Hey, hello everyone. Welcome to DevOps India conference. And we have amazing conference lineup for you. We have amazing speakers. Make sure to join Group Daily Community Discord channel, and you can chat with all the attendees or speaker if you have any questions. And do respect all the speakers and attendees. Don't spam on the chat section and we will post all the announcement and links in the chat section so you will get updated. So I would like to welcome Dewan from RedHat. So he will be speaking as a first session and everything in description, all the details, topic, and over to you, Dewan. Hey, welcome.
Good morning, India, and thanks, Sangam, for the intro. So let me start by sharing the screen first, and please let me know if you can see my screen in a second. Do you see the screen? I'm going full screen. Awesome. So thank you for joining this session. Deploy N applications to N clusters using Argo CD application set. My name is Dewan Ahmed. I'm a developer advocate at Red Hat. I'm based out of New Brunswick in the beautiful Atlantic region of Canada, where right now it's 1:36 a.m. So it's a very quiet night, but I'm sure it's a very busy morning in India, or not. Probably it's a Saturday morning, so probably less busy. So I love everything cloud native with a focus on DevOps and GitOps tools. Besides work, I like to play pool and ping pong, and I'm also a freelance career coach. So for those of you who are students, new grads, who are looking to get into tech and need any career advice or want a free resume review, please let me know. Connect with me either on Twitter or LinkedIn. I'm mostly active on LinkedIn, and I can see how I can help you out there. All right, in terms of agenda, we have a packed agenda today. Starting with the concept of GitOps, we'll touch on Argo CD. The session focuses mostly on application set, which is a sub-project of Argo CD. But considering that a lot of folks might not have heard about Argo CD before, I'll touch on Argo CD as well. The most favorite parts are demos and Q&A. So we're going to have demos for both Argo CD and Argo CD application set. And at the end, we'll have time for question and answer. So before I go further into the slides, you can see on the left corner, on the bottom right corner of your screen, a link to a GitHub repository. Now, that repository has the lab for Kubernetes environment. The demo I'll be showing, which will be using OpenShift environment, but you can use either or. You can use either OpenShift. If you don't have access to an OpenShift cluster, you can use vanilla Kubernetes cluster. If you're watching this video on your mobile device, you can scan the QR code right there, and that will take you to this repository right here. Now, this is the demo repository, which is based on Kubernetes environment. So all you need to do is just follow this guide on your own time, and you can do the demo on Argo CD and application set. At the bottom of this repository, I have added all the resources that would get you started, starting with Argo CD's GitHub, the read the docs, application set, and some nice blogs and videos as well. All right, so coming back to the presentation. Now, GitOps in one slide, like what is even GitOps? Now, the term GitOps was coined by Alexis Richardson, the CEO of Weaveworks. And when he first shared this term with one of his friend, he ran by this term. His friend thought that this is the ugliest thing he has heard, and now he can't unhear it. And now imagining Alexis, he was trying to find a term which is easy to pronounce, but also difficult to forget. So he knew, he found the exact perfect term, GitOps. So there comes the terminology, GitOps. Now, this particular GitOps in one slide, this is from Luis Facira. He's beautifully summarized GitOps in one slide. So let's see what GitOps is about in a single slide. So for GitOps, we understand we use Git as the single source of truth of a system. That means not our cluster, not any other environments. We use Git as the single source of truth. Second, we use Git as the single place where we operate. That means we don't kubectl directly on the cluster. Rather than we use Git to do create, update, destroy environments or resources. And finally, all these changes that you or your team members are making would be observable and verifiable as well. So that's GitOps in one slide. Now, let's understand GitOps, or scratch that. Let's understand GitOps for Kubernetes. So what does Kubernetes gives us? Now, the Kubernetes API server accepts a declaration as an input and then continuously tries to drive the cluster to the state described in that declaration. Kubernetes update provides a mechanism or the process of applying a set of changes described in that declaration in an automated fashion. Now, in terms of convergence, Kubernetes will keep trying to update until it succeeds. For idempotency, it means multiple applications of convergence will have the same outcome. That means no matter how many times you do kubectl command, the outcome will be the same for multiple applications. And finally, the determinism tells us that assuming you have adequate resources, the updated cluster state depends on the desired state. So considering those in mind, we should avoid kubectl, that means kubectl commands directly onto the cluster, or a bunch of scripts to do deployment. Even worse, a bunch of kubectl commands bunched into one single script, or a bunch of scripts for one single kubectl command, any of those variations. So if we consider all the points what Kubernetes gives us, what does GitOps for Kubernetes gives us? So it gives us correctness. That means a group of updates may be applied, converged, and finally validated, which gets us closer to the goal of atomic deployment. By contrast, if you apply a bunch of scripts, there is no guarantee of convergence. In the topic of security, I'll quote Kelsey Hightower, who said, limit the scope of access to a Kubernetes cluster to automation tools and cluster administrators who may have to debug it or keep it running. And finally, for developer experience, kubectl exposes the machinery of Kubernetes object model, which is quite complex. So ideally, user should interact with the system at a higher level of abstraction. That's what tools like the GitOps tools, which I'll talk more about, gives that this nice layer of abstraction. So based on our discussion so far, these are the parts or bill of materials, if I may, that we need to build GitOps on Kubernetes. First, we need the Git repos. Of course, we need the Git repos. We also need Kubernetes cluster where we'll deploy our application. We also might need manifest generation tool, although this is optional. Tools like Customize for your different environments like dev, pre-prod, prod. We also need a CI tool. Now, don't use a CI server to orchestrate direct updates to Kubernetes as a set of CI jobs. Your CI not equals to CD. In the resources of that GitHub repo, which I showed at the beginning of the presentation, I added a block which goes much more in details why using a CI server to do your CD is an anti-pattern and should be avoided. So feel free to look into that blog. And finally, the last point is you have to have a way of grouping the Kubernetes resources. That means your typical deployment services and etc. So introducing Argo CD. What is Argo CD? Argo CD is a declarative open source tool, open source GitOps tool for Kubernetes. It's based, it is part of an open source project, and lots of companies and individual contributors have contributed to this project. Now, the concept is pretty simple. As you can see on the diagram here, Argo CD is sitting right in the middle. It's watching over a Git repository or repositories and making sure the cluster state is the same as declared in the Git repositories. Now, why we should consider Argo CD, right, for our deployment? I think the first 3 points we have described previously, like using it as the single source of truth, being a developer-centric. That means you don't have to do kubectl commands as much, rather than making changes on Git, which as a developer we're very familiar with. Declarative, that means rather than scripting in an imperative fashion, you're saying that that's how I want my setup, my configuration, my clusters, and Kubernetes makes sure that it achieves those states. But let's start with security compliance and auditing. Now, in terms of authentication, Argo CD provides you a single sign-on based on OIDC, OAuth2, social logins. In terms of authorization, Argo CD provides some multi-tenancy and RBAC policies, and also audit trails for application events and API calls. That was the third point where we mentioned that the changes should be observable and auditable as well. Now, Argo CD also trivializes rollback. That means if you want to go back to any previous point of deployment, that is just a commit, the specific commit on your application configuration repository, and you can go back to any point in past from your Argo CD CLI or from the Argo CD UI. Argo CD app diff, that command performs a diff against the target and the live state. And that's the observability. And this can also be seen on the UI. And you can see that more when we demo the Argo CD part of the demo. So all of these points you can imagine improves the velocity of the team's application deployment. It doesn't have to be Argo CD per se, but any tool that achieves these features using Git as the single source of truth. Git is the place where you do create, update, delete all your resources, and the changes you're making are auditable and verifiable. These are sort of a recipe of doing GitOps for Kubernetes. So let's look at how Argo CD works. Argo CD is implemented as a Kubernetes controller, which continuously monitors your running applications and compares the current live state against the desired target state. So as you can see, there's a persona, which is a developer. After the PR merges, it triggers a webhook event that tells Argo CD that there was a change, and it tries to achieve that change, that desired state on the cluster. The triangle box on the right here, the API server is a gRPC and REST server, which exposes the API, and the API is consumed by either the UI or CLI or even the CI/CD system. At the bottom of the screen, you can see sync hooks, app actions. Now, synchronization can be configured using resource hooks. And you can think of hooks that can run scripts before, during, or after a sync operation. So for example, one particular use case would be if you have a rather complex deployment that goes beyond the typical Kubernetes rolling update strategy, you can have a script run either during or after the sync operation. And then at the bottom right corner, it's pretty self-explanatory. Your application could be deployed to multiple clusters. So this is in a nutshell the architectural diagram, or how Kubernetes, I mean Argo CD works. All right, so enough talking. Let's get some demo working. So we'll start with Argo CD demo. So here I have an OpenShift cluster, and let me see. I have an OpenShift cluster, but you don't have to use OpenShift. If you want to use vanilla Kubernetes, you can follow the guide which I added in the GitHub repository. So I'm starting with installation of the operator, and the specific operator is OpenShift GitOps operator, which bundles Argo CD and the sub-project application set together. So here we're going through the installation process. It installs in all the namespaces, which is project in the OpenShift world. Namespace and project are similar. And this is the customized app which I'm installing on that cluster. So I'm adding the prefix DevOps India. These are the resources. I have a deployment file, I have a service file, and I have a route file. The route is a custom resource specifically for OpenShift, which you can think of such as an ingress. So we have a single replica. This is the specific image, is just basically an Nginx image that I'm using. There's the service file. So this is my the Kubernetes manifest files on this repo under customize-nginx. So while we're watching that, the operator got installed, and the operator installs on one specific project, which is OpenShift GitOps project. Now, what Red Hat OpenShift GitOps operator gives you is out of the box. It creates that namespace, OpenShift GitOps, and it also gives you out-of-the-box instance. So you have an instance of Argo CD, and you also have an instance of application set, which are the controllers running in that namespace. So what I'm doing here is I'm getting the Argo CD admin password, and you can see I could, I'm going to the Argo CD server, which the pod hasn't gone up yet. And I'm switching to the developer perspective to see if the pod is going up, has gone up or not. So here I can see that the specific pod is not ready, OpenShift GitOps server or the Argo CD server. The solid blue circle will mean that the pod is up. So it's still not solid blue yet. We'll wait a few seconds for that to be up. So while that is up, I can show you two more pods that are running, and the one that is CAM, you can see I'm not covering that in today's demo. That is GitOps Application Manager. That's a CLI tool that gives you some more of a opinionated way of starting your GitOps journey. So the server is up, and in a second you can see your familiar Argo CD server UI. I use the password which I copied before to sign into that cluster. So going back to the installed operator, I'm using OpenShift console to create an Argo CD application. You could use Argo CD UI to create this application as well. If this seems fast, the session is recorded. You can always go back and rewatch, and you can also follow the repository which I showed that is based on vanilla Kubernetes. So here I'm giving the application a name. This is the Argo CD application. I'm giving a namespace. Typically, you won't be deploying in the same namespace where you're installing the operator. If you're deploying on a different namespace, all you have to do is create the namespace in advance and have OpenShift GitOps manage that. But that's not what I'm showing here. I'm showing it installing on the same namespace. I'm specifying the specific server. So this is on the same server where my operator is installed. That's why it's the inbuilt Kubernetes service as the cluster. For sync policy, uh, I'm saying it's automated sync policy. That means when I create the application, it should automatically sync the Git state with the cluster state. And these two checkboxes, prune and self field. Prune means that if the resource are no longer part of the Git, which is in the cluster, feel free to delete those resources. And self mean that if some malicious person is making direct changes on the cluster, Argo CD will self-heal and not show your app out of sync. It'll just revert those changes. So those are those two of the flags. So once I have added all this, I'm creating the application. This is the Argo CD application. Going back to the Argo CD UI, I can see that the application has been created. I can open the filter and I can see that the specific service, the deployments, and other resources have been created. If you can see on the right-hand side of your screen, there is a single pod. That's because in the number of replicas, we specified only one pod. So here I'm showing on line number 6 for the deployment file. It's a single, and you can see the customized prefix DevOps India being added to all the resources that were created. So now you can see that the route is a specific custom resource specifically for OpenShift. You can think as the ingress for Kubernetes. That route was created as well. But if you're doing this lab for Kubernetes, you won't have that route, and you have to configure ingress instead. So I'm not following the typical standard PR process. I'm just committing directly into the main branch. I'm just updating the number of replicas and see how Argo CD reacts to that. So I wasn't in the original repository. So I'm switching tab here to sign into that repository. So going to that repository and finding that file, the deployment file, and let's make change. But let me sign in first. All right, so let's try now. All right, number of replicas is 3. Commit directly to main. Committing into main is always fun, although not advisable. All right, so once we did that push, if I refresh, see where I hover. Right now, the app shows it's out of sync because there was a change from the Git state to the state on the cluster. And as soon as it's realized the auto sync is on, so you can see that the number of pods are gone from 1 to 3. So that's the ideal GitOps workflow, where you make changes in your GitHub or any Git repo and see the reflection on the cluster. So here's what I was mentioning about the diff, the app diff, your live manifest and the desired manifest. You can see if there is any diff. So since my app is in sync, that means there is no diff. You can also see events. You can go to specific pods and you can see pod events. You can also see pod logs in much more details. And I can delete my application directly from the OpenShift console. So that's in a very quick way, Argo CD demo. And that is all good and nice. But what if you want to deploy your applications to multiple Kubernetes cluster all at once? Or what if you're trying to deploy multiple Argo CD applications from a single mono repo? Now, typical Argo CD setup will mean that you need to have multiple Argo CD applications to do so. So introducing Argo CD application set. Unlike Argo CD application resource, which deploy resources from a single Git repository to a single destination cluster or namespace, application set uses templated automation to create, modify, and manage multiple Argo CD applications simultaneously, targeting multiple destination cluster or namespaces. Here on the left-hand side, you can see the application set controller is installed alongside Argo CD. That means Argo CD has to be installed before on the same namespace. And it automatically generates Argo CD applications based on the contents of a new application CR. So if you see on the right-hand side on this YAML, number 2, the kind is application set. But if you see line number 17 and onwards under the template is just an Argo CD application, but in a templated fashion. So in this example, the list generator passes the URL and the cluster field. So you can see the cluster and the URL field into the application template as parameters, which are then rendered into the template as 3 corresponding Argo CD applications. So 1 for each of the defined cluster: engineering dev, engineering prod, and finance prod. Targeting new cluster is simply a matter of adding new elements to the application set resource, and to the corresponding Argo CD applications will be automatically be created. Now, this is an example of list generator, and Argo CD has multiple generators. Now, before going into the other types of generators, how does application set controller work? Now, the sole responsibility of applications and controller is to create, update, and delete application resources within the Argo CD namespace. And the controller's only job is to ensure that application resources remain consistent with the defined declarative application set resources, nothing more. So that means the application set controller does not create, modify, or delete Kubernetes resources other than the application custom resource, does not connect to clusters other than the one where Argo CD is deployed to. That means if you want to add Argo CD, add clusters, you have to do that using like Argo CD cluster add command. Argo CD application set also does not interact with namespaces other than the one Argo CD is deployed within. So it's Argo CD which is responsible for the actual deployment of the generated child application resources, such as deployment services, config maps, etc. The application set controller can thus be thought as an application factory, taking an application set resource as an input and outputting one or more Argo CD application resources. So these are the application set generator. So list generator, cluster generator, and git generator directory or file was there before. In a very, very latest release, I think last week or one before that, 3 more generators were introduced: matrix generator, SCM provider, and cluster decision resource generators. And I added the links to each. So for example, if you go here, you can see the read the docs for list generator, and that goes in much more details. So I think we need one more demo because we had enough dose of theory. So let's look at application set controller demo. Let's see, application set demo. Okay. So here I have application set as I was showing the list generator. And I have 2 clusters. One is engineering dev and one is engineering prod. Now, what I did was before the demo, I added these 2. I added the cluster. Like one is the built-in cluster, which is showing as Kubernetes default service, and the other is this cluster, which I'm showing on the screen right now. So I added using Argo CD cluster add. So these 2 clusters, the inbuilt cluster is already there. I added the second cluster. And then under the spec source, this is where my my application set is. And I can see the examples, list generators, guestbook, and / you can see the templated cluster parameters. So for each of these cluster, there will be one Argo CD application custom resource generated. So I'm creating application set CR or custom resource from OpenShift console. And I can see that in my applications, I don't have any application yet. So what I'm trying to do is I'm trying to create 2 applications in different clusters using one custom resource. So when I invoke the command kubectl apply, I can see that those 2 applications were created. And this could be n number of applications. I have manual sync, so the applications didn't sync automatically. So I had to manually sync. Once I synced, I could see that for the in cluster where the application Argo CD was deployed, it is healthy and synced. For the remote cluster, the sync failed because the namespace was not found. That means Argo CD doesn't have permission to create namespace on the remote cluster. So I had to go to that remote cluster, create the namespace, and let's try to sync. And that's the comment I've added in the GitHub repository as well. When you're trying to follow that lab yourself, create the namespace beforehand before you're creating the custom resource. So once I created that namespace and tried to sync, the application synced perfectly. And I can see the deployment, the services, and other resources being created. Both apps are healthy. So let's say someone got adventurous and trying to delete your application from the cluster. So let's try that. So I'll try to delete the application. Application will try to go out of sync because the Git didn't say that your application won't be there. So there's a diff in the states. But because your application were created using the application set controller, application set will recreate the application. So although I'm making the change from the cluster, the application set is preventing that change to happen. And that is pretty powerful. If someone tries to make a change, because you created it in a declarative way, your resources are again being created. So that's the application set list generator example. But in my demo for the lab, I have shown three examples for the Git generator and the matrix generator as well. And a quick glance is here on our vanilla Kubernetes cluster, I have 6 applications deployed in 2 different clusters. That's using the matrix generator. So coming back to the presentation, we covered a lot of items in a short time. We covered the basic of GitOps, the challenges of GitOps for Kubernetes. We covered Argo CD application set, and covered 2 demos. There's also this GitHub repository, which you can follow on your own on a vanilla Kubernetes cluster, and I have added all the resources for you. If you have any questions, I'll appreciate if you ask in the appropriate channels or reach out to me on Twitter or LinkedIn. I'll always appreciate feedback, and please let me know what you liked and what you didn't like on this session. And thank you again for joining this session, and I wish you happy learning during DevOps India conference. Thank you. Back to you, Sangam.
Yeah, we have one question from audience.
For sure.
Yeah, I have posted on chat, so you can check. How does application set controller to authentication to multiple K-Tasker state define under the elements? So that is one of our questions.
That is a good question. So as I was saying, that application set controller actually does not handle authentication. So your authentication is handled by Argo CD. And if you're talking about authentication from the point of an ops person, that ops person has a single authentication from to the Argo CD API server. So once you authenticate to the Argo CD API server, whether using open source Argo CD or using OpenShift GitOps, you can create n number of application to n number of cluster. So the auth n and auth z, authentication and authorization, happens once, but the relation is 1 to n. It's not n to n for number of authentication for a number of application clusters.
Yeah, so we will share the GitHub link in the Discord and as well as in the YouTube chat section, so you can take a look. There is whole lab is there prepared for you, so you can go there and you can self learn and practice. If you have any question, chat with Dewan at Discord channel. He is available there, so you
And
can
and
ask
uh, and other
questions.
thing they could do is on the Argos, both Argos CD and Argos CD application set. I think they are on the CNCF Slack channels. It's completely open source. So if you're trying out this lab,
Yeah,
let's say for Argos CD or application set, rather than private messaging me, I think if you take the conversation to the open source Slack channel, we all could
yeah.
contribute and learn from each other.
Yeah, definitely. You can reach out on the CNCF Slack. There is an official Argo CD project, and you can reach out any kind of question not related to only OpenShift or any kind of you want to learn material. You can ask there. CNCF is a very big community, and you can go and talk officially to the contributor or contribute a doc also. So thank Diwan is wonderful session. And I have learned too much, and there are like so many good questions. I will share the links with the community, and we have the next session by Ramiro. So Ramiro will be joining in the minute. Hey, welcome Ramiro.
Hey, Sangam, how are you? Very
I'm
excited to be
fine.
here.
Yeah, I'm excited to learn about Okteto and Kubebuilder. Can you share your screen?
Excellent. Yeah, let's get to it. Share screen. And we'll share. Yeah, let's just share the whole thing. All right. So, Sangam, can you confirm that everyone can see the slides?
Yes, it's visible.
Excellent. Well, hi, everyone. Thanks for joining. Sangam, once again, thank you for inviting me to this conference. Always fun to talk to you, to your community, and to everyone on the Cube Daily Discord. So today, I'm going to be talking about how to build Kubernetes operators and how you can use Kubebuilder and Okteto, two open source projects, to help you build these operators. So first, let me introduce myself. My name is Ramiro. I am the founder and CEO of Okteto. Okteto is a startup that builds tools to help you move your development to your Kubernetes clusters. I was born in Mexico, in Guadalajara, but I currently live in Oakland, California. I'm a big fan of everything cloud native development, dev experience, open source, and as you'll see on my slides, I have a soft spot on my heart for emojis. And you can find me on ramiroberrelleza.com. I'll share the links after the talk if you want to connect later, if you want to talk more about cloud native development, Okteto, or anything else. I'm also pretty active on Twitter, so you can find me there as well. So let's get to it. If you're new to Kubernetes, if you're new to cloud native development, and you see the title of this talk, probably the first question that comes to your mind is, okay, what is a Kubernetes operator? What is this thing? So this is kind of like the official definition of what an operator is. And you can think of an operator as a software extension for Kubernetes, so that you can create custom resources to manage your applications and your components. They're called operators because there's a metaphor to how before you have someone, like a human, installing and configuring something on a cluster, and now you can codify that on your operator so that you can do it automatically instead of depending on a human. Operators follow all the Kubernetes principles, especially the control loop. And understanding the control loop is fundamental when you're building operators. I'll talk about it here, but just kind of keep that in mind. And this is a very simplified version of what the operator loop looks like. When you're thinking of Kubernetes and when you're thinking about operators, it's all about this loop. The idea is that Kubernetes in general and your operators pretty much do two things all the time. First, they are observing the world. They're always checking, okay, what is the state of things? If you think of deployments, if you think of configuration maps, If you think of your own custom resources with operators, it's all the same. The operator will observe the world and check the state, compare the state with the user declared state, and if it doesn't match, it will take an action. That is the entire thing operators do. It's super simple, it's very elegant, but as you'll see, it's extremely powerful. But at a high level, this is what it does. And operators are very broadly used in Kubernetes. You might not know that you're using an operator, but if you look at things, if you use things like Search Manager, the Elasticsearch operator, Litmus Cows, Argo, the one was talking about it in a previous talk, Flux, Crossplane, and many more, they all heavily use operators. If you want to kind of like see what else is out there, I highly recommend that you go to operatorhub.io and see like all the things that are there. But today, I'm going to show you how to build one. So let's kind of like keep going. So as you recall, we talk about operators, we talk about components, and then we mentioned custom resource descriptions. As they are known in kind of like the Kubernetes lingo, CRDs. But what are they? Well, we know that a resource is the manifestation of an API object on Kubernetes. A deployment is a resource. A stateful set is a resource. A configuration map, a job. A custom resource is the same thing, but it's the ones that we create. To kind of go back to that list I showed you before, Cert Manager creates custom resources for certificates, certificate requests. Crossplane creates CRDs for things like their abstractions, their offerings, things like that. You just think of this as kind of how you customize and create your own types. Like if you're coding in Java and you have your own types, in Go and you have your own structs. Well, in Kubernetes, when you're building an operator, you have your own custom resources, and they're called CRDs. And like everything else in the world of Kubernetes, it's described in Java files. By the way, as you get into operators and into CRDs, highly recommend you go to doc.crds.dev. It's this really cool open source project created by Dan from Crossplane. If Dan's seen this, hey Dan, if you see him online, say hi to him. He's a great guy and a big force behind CRDs in Kubernetes. And what this tool does is it lets you kind of like document and see what a CRD is in a very easy kind of like UI, kind of click-based UI. It's very similar. If you've used something like Swagger before for APIs, it's very similar, but for CRDs. So highly recommend. You don't need it, but as you get deeper into CRDs, as you get more and more into trying to figure out how CRDs work, this is a great place to be at. All right, so enough with the kind of like the class, the theory. Let's get to the demo. So we already talked about operators. We already talked about CRDs. So now we're going to talk about two open source projects that makes our lives a lot easier when building an operator. First, Kubebuilder, and then Okteto. Kubebuilder is a CLI that allows you to create all the scaffold you need to create an operator. Instead of doing everything by hand, you just run Kubebuilder in it, and it creates everything you need. Whenever you want to, it creates a make file, your Docker file, all the Go code you need, all that stuff, and I'll show you briefly. Okteto, on the other side, is a CLI that allows you to move your development from your IDE to the cluster. This has a lot of uses, but particularly for operators, it's really cool because it allows you to develop your operators directly in Kubernetes, so that as you write code, you can see the effect of that code immediately, instead of having to wait and build images every time you want to test a change. But I'll show you in a demo. If you want to follow along, or if you want to kind of try this on your own after this talk, I put all the code on GitHub. It's right there. I'm actually going to be showing you this straight out of GitHub code spaces, so it's super easy to kind of get started. And we're going to have some time at the end for questions. So if you have any questions, please put them on the chat, on Discord, on YouTube, and Sangam and I will get to them at the end of this talk. All right. So first, what I did for this talk, and let's go back here, is I have a GitHub repo. And If you haven't used GitHub Codespaces before, I highly recommend you do. It's a really cool, easy way to contain your dependencies on a container and to just develop straight out of GitHub. I create this repo. I have my dev container defined with all my dependencies. And all you have to do is click on this code button and click on Codespaces. In this case, I deployed mine before, but it's right here. And a Codespace is, you can think of it as kind of a virtual machine that's running on GitHub's infrastructure, but it's a container. So you can have a Docker file and add all your dependencies. So in this case, I create this Docker file that has Go, that has kubectl pre-installed, Helm, customize, the Okteto CLI, Kubebuilder, and the Civo CLI. If you don't know, Civo is a Kubernetes provider. They give you K3s as a service. If you're building things in Kubernetes, check them out. It's a super easy way to deploy clusters, as fast, as cheap, has a pretty robust free tier, so check it out. Especially when you're building operators, you do need like a full Kubernetes cluster. For that, I recommend Civo. For other things, there are offerings, but this is how my code space looks. At the end, I'm using one of Okteto's dev images that we pre-created with Golang and all the dev tools installed. But what's cool is that you see this is a normal Docker file. Anybody that starts this code space is going to get this Docker file, and everything is installed here. If I do something like, hey, kubectl, see, now it's installed. Everything is there. So Codespace is a really cool way, especially when you're building open source projects, as a way to make it super easy for everybody else to join your project, because they don't have to tinker with things like, okay, where is everything installed and things like that. So for this demo, we already have Kubebuilder pre-installed. So let me close this, and I'm going to open a bigger terminal. This is one of my favorite features with VS Code, which is that now you can add a terminal at the file editor level, so you have like the full length and width of the editor for your terminal. Really, really cool. So anyway, we're here. So the first thing you do, like any other project, we're going to be using Go for this operator, is run go mod init. I already ran this before, but here's the command. And in this case, it already exists, and it's a very standard Go mode. All it does is create the module name, and in this case, I'm using Go 117. All right, so now, this is where the fun kind of starts.
Can you a little bit like increase font size?
Good idea. How's that?
Yeah, a little bit, I think.
Okay. What do you think about now, Sangam?
Yeah, I think it's. I will make a full screen, so it will be easy.
All right, there we go. All right, so whenever you have a new project, okay, let me show you. Okay, there we go. Whenever you have a new project, the first thing you have to run is this kubebuilder init command. It takes very few parameters. In this case, it takes the version of the plugin. I'm using the latest, which is v3. A domain, which for this case, I'm going to use example.org, but you can use whatever you want. The owner name, which is my name. And in this case, because I'm using Go 117, which is not officially supported by Kubebuilder, I'm going to pass this parameter. Kubebuilder is a CLI, single binary, you can download from GitHub and install on any machine. In this case, I have it pre-installed on my code space. So you click enter. What happens now is that Kubebuilder is going to download all the dependencies that you need to create your controller, your operator. It's going to create all the initial files, all those things. So it's going to take a few seconds. It's downloading all these dependencies. You only have to run this once per operator. Once everything is downloaded, you're going to have a Go mod, a Go log, and a bunch of Go files. Like it's running, and if you see here, you see how these things are starting to appear on your repo. This is all the things that the Kubebuilder is building for you. So now let's go back here. It says, okay, your project has been initialized, and it says next. You have to define a resource with the command Kubebuilder create API. And this is the core command of Kubebuilder. This is where you create your actual API that you're going to use to react to something. So for today, since we're in a conference, let's say that we're going to build a operator to manage the talks that you have on your conference. You know, this is a conference about cloud native stuff. So why don't we use a cloud native service to manage all of our conferences? And it's kind of a small demo, kind of trivial, but it's a good way to kind of understand the different pieces of an operator without getting like super deep into like code and implementation. So let's go with that. So I'm gonna clear my screen. I have it here. So when you create an API, there's 3 things you have to specify. The group name, in this case it's conference, but it can be anything you want. It has to be unique to a cluster, so I recommend use something that's really unique. Don't do something like boo, like foo or bar, things like that. Version, I like to start with beta as I iterate until I get to 1. And then kind is the name of the resource. In this case, because we're tracking talks, I'm going to call my resource my kind talk. This is very similar to like when you're using deployments. You know, the deployments come from V1, from core, from extensions, things like that. It's really the same. And we're going to press enter. Oh, I have a space or something. I'm missing a dash. There we go. One of my favorite things about live demos is that we all learn together and finding things and iterating to them as we think. So when you create your API, Kubebuilder is going to ask you, hey, do you want to create a resource? What Kubebuilder is asking us is if we need a custom resource for our operator. And in this case, we're going to click yes. It's not always the case, but in this case, I'm going to show you what you can do with CRDs. So we're going to tell that, yes, we need it. Then it's going to ask you, do you need a controller? This is where the code is going to actually run. And you say, yes, I do need a controller because I'm going to be implementing some logic. And then something broke. Okay. I probably have a, oh yeah, I have a missing my V1 here. If you see the error, it says version must match V, and then a number, and then it can be alpha and beta, and then something else. I forgot B here. So we're going to run the command again. And just as we did for the init command, now Kubebuilder is going to create the scaffolding for our type, for our controller, and download all the Go dependencies. In this case, I'm using Go. Kubebuilder supports other things. You can use Java. You can use Helm charts if you want, but I do recommend Go. It's the one that has the best support. And you know, most things in Kubernetes land are in Go, so it's a good language to pick. All right. So now, if you look here, you see that 38 files have been created. This is part of the beauty of Kubebuilder. I didn't have to create all those files. And if you look here, let me go to like this Explorer view. You see now that I have my API, I have config files, I have a bunch of YAML, integration with Prometheus, anything you want. And this is where Kubebuilder starts to save us a lot of time because we don't have to build any of these things. In reality, this is one of the very few things we have to look at is just the types and a few other things. So just to kind of show you what Kubebuilder is doing, let's look at this. Anything under API is where you're going to modify things. This is where our type is specified. It says, hey, there's a resource called talk. It has a spec called talkSpec. It has a property called foo. And you can see here, there's even a comment saying, hey, foo is an example of the field talk. Edit this to remove an update. Okay, so instead of foo, we're going to say, hey, it's a talk. It has a title. And you know, we're following the syntax. And it has a speaker. And we're going to remove this and this. And you see here, it says, hey, and then you have to run make to generate the code after modifying this. This is something else that Kubebuilder is doing for us. It creates a makefile with all the common commands we need so that we don't have to worry about doing all these things by hand. So I'm going to save this. I'm going to go back to Bash. And I cancel this. I'm going to say clear. Okay, let's save this again. And we're going to run make as we were told. What make is doing is going to build our binary, it's going to format our code, it's going to do everything we need to get our code validated. And then if you look at all these other things like the generated code, you'll see that Kubebuilder is generating everything for us. So if we kind of go deep here into these files that you're not supposed to modify, you'll find that all these parameters are now being applied, the CRDs are being updated, all those things. So it's here. You have everything now running. And for instance, if we go here to sample talk, no, that's not the right one. If we go to the code generation on CRD here you'll see that now these values have been applied. So now that we have here, now that we have kind of like the basic scaffolding of our CRD and operator, let's just deploy it. That's another command that Kubebuilder gives you that is super easy. First thing is we're going to create the image. In this case, I have this command and another command done by Kubebuilder. It's going to like build an image, push it to my personal Docker registry. This is the image we're going to be using for the controller. And you see it's going to build everything we need. It's going to get the tool, it's going to create all the stuff, build the image, and push it to Docker. Once again, this is one of what I really like about Kubebuilder is that if you were doing all these things by hand, it would take a long time. And you have plenty mistakes and non-standard stuff. So again, it's what the beauty is as you're building operators is they do most of these things for you. So it says that, hey, I cannot connect to Docker. Is a Docker daemon running? Well, maybe it's not. Let's see what's going on here. Docker. You know what happened? I forgot to install Docker on my code space. So I'm going to quickly run it locally instead so that the image is there. Okay. Anyway, in the meantime, as I build this, let's go back here. When you look here, you'll see there's all these different things, right? API is kind of the first thing, and that's what really where you define your types. Just like as I mentioned, in this case, we have our top type. This is what we're going to be using. But here, controller is the other part of our operator. This is the part where you're going to implement your logic. If you see here, for instance, Kubebuilder automatically created this file for me. It's already imported my types. In this case, it's conference B1 beta 1. And you look at this, there's a lot of things here, but what matters is this. This is the reconciliator I was talking about in the previous slides. This is where you're going to implement all the logic you want to reconcile the current state of your cluster with the desired state. So pretty much what you're going to do here, what a typical operator looks like, and if we go back here, you remember this loop is something like this, is, okay, get the current object, try to find it, create it, find it, then get the required Kubernetes resources, and then return a result. And a result, there's two options. You either return success, say, hey, everything is up and running, good to go, or you return an error. And the result object allows you to return an error and then tell Kubernetes, hey, I'm going to return an error and stop trying because there's something wrong with the request, with the code, whatever. Or, hey, this is a temporary error, wait and try again. And this loop is going to be running all the time. As I show you here, this is running all the time. So here you're going to implement something like this, and I'm going to do it right now because we're kind of running out of time. But I'll share the link, and everything will be there, so you can check it out later. But this is kind of like the core idea with Kubebuilder. Once you build your image, you have commands, and I'll share this as well. There's a command for building, there's a command for deploying, and once it's running, you just do kubectl apply crd and see what happens. Even in this case, if you look at the CRDs folder, the samples folder, oh, there we go. You'll see that there is already a CRD created for me with top list, all those things that I can add to my cluster. And then it even created a sample for you where you can create something. So let's say, hey, my talk, if you remember here, we added speaker, Berrelleza, and a title, I think it was. If we go back here, we can see the reference and say, hey, you see all the properties are here, the whole thing that we need, but let's go see it on the code. Title and speaker. All right, so we go not this one, but this one. Title and speaker, and in this case is built-in operators with Kubebuilder and look at this normal talk. So now let's use an operator. I'm going to go back to Bash. So in this case, for this talk, I pre-created a cluster using Civo, as I mentioned before. Basically going crazy. Civo, Kubernetes LS. I'm using a Civo CLI. I highly recommend go to civo.com. I'm friends with them. They're a really cool company. They're super helpful, and they have a very robust free tier, so check them out. In this case, we're going to do is say Kubernetes. And then I think it's config. I'm going to download my config. Yes, I want to run my default config. Let's see if it works. And because I'm using a code space where everything is pre-installed, I don't have to install any of these tools. So everything is there, right? Looks good. Now let's first install our CRDs, which let's CRD. It's here. Copy that. And you'll see that now the CRD is installed in my cluster. If I do get CRD, you'll see that now talks conferenceexample.org is there, which means that now I can create my talk. I'm going to go here. I'm going to copy the path. And just like any other Kubernetes resource, I can now create this. Create it. I now can do something like, hey, kubectl get talk. My talk is there. If I do this, you'll see that the speaker and title are there. In this case, a list. I can do something like give the name of the resource. And you see that now the talk is created. Now, if I wanted to do something more complex, like every time I schedule a talk, maybe record this on an S3 bucket somewhere else, or maybe create a config map where I'm going to hold all the details about this talk beyond the ones I described here, that is where the controller gets into the picture. I'm not going to deploy them today. When the final demo I'm going to share after the conference, we have it. But this is the idea with operators. It allows us to create custom resources, add custom logic to them. It's great when you're trying to build kind of building blocks, or when you're going to build some more complex logic, like what Search Manager does, or Crossplane, or Litmus Chaos. And they use all the other building blocks of Kubernetes, which means that you can use tools like Kubebuilder, kubectl, CRDs, and Okteto when you're building your operators. So just to kind of finalize, wrap this up, if you want to learn more about operators, I highly, highly recommend you check out the operator book. If you just go to kubernetes.io, you'll find it there. The link is here. As I mentioned before, docs.dev is great. Both Kubebuilder and Okteto are open source, so check them out. The links are there. And if you get into trouble, if you want to talk about operators, if you want to learn about how to use Okteto as you build operators, please join the Kubernetes Slack and go to Kubebuilder and the Okteto channels. We're all there, maintainers, users, and both have great communities with people who love to talk about all these things. So, and if you like any of these projects, as always, remember to give them a star on GitHub, because the stars, believe it or not, they're like a huge motivation to know that, hey, people are building things that other people enjoy, and it's a great way to show support without like using like any resources. And hey, I'll see you online. I'm gonna be speaking at DevX Days, which is part of KubeCon North America 2021. I'm gonna be there in Los Angeles, hopefully, but the talk will be available online as well. I'm gonna be talking about how to use Okteto to develop in the cluster, and we're also gonna be talking about preview environments. And Okteto, at Okteto, we are building a lot of content around Kubernetes, cloud-native applications, dev experience. If this is something that you're interested in learning more about, please subscribe to our channel. Just search for Okteto on our YouTube, or I'll share the link later. And finally, if you want to talk more, hey, let's connect. I'm very active on Twitter. Just search for Berrelleza on Twitter. I'll pop up. Search for Okteto. I'll pop up there as well. And happy to talk more about this, especially as you get deeper and deeper into this wonderful world of operators, Kubebuilder, and Kubernetes. And thank you very much. It was lovely to be here. As always, it's super great to be part of the Kube Daily community. And I'm looking forward to seeing the next talks. I hope this was useful. I hope you like it. If not, your feedback is always great. So thanks so much.
Yeah. So we have one question. We have one question. So question is, how does this approach, like example, using Kubebuilder plus Okteto different from Operator SDK?
Great question. Kubebuilder is built on top of the Operator SDK. So they were both kind of like separate things, but they're kind of like now building on top of each other. So what Okteto gives you on top of Kubebuilder is that instead of, how when I was demoing it, I had to build a container. It didn't work, but I had to build my Docker container locally and then push it. When you're using Kubebuilder and Okteto, you don't have to do that. You just write your code, run Okteto up, and see it there. But Kubebuilder and Operator SDK are pretty much the same thing these days. So you can use one or the other. I like Kubebuilder. I think it's a lot more like dev-friendly than Operator SDK, but it has most of the capabilities and everything is there. If you need something from Operator SDK, you can dig deep into the code and it's there.
Also, make sure we have a Okteto Bangalore meetup. So if you want to share anything.
Good point. Yeah,
sure
that's something that we please join. Sangam started Okteto Bangalore, has a bunch of people. We've done a lot of events, and we're going to be doing some more things later this year as more events come online.
Let me know if anybody want to contribute or speak around Okteto, and if you build something cool thing around Okteto, or you want to deploy some of your application, you want to showcase, so reach me out and we'll schedule an event for you.
And one more thing, at Okteto we have a blog and we have a program for external for like guest writers. So if anybody here is interested in writing about Kubernetes, cloud native development, or how you use operators, Okteto, all those things, reach out. Just go to okteto.com/tech-writers and check it out. We're always looking for new voices and other points of views. So it's a cool way. If you're interested, reach out.
It's a great demo. Little bit laggy demo because of code space, I think. It's a browser based.
I was kind of nervous. It was the first time I used code spaces for a demo, and it's cool, but I think it's still missing. But it's getting there.
Yeah.
But if you try it on your own, what I recommend people do is install the.
But this is cool way. I never used code space, but I will try.
Well, that's what I like. As I said, that's what I learned from Kelsey Hightower. When you do live demos, even if they don't work, it's great because we all learn together why it didn't work, what worked. Like in this case, my code space didn't have Docker on it, so that didn't allow me to build my container. But hey, that is part of the fun of this. We are learning together.
Yeah.
That's why Sangam is doing these events.
So this is like great demo. Thanks, Ramiro, for sharing a bunch of knowledge around Okteto. Okteto is free if you want to learn Kubernetes, create a cluster there. It's free of cost, and you can start your Kubernetes journey. So we have a next speaker, Carol from Aqua Security. She will be talking around security checklist in containers. Over to you, Carol. You can
Yes.
share a screen.
Hi, can you hear me well?
Yeah.
Yeah. Thanks, Sangam, for inviting me. I am very happy to be here. For me, it's night, but good morning for everyone in India. Okay, I will share my screen. One moment. I think now you. Okay. Well, I am very happy to be here. My first time in India time zone. As you can see, I am very blue here, but I will talk about security checklist for containers. My name is Carolina Valencia. I from Peru. I am in Latin America. Now I am in Peru. For me, it's midnight. But well, I work as solutions architect in Aqua, and I will share with you some checklists and how you take care about security. I will do next here. And as you can see, when we think in containers and in all these cloud native world like serverless and these new artifacts that we use in cloud native, we have to adapt the security. For example, in traditional security, maybe you only check the process and the VMs, but when you think in cloud native, you will talk about microservices, and the context is important. For example, if you have several services with a lot of communications and using several protocols like gRPC or REST, and you have to know more details about this kind of information and how is the context about this. So security also is different, and we're trying to doing better approach for using these technologies. And as you can imagine, this imagine represents the stack of cloud native. As you can see, if we talk about containers, we have a base image. This base image could be Alpine, Ubuntu, no? Is the first line that we put from Ubuntu, from Alpine. And after this, we built our applications, maybe installing some other libraries, like maybe it's Java, Python. And also you have the dependencies that you need to build your application. If it's your is JavaScript, maybe you install a Node and all the dependencies. And also, if this container will be deployed in some orchestrator as Kubernetes, or maybe containers as a service Fargate, or serverless. And also you have infrastructure as a code. And all these new kinds of artifacts, you could verify or try to use security in this new artifact that is part of this cloud native world. And also, I describe more the build process, but you also have the attacker that could be in any point of this, could be introduce some malware or some package with vulnerabilities. If you have some doubts, you also you put it there, and I will show for example, talking about containers, will be, we could see here a Docker file that will be built a image. And also, depending of the design of this Docker file, you could have some bad practice. For example, if you could use your user root, in this case is put in the user JBoss, but also you have a lot of other advices that you could find. And I will check here some tools that will help us with the basic checks. For example, I will move from here. As you can see, I can use, I hear a Docker file here that is the same Docker file that I show in my slide. And I could try to build this Docker file as a normal process when we use containers. And I could check this container. I will use 3 for this. That basically I will try to first to test the basic things about configurations, misconfigurations. I don't know if you noticed, but I have, for example, the root user. So, you could do the basic things that you could check if you are following the best practice only, applying these misconfigurations about the Docker file and other things. I can open here, for example, the advices that you could explain more how is about this misconfiguration in my Docker file. Here. For example, this is a device and the recommendation actions that you could understand more about this rule. Well, we talk about misconfigurations in Docker file, but also we could talk about the vulnerabilities. That is a main important part. When we build some image, we have to be knowledge about the vulnerabilities that we could find. And also using the tool tree, I could run the vulnerabilities in the image that I built, with my name, crawl, my Docker, and I could run this. And as you can see, I have many vulnerabilities, like 1,000. I could use filters to only try to prioritize the severity. For example, we could put only the severity that is high, only to have high or critical. And as you can see, here is 19 because I only try to prioritize the vulnerabilities that are critical for my application. Also, I don't know, but when we talk of vulnerabilities, these vulnerabilities could be from the operator systems. So you could try to maybe classify or try to see the vulnerabilities only for the type that will be the operating systems. And operating system that I am building this image is CentOS. And as you can see, the vulnerabilities of these operating systems that will be classified here. Also, you have the links about try to have more knowledge about this vulnerability. And also, you can find the operating systems or the libraries. That is a main component in the applications. I can put here libraries that you can, is basing in all the, in this case, it's a Java application. As you can see, we have many vulnerabilities, depends of the component. I can open some link that you can see more details about the vulnerability. how different is this about? This is the common vulnerability exposed, no, that it has a unique code, and some reference and the package that is affected, and then all the detailed informations you can find. And for this, I will go back for my presentations. I also, when we talk about Kubernetes, we also could have misconfigurations about these YAML files. And as you can see here, we have this image, and the attackers could use the several exposes points in the architecture about Kubernetes. For example, started from application that has many vulnerabilities, high vulnerabilities. This could be the first entry to try to expose the other components from Kubernetes. This is some examples of several attack vectors that may be using some older misconfigurations Kubernetes. You could do discovery in all the components of Kubernetes, like dashboard, API server, etc. And after this, you could do lateral movements or privilege escalations. But talking about misconfigurations, what can we do? Also, in this project that I have, as you can see, I have some manifest here that will be like common applications in Kubernetes that you have this manifest. And also I could, with 3V, I could search the configurations about the Docker file that already I talked, but also the misconfigurations about the manifest that we are using to deploy our applications. For example, here we have like several checklists that will help us to automatize this with some CI, if we put these controls. And for example, the image tag don't use the latest. That is like a low severity, but a nice good practice that maybe in the future try not to use latest and immutable tags. And you could have more explanations about this and the actions of the recommendations that you could use in each of these points. And talking about misconfigurations and all these manifests that we could use, also we talk about infrastructure as a code. Also, I can use 3V Pro to find misconfigurations in Terraform file that also is infrastructure as a code, other artifacts that we could check about the best practice. And with this, I want to do a resume about all these checklists. And I have this security checklist that, as you can see, is based in the tax security CNCF. And we talk, we have to take care in security in all the phases that we use the cloud native components and technologies. We talk more now about the build process that will be built an image, but we have other components like the container registry, the VMs, and several of these points. We could do it with these tools of static analysis like 3V or others that also I know that that exist. You could do the hardening in the image. That is the several good practice like already the tools could help us to automatize these controls. For example, privilege capabilities is easily that these tools like Trivi help us to validate these controls. For example, here immutability, don't use latest. Also, the tools will help us with that. If the image is using security profiles or not, also it will be some checklist that already this kind of tools help us. But we have other points like signing image that has related with software supply chain attack that is like a new field. No? How could you signing image and use inside of your enterprise? But the basic thing, I think you could start using some static tool like 3V or others that already exist in the market, and you can use this to have knowledge about the vulnerabilities that the image could have. That is the first stage. You have a knowledge about how are the vulnerabilities that your application that you are building. And other things also, your other components you have to take care, like container registry, that you could have set the best practice following dependent of what kind of register you are using. For example, you could following the best practice of Azure, the container runtime. Also, we have a lot of cases the attacks in misconfigurations about APR ports in Docker. It's important that you could take care about the configuration to avoid this kind of attacks. But well, you have like several points that you could think in if your organization is taking care. For example, secure the data. That is a main point about secrets. If you have embedded keys or important text inside of your Docker file. I will continue with the presentations to talk about more about the advanced attack that maybe these tools that I show will help us. But when we think in advanced attack, it's more difficult to try to find using static tools. So one of the main attacks that we can see in the wild, that means when you the security research try to find the common attacks that is really happening using containers or cloud native applications. You can see I like very much this Sonatype report. That, as you can see, the software supply chain attack is using a lot. And when we're thinking supply chain attack, could be any of these components or dependency that could be build our applications. As you can see, could be open source components, dependencies, libraries, vendors, third party. In any of these components could be embedded some malware. And how is the common attacks, as you can imagine? The first could be the typo squatting. That is a simple attack that you could change the name with some common word, famous word, as you can see here, this TensorFlow. But it's an easy mistake that any developer could do it, and it's a common error, common attack that you can observe in the cloud native space. Other kind of attack that you will see when we talk about supply chain attack is the dependency that maybe has related with the signing image. We have the CNCF are building some tools that help us with this kind of problem. For example, here, as you can see, this is a nice research by Alex Beerson. In red, you can see that these dependencies was a private dependencies. For example, this is out PayPal. All this was private. And the experiment was what happened if you create these same private libraries in some public registry of Node. What happened was that the components don't learn from the public instead of the private, and this could be you could embed it malware easily in this way. This is like some example that could be happening. It's related with the 0 days attacks, because with the static tools that I show, for example here, we only analyze the layers in a static way. But this kind of attacks, how can you search, or this kind of 0 days attack that is acknowledged, how can you be protected or be aware about this? So we have several cases that maybe we don't know. That's the important reasons that you try to be more that they care about how you are building your image. And here, only to try to understand more about how is an advanced attack. Here you can imagine that this malware will be only running in memory, and the static tool never will find this malware, because the malware is only happening is executed in the memory in the moment. So only when the container will run, this script could run a cron script to download some crypto miner, for example, or execute some rootkit. And this is kind of the common attacks that you could find. If you want to deeply have more understand this kind of attacks, I recommend the Aqua security research that they have a dedicated team that are studying this kind of attacks. We have a lot of reports that if somebody is from security, they really love the detail about how he's doing the scripts and everything. Also, if you have some doubts, please also put there. But in the resume, the kind of attacks that we observed in talking about cloud native is typo squatting, that is changing some letter, something with a famous image, and this easily will be downloaded and propagate this malware inside of our organizations. We have also, in talking about supply chain, the dependency confusion, that it depends how is it depends of each language. For example, this dependency confusion with a sample we have in Node, but this could be happening in any other language. We don't know. The first step is also we have to use some static analysis, but also have some tool to also try to do the protection in runtime, or at least try to find more about the behavior of this container, because this the malwares could be embedded in runtime, and the static analysis can see the runtime. For your knowledge, we exist tools that could use to try to deep analysis about runtime It's like we have SaaS does the dynamic approach, but you could use this dynamic approach to containers. That mainly it is doing is running the image to observe the attack vector in containers and try to do the prevention before this image go to production. This is some sample, and it exists these techniques. It's recommended that this will help with the supply chain attack. And as you can imagine, also all these kind of malware attacks could happen in software as a service, as GitHub Actions, Travis, inside of our software as a service, our SaaS. They could be easily embedded some image with some malware and propagate with crypto miners, for example. And for this also, I recommended some tools in runtime. For example, we have Tracy, that is a nice open source project also that you could help with these kind of problems. Yeah. In all the slides, it has the reference if you want more detail about this. And doing a resume about the best practice. The first point is you try to automatize these controls inside your pipeline. And after this, you have to empower your DevOps organizations and try to establish some standards inside of your company to have a better controls inside. And well, I am finished. This is the tool that I was using. It is Trivi, and I invite you to go to the other open source projects that also will help with the Kubernetes secure posture. For example, KubeHunter doing a pen testing, Kubebench that will be automatized the sys benchmark of Kubernetes. Starboard, that is operator that will help you with several security tools inside your cluster. They will create several reports. If, for example, if you create some new pod, Starboard that is installed as operator will be automatically create the report about the vulnerabilities. And for Cloud Secure Posture, you have Cloud Exploit that will help you with the Cloud Secure Posture management. But any doubt that you have, also I am available to any doubt in any of these open source projects. And this is my contacts. You can find me in LinkedIn or Twitter. I think also I have the project that I was showing, that is this container security list in my repo. You could find here. And also the demo of Trivi that I was showing about the manifest. Everything is there. Also, you could use GitHub Actions to automatize the controls that I was showing in my terminal. I think that's all. Thank you so much.
Yeah, thank you for your time. I know it's a midnight for you, and it's a really great talk around.
I will go sleep now.
Yeah, thanks for your time, and we'll arrange some of the conference in your time zone maybe. Or it's a great talk around security and how to check the different open source tool to scan container vulnerabilities, and how attacker will like how you can scan misconfiguration. I'm gonna talk a little bit more about like another open source tool. So, but great to have you here. Thank you for your time.
Okay, my pleasure.
Hello everyone. So next talk will be I'll be presenting around one of a open source tool or another security demo I can say. that is Terrascan. Let me share my screen. Hope this screen is visible. Yeah, I think it's visible. So first of all, my name is Sangam, and I work at Accurics as a developer advocate, and I'm also Docker community leader, Okteto and Traffic ambassador. I run a community called Kubebuilder, and this is a non-profitable community, and always I try to support open source and try to contribute in open source. So this is one of a tool from Terrascan, and you've seen one of our first talk on GitOps. So I'm gonna talk a little bit how you can use a Terrascan in different way and how can utilize this very easy and handy tool. Maybe you are a developer, security person, or anyone can use it. So let's start. So what is GitOps? When you think about GitOps, so we think GitOps is a something new or it's just a buzzy word. No, it's a really old concept. We had like declarative infrastructure like a terraforms, and we had a bunch of the past tools like Puppet, Chef, and we had some of the tools like CI/CD kind of Git action introduced in 2019, uh, GitLab CI/CD, TeamCity, Jenkins, and so many tools, right? And from that, we had a Docker previously, so like capturing different kind of methodology and having one of the Git as a one single resource to manage whole thing. And Git has capabilities to do branching, tagging, and a lot of things. And taking those Git repo directly sync whole file to the Kubernetes cluster, and that's where the GitOps is coming to picture. And GitOps is introduced by Webwork, one of the company, 2017. So this is not a new concept. There is a bunch of tools we've seen in the past, and now we see the tools like Flux CD, Argo CD, Jenkins X, which is like around GitOps principle, and it's a very declarative way. Like you can write your whole project, whole commit your code into Git repo, and that's your single source of truth. And from there, you can push your resource on the Kubernetes cluster, and you can deploy your cluster right from UI also. And that had like very easy for the developer to manage whole thing, and without depending on the infrastructure actually. So let's talk about a little bit more. So I think, can I zoom? Is this much is fine? Yeah. So let me explain again if not clear. So we had previously shell script, then we come into like make files to automate that scripts, and there are terraform tar files and git come into picture, and some of the CI/CD tools like Jenkins, one of the open source popular tools. And from this other feature, like GitHub introduced git action, and then there are like Docker come into picture for the containerization, which help us a lot of maturity to deploy containers. And Kubernetes is a whole ecosystem that orchestrate the containers. It give you a freedom. So let's say we copied declarative infrastructure. Um, GitHub is a declarative infrastructure. You write your YML files, and from there you synchronize to the these tools, CI/CD tools like Argo CD, and you can use GitHub, GitLabs on other source code repositories, and from there you can synchronize the thing. So this is not new Git. So moving forward, so this is particular DevOps pipeline and GitOps pipeline, which we build, commit a code, build thing, do a bunch of testing, create artifact, deploy into Docker Hub or Docker file, and pull from there. This kind of, maybe you are doing different kind of following different kind of pipeline, but this is a DevOps pipeline in the GitOps, what happening is Git is a kind of developer, which is dev, and ops is you can manage whole thing with single repositories. You can do add a GitHub action. You can use tools like GitOps, Argo CD. So this is write a code. You have version control system, then automated test, then whatever image repositories, and deploy it directly into Kubernetes, and you can manage whole things. So what are the tools are there, GitOps tools? There are different categories of GitOps tools. That is push GitOps tools. Those are the GitLab, GitHub, and Stack. And pull base is which is like pull resources from GitHub. So that is Argo CD and Flux, and there are like other Jenkins is another tool, and maybe there is a you can deploy this thing in the future using Terraform or Pulumi also. That can be a possible with the GitOps. So moving forward, one of the challenging thing which I think personally, this is not part of a demo, but I listed few of the cool open source kind of repos, which I think when you think about GitOps, one of the difficult thing is managing the secret. So there are a bunch of tools I have listed on this slide just for the knowledge. So you can use these tools and you can secure, encrypt your secret or decrypt your secret. There are bunch of other open source project you can utilize. I highly recommend if you are using like creating a secrets for the Kubernetes. Don't put in a Git repo because that will be a lot of security violation around if your some of the credential got leaked and maybe your whole infrastructure get exploited to the by attacker or anybody can use it. So I highly recommend to you can use this kind of secret management tools for the GitOps or any kind of things. So one of the moving forward, we are talking about security lot, and I think DevOps is just a pipeline, and we need to add more of the security checks in the pipeline, right? So we have this is a DevOps pipeline, and we can add a bunch of security things in every phase of the pipeline. Let's talk about plan. You can add thread modeling. You can do a code analysis. You can check the what is configuration drift happening. You can check the dynamic like you can check runtime, or if some of the build case is got like some error, then go to the developer and talk about this is a problem, then fix it. Don't do kind of dev opsec. People are doing like deploying whole thing and then thinking about security. So you can add this kind of different part of security thing, maybe secret management, configuration drift, chaos engineering, monitoring, security monitoring. So make sure that your DevOps pipeline is more secure. And I'm going to talk about Terrascan. So a little bit about this is the latest post from the RedHat blog, which is top open source Kubernetes security tool, and Terrascan used by 22 respondents as per this survey. And you see the Terrascan is in the top 5 Terrascan built top of OPA, and we have a lot of open source, a lot of policies, pre-built policies, so you don't need to write the policies, and there are a bunch of other open source tools also. So first thing, let's how you can use this tool, right? This is very important. So it's an open source tool, and you just go and copy this link. If you are using Linux or Windows, so you make sure you have a Terrascan binary install. If you are a Mac user, use Homebrew. You can use our Docker image if you want to use Docker image for scanning some of the things. Moving forward, once you install, you get this kind of CLI. So you can scan, use as a server, check version, and use as a flag. We'll see in a minute. But I'm going to talk about what you can do possibly in your securing your cloud native infrastructure. We start right from the CLI. I will talk about GitOps, Argo CD, and Kubernetes, right? So let's say you are a developer and you want to commit a code. And before a committing code, you can use a pre-commit. Pre-commit is a pre-hook which is integrated with the Terrascan. Whenever do a git commit, if that pre-hook is configured, you will get right in your terminal what is the violation happening. So before committing, you can check that those things. You can use as a Terrascan CLI, scan your Docker file, Kubernetes, customize Terraform. Maybe you want to deploy AWS, Azure, GCP platform. You can use that. You can integrate into Git repo, set up a security kind of for your Git repo, use our Git action also. Also, you can use a Terrascan as a server. You want to scan into your CI/CD pipelines or anywhere you want to use. So moving forward, you can set up Git action and write in a Git action report. You can check violation. Also, we integrated a Terrascan with Atlantis. Atlantis is one of the Terrascan pull request automation. You can create a Git action with Atlantis. Whenever you update your whatever the Terraform files, so in the comment section itself, you get a violation. Okay, I created a pull request. I am a new user, and we are collaboratively building some kind of using a Terraform, deploying some kind of application or something. And once you create a pull request, and Atlantis will create that git, run that git action, and it will give you your whatever the violation in the comment section itself. So you don't need to like do a security check again and again. So you can use that way also. Yeah, you can integrate with a bunch of CI/CD tool, Azure Pipeline, GitLab, Circle CI. You can use those things. And one of the buzzy thing is GitOps. So you can use in GitOps also. So what is the GitOps? So you have a Git repo, and you have a one namespace. You maybe might be using a Minikube or for the demo or EKS, AKS, any kind of cluster. So there is a GitOps namespace which contain all your whatever you want to install, your Argo CD, YMLs, or whatever the needed manifest, and then it will create a kind of, after installing this thing, you can use our presync hook. What this presync hook will do is that in that presync hook, you can add which Git repo on a scan before deploying. So inside your Git repo itself, inside your Argo CD kind of logs itself, you will check the violation, what happening. Even you can set up a Slack notification. You can configure your Slack, and whenever that hook will run or synchronize that Git repo, then you will get a notification in Slack channel. You can use that way, or you can use a admission controller, add your to the Kubernetes cluster, and you can use in a Kubernetes cluster, whenever you create something, you get a direct violation in your dashboard. And we added a couple of few new feature, which is Docker file support, and also you can scan a container registry. We support currently 3 container registry, Azure, Azure and Amazon and GCP registry. So you can use that. So I'm gonna show demo around how you can use this thing. So let me open the VS Code. Okay, so let me open the demo. Is it visible? I think it's visible. Okay, I think it's visible. So this is a terminal. I have like bunch of different example. Let's talk about a Docker file. So you write this kind of best practices for the Docker file. use minimal images, remove the cache package, and avoid multi-layer this kind of thing. Use add notation. Then don't add a secret all thing into your Docker build context. Use Docker ignore for ignoring your some of the file. Don't commit whole thing. Don't use as run as a root. Use add some of the user for the security layer. Use Docker file linters for VS Code if you wanna like do best practices. Avoid hard coding. You can use argument variables to pass variable arguments when you build. And one of the cool thing, you do this thing, but you not you still need a security best practice. You need to check your Docker file. So you need to check vulnerability checks. So use 3 commands. So this is my Docker file. So already I have installed Terrascan, and once installed, use Terrascan init, which initialize our whole policy. We have pre-built 500 plus policies for Kubernetes and everything. So once you do Terrascan init, so after that you are ready to go and scan your Docker files. Let's show you. Use -i as a flag and Docker. So whatever the Docker file is here, it will detect automatically those files, and it will show what kind of violation happening. So this is my Docker file here, right here. So I'm here using, maybe let's say I will use 7 because this is beyond the range of the exposing the port. If I scan again, you will see the new violation there. Before there are 2, now 3. It will tell you what you can do on the right in the terminal. Your range of the port is from this range. What line number? What is the security risk? Minimum, maximum? You can go and check rightly, and it can use by security person also. You can use by developer. This is very good. We have predefined policies. So this is one of the thing. Now I have another file here. If you see here, so I have a file called dockerfile.go, which is another file. So I can use a flag -f, and I can just pass this whatever the file name. So it will go and scan this file. Now you can see what file name and what is the number. You can check this Docker file. You can similarly do for the Kubernetes also. So if I see git s, I can do a directory. I can use dot, and I will do kube demo. I will just scan. If you see here, I'm scanning under this file. I have simple YML file here. Whatever if you are a Kubernetes user and you want to scan your whole misconfiguration, what happening in your is it your YML file is secure, or you are passing some secret, or some of the best security best practices. So you can scan Kubernetes violation. It will check checking the 41 policies which is written in Rego, and you can use this thing to scan whole thing. You can scan Helm chats. You can scan Terraform files also. So if you have AWS kind of thing, AWS directory, I will use like S3. I think, and I think I used to do E and mark. And now you see the violation, right? You see the violation, what happening right here in the your whatever the Terraform script, or whatever the misconfiguration. Maybe you are exposing something buckets in the public, so you can use those things to scan. Now you can scan a whole Helm chat, Kubernetes, Docker, customize even the container registry. If you know the Rego language, which is writing for a write your policies, so you can write a kind of policies, also customize policies, and you can contribute to Terrascan, or you can run locally, write your customized policy and use a Terrascan as an engine to validate your infrastructure. So you can do that also. So moving to the GitOps thing. So what you need to do once, make sure you have a Minikube installed. So once your Minikube installed, create a create a namespace for Argo CD, which I have already created. Now, then you install this whole thing into your that namespace. So this is a YML file, official YML file. So you can just copy this YML file to install Argo CD on your Kubernetes cluster. Then you run Argo CD as a server, right? So let me start those things. So I will go here. I will just clear my screen and I will just run. Click start. So it will take 2 minutes to start, I think. Until then, I'm going to show you the repo which I have created. So this is a repo which I have, which I'm going to synchronize into Git. So I have created a Kubernetes webhook, pre-hook actually. So what it's doing is you can go to the Kubernetes documentation, you get this YAML file. So what we are doing is here, we are using a Docker container here, and then we are passing the command and argument to scan. We are scanning the repo remotely. So I am scanning current repo. You can scan any repo, public repo, or you can pass credential also. So I'm gonna scan here my Docker or Kubernetes file. So I will use here command as latest, and I will just change this file and commit this thing. So what happened is here, it will go and scan this particular repo, and it will change. It will tell what violation happening. So now I have one Kubernetes manifest here, which is simple go over hello world application. So it will scan this thing, and it will tell a violation right into your Argo CD. Right. So let's see. Okay, now it's ready. And I will change kind of Argo CD. I think switching. So I'm switching now my namespace, and then I will just run Argo CD as a server. So I will go here. I will run Argo CD as a server, and then you will see it will run on localhost 808. And then I will go into my browser. I will share my browser. So you will let me share my different screen, I think. So that will be, or let me move my screen so you can check. I think I will stop sharing screen and reshare my other screen. Stop sharing and share a screen and share a second screen. So if you see here, you will get uh, this kind of a browser. Once you go to localhost, you see this kind of let me get a port on screen, I think. So you will get this kind of a dashboard here, and if you go, you can give your password. So my password is, you can change a password also. I will tell a little bit about the password also. Now already I have created here whatever my Git, but I will just delete. I will go there and delete my old project, all resources. So I'm gonna delete this thing. Scan demo. So I'm going to delete. So what you need to do is first you need to create a Terrascan or whatever the application name you want to give. Default, I will set default. Manual, and you need to add here whatever the Git repo you have, or whatever the Git repo you want, your hook is presented. So I will go there and I will add my branch is main, and then I will give a path as a current. I will give a default cluster, and my namespace will be default space. And I will say create. What's happening is here. Application specification is invalid. Okay, this is correct. Git branch and default is correct. And then I will just create. Application is invalid. Okay, maybe. Let me check my Git repo here once again. I think it's correct or not. Manifest file. Project is default. Manual. And default. URL. Click once again, refresh my app, scan, remove one, then default, then review my root repo, path, cluster, default, then say create. Okay, so now you have created this kind of project is created. Go and you can see your application here, and you can, it's not synchronized, it's not auto synchronizing my whole thing. So you can click here and you can run as a dry run also, or you can synchronize whole thing. So I will say synchronize this thing. Now hook will run, and once hook will run, you can see all the manifest live here. You can go and check into the log what happening. You can check the events, what happening in the what Docker image it's pulling, and what kind of logs also. So currently it's getting ready. So you can check the bunch of violation here, which is my KTest deployment YML file. So you can see this kind of violation. You can add a kind of notification also using your integrated your Slack, and it will send your whole kind of whatever the violation happening on your Slack channel. So you can add one pre-hook, just one YML, and you are ready to go and scan your file, and it will tell there is violation or not. So you can use this Terrascan on GitOps pipeline also. So that is the GitOps demo. Come back to my sharing screen and let me a little bit show around a Terrascan what other thing you can do. Share a screen. So let me share a screen. So we have launched the Run Terrascan website. You can check all the documentation here. So there are a bunch of documents here. So you can go how to integrate. There are few of the tutorials, use Prehook, Argo CD, or Kubernetes Administration Controller, and even you can contribute also. And make sure to join our Discord channel. Go to the run terrascan.io and join a Discord. We have a Discord and very active community, and let me know if you are doing something or any kind of question. Reach out to me if you wanna integrate this into your Kubernetes cluster, or even in your GitOps pipeline. So make sure to give a Git star to this repo, and a bunch of cool feature coming up. So we introduced Docker image vulnerability scanning feature a few days back, and you can use as a Git action, and you can do pretty much as you can as a developer also you can use, and as a security person also you can use. So if there is a question, let me know. So that's my demo. So we have a next speaker from Nicolas. He's a developer advocate as a Hazelcast. And so he's created you have seen a demo from Ramiro. Using Kubebuilder, you can build a CRD or operators. So Nicolas built something around Rust. Using Rust, how you can build a operator. So what Terrascan init do is Terrascan initialize all the policies. We have 500 plus policies. Whenever we it makes sure that your all the whatever the policies you need to initialize before use, so it will be cached locally, and then you can use it. Otherwise, you will get some kind of error if you don't do the Terrascan.
Hi folks, thanks to be here for this talk about your own Kubernetes operator, not only in Go. I'm Nicolas Frankel. I've been a developer for 20 years and now I'm a developer advocate. Throughout my career, I was always interested in better and faster delivery. And since a couple of years, I'm quite curious about Kubernetes. I work for a company called Hazelcast. Hazelcast provides the Hazelcast platform, which has two main features. The first one is an in-memory data store, and the second one is a stream processing engine. But today, I won't talk about Hazelcast. I will have a look about a bit of Kubernetes. And I assume that you know that Kubernetes is a platform where you can deploy containers. And in general, people introduce Kubernetes with this diagram. And here we can see that there is a central piece, a central component called the API server. And it's the proxy by which everything happens in Kubernetes. And mostly it's the proxy with which we interact. So whether you are using kubectl or something else, everything goes through the API server. And how does it work? Well, you probably are used to using kubectl, at least to play with Kubernetes, but did you ever try to get some verbosity? So let's try to do it. I have launched a Kubernetes cluster. Here I'm using Docker Desktop, but it will work with anything. I will just kubectl get pods, but I will add a verbosity level of 6. And here we can see that to interact with the API server, the kubectl command actually sends HTTP requests. And even better, if we add the verbosity level, if we increase it, we can see that it sends JSON and receives JSON payloads. So nothing magical, is just like the API server, is just a sort of a web server. It receives the request, it responds. And now we have this concept of controller. And actually, you probably used already some of them. Controllers are just control loops. With a controller, the controller will like watch the states of your cluster, and it will like query the desired states, and between the two, if there is a gap, it will try to reconcile the actual state with the desired state. The most well-known controller is, of course, the deployment controller, meaning that when you use a deployment, when you deploy, let's say, 3 replicas, if you like kill a pod from this controller, from this deployment, sorry, then the controller, the deployment controller, will regularly watch it and say, oh, there is a missing pod, I need to recreate one. This is just very simple stuff. And now the question is, where are the controllers located? Because probably the deployment controllers are run inside the cluster, and it's correct. All out-the-box controllers run in the control plane. But if you create your own controller, actually, you can run them from anywhere. You can run them inside your cluster, you can run them outside your cluster. And the title of the talk is a Kubernetes Operator. And then we add one layer, one semantic layer, is that an operator is a specific controller. And actually, the operator operates on a custom resource definition. So it's a controller, but instead of operating on like pods or deployments or whatever, it operates on a custom resource definition. And a custom resource definition is a way to extend the Kubernetes model. So if you want to add the notion of application, the notion of car, the notion of customer, the notion of, I don't know, inside of Kubernetes, you can like create your own resource through a custom resource definition. So here, for example, I've created a custom resource definition, YAML file, and its name is Hazelcast. So I can create a new Hazelcast. Whatever that means, there is probably something that is specific to you. And of course, I know what is a Hazelcast instance. If you never played with Hazelcast, you don't know about it. But here, anyway, I can extend the models. You can think about a custom resource definition as sort of a new table inside a normal model. But of course, it's not like this, but this is quite similar. So again, controller is just a control loop, and an operator is a control loop that operates on a CRD. If you know how to do a controller, you know how to do an operator. As I mentioned, the technology stack of controllers is just to talk to the API server. And we have seen that to talk to the API server, you make HTTP requests and you send and receive JSON payloads. So it's just like simple REST. So you can probably create your own controller using just shell scripting. But most people, they use Go. And yes, Go is very pervasive in the Kubernetes ecosystem. Most probably because Kubernetes itself is written in Go. Well, it has been rewritten in Go from Java. But I dislike Go. And the reason for that is error handling. I don't have other trouble with other languages feature, but as a developer who programmed mainly in Java in 20 years, I've been used to like separate the nominal path, what the code should do, and what it does when there is something unexpected. And if I don't care about errors, I want to understand what a piece of code does, then I can focus on the nominal path. But with Go, it's not possible. Every time, every function, if something might go wrong, it will return an error. And it's up to the developer to check if the error is nil, is null, like if there is no error. So you can write stuff like that, which, in my opinion, makes it very, very hard. And there is this joke commonly found on the internet that if you are a Go programmer, you probably have this key on your keyboard. And you can say, hey, but you can learn Go. And that's true, I can learn Go. Actually, I try to do it. But I believe that's not the path that everybody should take. Of course, you can learn it. But it's not only to learn the syntax. You might remember those books from like 10 years ago. I hope they are not there anymore. Hey, learn C++ in 10 days. Yes, you can learn the syntax in 10 days. But learning a language is much more involved than just the syntax, because you need to use the idiomatic way. I remember when I was younger, I started in Java, but at the time there were C and C++ people like coming to the Java language, and you could see the Java codes that was written by C and C++ developers, because every time at the end of the function, they set all the variables to null, because that's what you would do in C. So in Java, it's not necessary. You don't understand how it works, you will do it anyway. And then it doesn't stop at that, because afterwards, you need to understand the libraries. Like, for example, in Java, the libraries, there are many, many libraries, and some libraries, they do the same stuff. So if you want to do logging, for example, you can use log4j, you can use Apache commands logging, you can use slf4j, and then you have log4j too. There are many, many libraries to do the same thing, and you need to understand what's adapted to your use case or not. And then afterwards, you've got the tooling, because you probably, well, I know there are some people who do, but you're probably not writing your code in Vim, in VI. So you probably are using an IDE, and you need to understand how the IDE works. You need to understand how you can like run a program, set a breakpoint, and check the state of a variable. So my point is, if you already know a language, then you should probably use it. I did this talk before, and I showed how you can use Java. But here, since I don't have that much time, I will show how you can use another language, Rust in that case. I'm a Rust newbie, I'm not a Rust expert, but it's just to show you, and besides, I won't go very deep into the language. I just want to show you how you can do the same as you would do in Go. So here I'm in my IDE, and Rust like already provides you the way to declare dependencies and to build your package. So here, for example, I've already prepared everything. I'm using logging, of course. I'm using the way dependency to talk with the server, the kube server, and also I'm using an async library because I don't remember which one, but relies on async codes. The code itself here is pretty straightforward, and even if you don't know Rust, here I'm initializing the log, so I rely on an existing log configuration file. Then I will create a client to talk to the API server, and then I will use something called an API, and it restricts the resources to a dedicated namespace, and then from this namespace I will list all the parts. And well, if I try to run this program, you probably understand what it does. It will just go through all the pods of the kube system namespace and print them in the console. And that's done. So let's go a bit further. Now we know how to talk to the API server. It's just like REST code, and we are using an API that already does it for us. We could go on a lower level and just really use HTTP commands, but here it's already done for us, so we can already do something. And now if we run this code, it won't work because the program will run and it will stop, and so Kubernetes will detect that we must restart the pod. That's not what we want. What we want is to do that in a loop. So of course we could do that in a loop, but there is an API called the watch API that does it for us directly. So here it's a bit more involved. So instead of listing, we are watching. And now every time we receive an event, if the event is of type added, then we write added into the log, blah, blah, blah. So let's try to do that again. And here you can see that I'm running this code from outside the cluster. So far, I don't do anything from inside. Again, it's irrelevant. As long as I'm able to talk to the API server, that's perfectly fine. And now, poof, it works. And here I'm in the kube system namespace, so I don't want to delete anything. I also don't want to add something, but everything there is a change, it will write into the log that there was a change. Pretty cool. But we can do better. Actually, what we can do is we can do some, it's not real sidecar. Actually, the sidecar would be to be in the same pod here. Every time we deploy a pod in a dedicated namespace, which is actually a REST operator namespace, we'll deploy a new pod along it, which is a Hazelcast pod. We don't want to do anything with it. We just want it's just for fun. So now, when we add something, we will do the deployments, and we first check that it belongs to the correct namespace, and then we can check that it's not a sidecar, because if we don't do it, then you will have one pod, then you will deploy a sidecar, and then the sidecar will be a new pod, so we deploy a sidecar of the sidecar, and it's never ending. So we must check that it's not a sidecar. We must check that it doesn't already has a sidecar, if it can happen, so just be sure. And if it doesn't, then we create the sidecar. And in the case it's deleted, we must recreate the sidecar. So again, I don't want to delve into all the Rust codes. I just want to show you how it works, and let's do it. So now I will create a new deployment into this namespace. Just stupid one. And you see here I have deployed a deployment and a pod called hello whatever, and then like directly I have the sidecar alongside it. And if we delete the deployment, of course the hello world is not meant to run normally, and we can check that it gets deleted alongside, yes. So here it deleted the pod, and now we delete the Hazelcast sidecar. Again, it's not a real sidecar, because we made the main hello pod the owner of the other one. So it's up to Kubernetes to delete it. Finally comes the time when we decide that it might be a good idea to deploy this, not outside the cluster, but inside the cluster as a regular pod or deployment. But here we will save it in the scope of the pod. Next step is to actually create it. So here I go through several steps. If you want to check the GitHub repository, it will be at the end of the presentation on the last slide. But I directly present you the from scratch Docker file. So we create a Docker file. Here there is like a Rust image builder. It's a multi-stage Docker build file. So we first create the binary, and then from scratch we add the application we just created in the previous step, and we also copy the log configuration file. If you don't have anything here, you don't need to copy it. And then here it's very simple. And if we like check the final results, like Docker images grep Rust, here we can see that it's like 17 megs. And probably in Go, you wouldn't go much smaller, if at all. We must just be careful that when we do that, we must give the pod authorization, because to talk to the API server inside the cluster is actually like dangerous stuff to do. You don't want every pod to be privileged to do this. So here we must create the correct cluster role, and we must create a service account, and we have a cluster role binding that uses the service account and the cluster role. And finally, the pod, we must use a dedicated service account, the one we've created before. So this is something to remember. When you are outside the cluster, it depends, but here I'm using the Docker desktop, so it's just as if I was using kubectl. I have all privileges. So let's try to deploy this. K apply F, and it's called deploy. K get pods W. And here you can see that it's already working. And the reason for that is it deployed the Rust operator pod, and when it has been deployed, hey, there is a new stuff arriving, and so the pod itself has created its own sidecar. And likewise, we can remove it. K delete pod Rust operator, and it will again, because of ownership, it will delete the sidecar. And that brings us to the end of this talk. So in this talk, I've shown you what are controllers, just control loops, like nothing really mind-blowing. We check the current state, we check the desired state, and we try to reconcile the two. I've shown also you that operators are nothing mind-blowing. It's just like a specific controller, a controller that operates on a CRD. So here, this is not an operator, this is a simple controller. No tech stack is actually required. You don't need to use Go, you don't need to use a library. You can, as long as your tech stack can make HTTP requests and is able to send and receive JSON payloads, then you can use whatever you want. And I would probably advise you to do that, because learning a new language is hard. Go, despite all proofs to the contrary, in my opinion, is quite hard to read because of this error handling. When they add a better error handling, I believe it will be much easier to understand. Of course, your language stack probably has limits. Like, for example, if you use Java, that means that you will use the JVM. And if you don't want to use the JVM, then you probably need to do some ahead of time compilation, where there are ways to do that. But some languages, some stacks might be better for running inside a container, especially if you want to kill the pods and to restart them every so often. So startup time might be important, so be very careful about that. But otherwise, yeah, just use the language you are most comfortable with. Thanks a lot for your attention. You can read my blog, you can follow me on Twitter. More importantly, you can get the repository, so you can check the code here. And here is the blog post that I wrote about it, which basically is the same as this talk, but in a perhaps more detailed way. I also did the same for a JVM controller. So if you're a Java developer, you might check that. And though this talk was not about Hazelcast, you are welcome to join our Slack and to get some free training. Thanks a lot for your attention, and I wish you a good day.
We will take few questions. Nicolas is here.
Hi, folks.
Hey, hi. So there is one question in the comment section. If you see, in regard to the performance in the Kubernetes context, does one language has advantage over another language? Example, Go over Rust or Rust over Python. So
sorry, can you repeat? I have a pretty bad connection, and it's really hard for me.
Yeah, there is a question regarding Kubernetes in the performance in Kubernetes context. Does one language has advantage over another language?
Okay, so the answer is pretty simple. The closer to the metal, then of course the better it is. So if the performance is first, there is not one single dimension for performance. It can be startup times, it can be execution time. There are a lot of dimensions. So I generally push back on questions regarding performance, because it doesn't, I mean, depending where you come from, the answer might be different. So if you want startup time, for example, then probably you are more interested in native binaries. If you have long-running processes, then the JVM is pretty good, because the JVM was made for long-running processes, so that it actually compiles the bytecode, the native codes, in a way that is adapted to the workload. So, and in general, your workload is pretty similar, it's pretty stable. You always have the same workload. So it really depends. I never did any benchmark, because most of the time, the raw performance in all cases is not that important regarding the HTTP round trips. So if your HTTP round trip is 1 second and you gain 2 milliseconds, that's not a huge advantage. On the opposite side, what I try to show you in this talk is that learning a new language is hard, and we are not talking about performances. Here we are talking about the time it takes you to learn Go or to learn Python or to learn anything. And it's going to be a huge investment. And that's for sure. At the beginning of your journey, you will make many mistakes, and a lot of them will impact performance. So the idea is just don't think about raw performance, just think about your whole context. And again, performance is multidimensional. It doesn't mean a lot per se. I hope I answered the question. Perhaps not in the right way, but
so there are like so many components of Kubernetes also that what you are dealing with is very important. Maybe there is scheduler and there is so many things, but Nicolas cleared most of the things. But if you want to learn Rust or Java, visit to Nicolas' blog. He wrote a Rust series, so you can learn in easy way. And there is one of a repo called Rust Link. You can use that repo to practice. Even I started learning from Rust Link, practicing the exercise. So make sure to visit, and if you want to learn Rust, visit to Nicolas. Thank you for your time.
Thanks a lot, folks. Have a good rest of the conference.
So we have our next speaker, Shilpa from DellEMC. So over to you, Shilpa. Ma'am, can you share a screen? Your voice is not audible. Can you check your settings, please? Go to the camera or mic setting. From there, you can select whatever the resource you want. Or you can rejoin if there is anything. You can rejoin the platform. So if there is any question regarding Cloud Native and anything, let me know. I'm happy to answer. So if you want to learn Rust language, so I have created a series of called Rust Lab, labs.kubebuilder.com. So you will see a bunch of tutorials there if you want to learn Rust language. And I have community for that also. So if you go here, so this is a link. You can go and learn Rust, and there are similar link if you change the go for labs.kubebuilder.com. So I have a few of the tutorial for Go learner, golang.goforlabs.kubebuilder.com. If you go there, I have created a bunch of the resources to those who want to learn Go from the beginner. If you are a student or newbie, everyone is welcome. And you can go and check this both link. Shilpa man is back. Yeah, still it's not audible. I think you can just check your mic setting. Go to the camera and mic setting, and then okay, no problem. What we will do is we will continue one of a session from Shubham and Neha, and then we will follow your session after that. Is that fine? Yeah. So over to like next session, we will move forward. I think because of there is technical issue, but we'll find out what is the issue, and then we'll continue the Shilpa ma'am session. So over to Shubham and Neha. Hey, guys.
Hello.
Hi everyone.
Hey guys.
Yeah, over to you. You can share a screen.
Okay. Yeah. Is it visible?
I'm not shared it yet.
No. So I've shared the screen. Is it visible?
Yeah, it's visible.
Okay. Cool. So we'll get it started. Hi everyone. Hope you're doing well and safe. I'm Neha and this is Shubham with me. A little bit about ourselves. We are the co-founders of Hybrid Kubernetes, and we've been into data and platform engineering for organizations like FARI, Lenskart, AWS, and so on. Today, we're going to talk about how to make deployments of your applications reliable by enabling AI-based automated rollbacks in Kubernetes. And by the end of this talk, you'll have insights on reducing downtime and user impact while deploying your applications, that too faster than before with reduced effort and maintenance cost. So we always wanted to make deployments as soon as possible and iterate faster without having any downtimes. But where does the challenge lie? How there are disasters that happen. They come in many forms and shape. Uh, Configuration issues, latency issues, crashes, accuracy decrease. So when you deploy your application, it takes a lot of manual effort to do the production sanity testing to see if everything looks fine with the logs and other metrics like latency, error rates for the new deployment, right? Um, if you choose to go with automated scripts, which contains log regexes of your application or validation or network metric, it will come with a lot of script maintenance, and it will become boring eventually. So this results in other problems like performance of applications being unpredictable sometimes, which require quick rollback, and automation in Kubernetes can be hard sometimes. So if you think about it, these challenges are there. And with these challenges, how do you verify the sanity of your application at scale? I'll give you a moment to think about it. Any thoughts? Put down in the comments. So when I thought about it, there are HTTP error monitoring. We can start with it. It's a great start. But do they tell you about the complete picture? For example, sanity scripts can, help you further, but it's not easy to build and maintain them. How to reduce the impact and recovery time? Uh, so all these thoughts put me down to the solution of introducing progressive delivery and with the AI automation of verifying the deployments. So let's take an example here. Say this is your plain old canary deployment on Kubernetes. What makes it special is you don't have to manually check the performance of new application, like checking the latency, error rates, memory consumption, logs of your new deployment. What makes it special is hybrid care tests will automatically verify on the logs and performance metrics and then roll the changes out to the rest of the users. Now you might be thinking, what would happen in case of buggy application release? So let's say if I roll out a faulty release, then the canary deployment will serve as an early warning indicator with less impact on downtime. And if the canary deployment fails, the agent of hybrid creators will flag and roll back. So the point to note here is that the new user impact is highly reduced to 40%, for example, in this case. And the rollback decision was instant without any need for custom application specific script, writing the log rejects or rules, or for the ranges of different metrics or any manual intervention. So how does this automation work behind the scenes using AI? By comparing the logs and performing metric performance metrics of new and old deployments in real time, which otherwise could become difficult to monitor at scale when you have thousands of log files being generated per minute and so many performance metrics to track. And this is how things would work at the backend, where there would be a service mesh, which will be helping us splitting the traffic to new and old deployment, and a hybrid KTS agent that would be syncing up the logs and metric data to see if we can release the application to the next subset of users. So I've done enough talking. Now I'd like to call upon Shubham to show a quick demonstration of how you can enable the setup within few minutes. Shubham, over to you.
Thank you, Neha. Quickly share my screen. I hope it's visible.
Not yet.
Okay.
Yeah, it's
Cool.
visible.
Perfect. So to start with a quick demo, so we have a test namespace here for demonstration purpose. Most of this is quite vanilla. It's a fresh Kubernetes cluster on AWS, and it currently has a service mesh installed. We're using Linkerd for demo, and it also has Flagger from vWorks, which is part of the Flux Flurry ecosystem. So that's also installed as the progressive delivery operator. So as we can see in the test namespace, we currently have two parts. One is a Flagger load tester, which is for demonstration purpose, is going to generate load. And the other one is a test app. This could be a regular old application, which now you want to convert to a candidate deployment or a blueprint deployment, right? You want to improve the stability. So here, as we can also see, what services do we have in this namespace? We have two services for each of these parts and also two deployments.
Shubham, somebody asked if you can please increase the font size. It's not visible.
Sure. Is it better? I think it should be large.
Try to pinch out on the...
Yeah. I think it's far bigger. So going back, we have two deployments. We have two services, and we can see the same thing on Linkerd dashboard. So with Linkerd, you get this nice dashboard. And here we can see that there are two deployments here in this particular namespace. And test app is the deployment which we want to convert into a candidate deployment. There's no traffic split configuration. Everything is quite simple. So the first step here is I need to create an account on hybrid KTS because we're going to use that for the verification part. So let's do that. Once you create the account, then we have to just add this particular cluster to hybrid KTS control plane. So once you sign up, this is a screen which you would be able to see. In this case, I have already added. So essentially, you just fill these details. And once you've done that, you will get a few commands. So these are those commands. The first one is just the metric server, which you can copy paste. The next one is, the next two are about the Helm charts. So once you're done with that, each cluster comes with its own API key for security purpose, because you may have clusters for different environments, you may have clusters for different owners. So to segregate all of that, and what we have to do is copy the API key and paste here. What we have here is a canary file. In fact, let me increase the size here as well. Yeah, cool. So this is a canary file. It's based on a CRD from Flagger, and as you can see, API version Flagger v1 beta 1, and we have already provided a template which can be also accessed on hybrid KTS documentation site. So there's a quick start guide available, and essentially all I need to do now is just paste the API key because we have a native Flagger integration. Perfect. Now, after that, I just need to apply this file, and I'm just going to do a couple of changes. Now, as we saw in the beginning, there were 2 deployments. Now it's going to create 1 extra deployment. Right? It's going to take some time. And also create 2 new services, okay, which has happened. So this one is going to use for primary, and the other is going to use for canary. And let's see if it's created a deployment. Yeah, so it has created a new deployment called test type primary. So going forward, all of your stable application earlier used to live here because you had only 1 version running at a time. Now the stable is going to run here, and this is going to be scaled down to 0. Test app is going to be used for your canaries. So whenever I do a canary deployment, it's going to be scaled up with the newest changes. It's going to be tested, and once everything looks fine, it's going to be shifted to the primary itself and scaled out. So that's the process here. We can also, describe the canary object because it's a CRD. As we can see, metric are available. It's still waiting for rollout, so it's not ready yet. Meanwhile, if I go to the Linkerd dashboard, I'm able to see it has also created a traffic split configuration. And what it's doing is the old service, which all the applications were using, that essentially becomes an Apex service. And it has created 2 leaf services, each for primary and canary. So these 2 services goes to those 2 deployments, right? And there is a traffic split for me to split traffic during my canary deployment. So essentially, your old service stays as an Apex service. So external applications don't have to change anything. Everything works as it is. But the leaf services are created, which can be used for traffic split. So it's all internal to the service. External applications are not aware. Similarly, now if I go to the deployments, you can see this has been scaled down. So now it's entirely my primary. We can also see it here. So by now this should be initialized. Yeah, so it is initialized, and now if I get deployments, you can see that the old one has been scaled down to 0. So let's do a change. So let's do a deployment. So in this case, I'm using a Helm chart. The same thing would work even if you're using regular Kubernetes YAML or you might be using customize. It would work exactly the same. We have purposely created 2 tags. One is normal, which is currently running. Let's change it to faulty. It's purposefully for this demo a faulty image. Now, what it's going to do is, even if you're using Helm or you're using customize or regular Kubernetes YAMLs config, it would say that deployment has been successful, but Helm thinks it's been deployed, but it's actually not deployed. Now this would be handled by the canary object. It would not just go and roll out and replace the application. It would now first detect the change, and once the change is detected, it would now start the whole procedure. So let's see that in action. So if I describe the canary object, we can see new revision detected, scaling up test app. So what it has now started doing is, so it has already done that. So it has now started scaling the test app. Test app is now going to have our latest changes. In this case, we've added a new container. So we have that in the test app. And test app primary continues to have the old application. And yeah, so as you can see, the health checks are passed for the test app, but now it's actually going to do the canary analysis, and that's where hybrid k comes in. So it has not yet done the traffic split. In a moment, that's what it's going to do. So essentially what's going to happen is the load tester is going to be also initiated. There's a webhook we've added in Flagger to start the load tester so that it can start generating load. In practice, however, you could be having a production traffic, so you will actually not need a load tester. Load tester could be required only in non-production environments, and in many cases what people do is they just mirror traffic from production to non-prod. So that's also a strategy which can work. So in our case, let's see if it has started with the traffic split. Yeah, so the traffic split is done. We have configured in Flagger to increment it 5% at each and every step. So it's going to keep on incrementing traffic, and it's going to call whatever webhooks you've configured. So in this case, we've configured hybrid k. Meanwhile, let's also see what events we have in the Flagger object. Yeah, so as you can see, started canary analysis for test app, and we also have advanced test app canary wait 5. So Now what's going to happen is it would have triggered the load tester. Okay, it's not done yet. So it's going to trigger the load tester. And the load is going to be split between test type and test type primary. And during that time, it's going to call the hybrid K-Days API, which is going to look at the log data. It's going to look at the metric data. And it's going to give us a result around, okay, if things are fine, if they're fine, it'll let it proceed, 5%, 10%, 15%. Else, it's going to trigger a rollback. So as we can see, the load tester has instantiated, and we can already see from visually that the success rate is different. So it's 98%, 98 point something, and the success rate for the older was 100%, right? So there's already a difference that we can see. There could be other faults as well. So now it's going to call the hybrid K-Days APIs, and it's going to figure out if it's working correctly or not. Okay. Another interesting thing about Flagger is that the analysis is asynchronous. So it's currently implemented in a non-blocking way that can be changed. That can be adjusted. You have to change the webhooks that you're using. Right. So as you can see, there is a failure, and right now here it's quite cryptic because it's directly the API response to really get a deep sense of what really happened. Let's have a look in the hybrid K-Days dashboard. So here, what I can see is this is my current deployment, so which we just did, and we can see that the metric validation failed, and metric validation have multiple types. For example, it could be latencies, it could be system metrics, it could be your error rates. So in this case, it is error rate, and it's saying right now it's configured to round off to 2 digits, so it's showing 1% error, and whereas there's 0% error in the primary. So that's why it has failed and it has triggered a rollback. And here we can also see that the canary has been scaled down, right? The traffic split configuration is also changed back. It is now 0 and 100. So in practice, if this was a faulty deployment and you did not have anybody actually sitting here and checking each and everything, this would trigger an automatic rollback. 5% users were affected for a very brief moment, but the automatic metric analysis was done, the log analysis was done, and based on that, rollback happened, and very, very minimal user impact. And yeah, so rollback has been done. Similar to metric validation, like I said, we do log validation as well. So an example of that is here. And the way that works is if your metrics are passing, so let's say your success rate looks correct, the latency looks correct, but in practice, what all of us might be aware of is, even though the metrics don't tell you the complete picture, there are errors that we're able to identify once we go in deep into logs, right? And that's why that's one of the core focus of this platform. So it's able to detect errors, new errors. So these are new errors: 11 occurrences in canary, 0 occurrence in primary, 9, 0. So these are new errors which are not encountered ever before. And the first one is an existing error because it's 80 in canary and 10 in primary. So this used to happen. In practice, we would have errors, but if a particular error distribution has changed significantly, right? Because it could be a known error or it could be something that we've been ignoring, but as soon as the distribution changes, it becomes 3 times or 8 times more likely. That's a clear indicator of a problem. But yeah, since it is all NLP and AI driven, there's a possibility that maybe this is incorrectly flagged as an error, right? Or maybe this is not an error, or it's a known error. You want to ignore it going forward for now and fix it later on. So in that case, you can add it to the knowledge bank, and once you do that, it's you can for each and every application, each developer can go and adjust, keep on delete from the knowledge bank, or keep on adding stuff. And what you can also note here is for everything that we show around logs, we show these stars, which essentially mean, so these represent the logged data, because generally whenever we log something, we log some data, maybe event IDs or some other fields. So the agent itself removes all of that so that there is not a lot of egress from the cluster, because in an application, generally you would have at max 500 different log statements. but they will be logging it different for each and every event, and so you'll have millions of logs every minute for a large enough system. So all of that is dealt with here. And as we can see, we're able to see the generic log statement and everything is start. So all of those data is removed and obfuscated. And yeah, if one day you decide that, okay, this is no longer a problem, you can delete it and it's removed from the knowledge bank. So knowledge bank is specific to the customer, like for you. And we also use the knowledge bank overall from different customers to improve our ML-based models. Because the theory is that the better, the more data we have, the better we can understand different stacks, like, or different frameworks like Spring Boot, or, different web servers in Go, or different libraries used by different applications. So we want to, be able to figure that thing out in depth as we encounter more logs. So yeah, as we can see here, everything is rolled back. Things are back to normal. And yeah, that's it for the demo. So let's conclude what we have seen so far. So we started with the first problem as production standard of application takes a lot of effort, right? I mean, it's far simpler than it sounds. Like the problem can involve problems in ownership, like who's going to own the sanity of application. Is going to be QA? Is it going to be the application developers? Is it going to be the SREs? So one, it takes a lot of effort. Two, it has to be maintained, and the ownership can sometimes be not super clear. So in this case, it is automated, right? You don't have to write any sanity scripts. You can add manual checks to handle special cases, but in general, most of the thing would be handled by the ML-based algorithms. Custom monitoring rules or rejects. There's something that you will be writing PromQL with your. I'm sure many would be doing blue-green deployments or candidate deployments. We'll be writing PromQL or NRQL for New Relic, or maybe using Datadog. Different monitoring stacks and different log rejects. Making a developer stick to a specific log types and writing rejects to ensure that you're able to track things. That requires a lot of organization, requires a lot of upfront effort, plus continuous maintenance effort. You need to ensure that as your application is being developed, as it's being deployed, all of that is updated upfront. In this case, almost zero maintenance, because all of that is done by the AI-based algorithm. So you don't have to write anything. Performance can be unpredictable. More often than not, for most of our deployments, we don't do performance validation or performance testing. So here you get that as well, and that too with production traffic. So you can also do this something similar in non-prod, but you can essentially be able to do all of this at each and every state. Things could behave differently if with real user traffic versus synthetic traffic. So you get an easy diagnosis. All of that can be seen. We also have integrations to show you more in-depth information around your performance, around how it has been happening so far, how it has happened right now with the current deployment. And we've also been building integrations for, native integrations for things like Argo. You can still integrate hybrid KDs with Argo CD and the likes, but we're also building native integrations for Argo CD, Istio, and console. So that's coming soon. Kubernetes can be hard in general. It's a complex ecosystem. It's also a very, very fast-growing ecosystem. But yeah, it can be, especially to new adopters, it can be hard. So here it's a quick setup, like I showed you. To convert any application to Canary, just you need to add a file. That's it. And that file is also pretty much templatized. So just need to add details about the application. And the overall agent setup is also, hardly a 2-minute process. So it is super easy to install and get started. That's it for the conclusion. And thank you for having us. I hope this was helpful. And for any questions or thoughts, you can feel free to reach us out at the emails on screen, and would love to understand your use case in chat. Yep, so we have a question from Chandrasekhar. So it supports Linkerd currently, but we also have Istio and console currently in testing. So would love to connect, and you can we can work together to try it out.
If you have any more question, feel free to reach out on the email address, or Discord channel is there. So feel free to ask any kind of question. Or there is a website also. You can reach out Hybrid KTS website, and it's a really great demo, and they are solving a real problem. If you want to learn more, reach out to them. It's nice demo.
Thank you,
Thanks.
Sangam. Everyone.
So let's move to the next session now. So what do you, Shilpa ma'am?
Hey,
So
hello everybody, I'm back
yeah,
with the working setup
so
this time.
yeah. So can you share a
I'll
screen?
share my screen. Yep, you can see my screen?
Yeah, yeah.
Okay, great.
You can go ahead.
We'll get started. Okay, perfect. Hi everybody, this is Shilpa. I work with Dell Technologist as a technologist for DevOps organization for infrastructure solution group. And as part of my job, I'm working with the team of architects to develop a DevOps platform, and we call it Developer Ready Platform. And that is when we stumbled upon the event-driven architecture, which is quite handy when it comes to designing CI/CD, right? So one might think it's not a product, it's not an enterprise application that we are building. Why are we even going that route, right? So we will talk more in terms of why and how you can actually put it to a good use. I'll take a couple of use cases for CI and CD and explain more about that. So we'll quickly go to the next slide. So why part, right? So you all, I'm sure a lot of you are the DevOps experts here, hence the forum, the common interest. So traditionally what we have been doing is using the pipeline ways, right? There's a build, there's a plan, there is a build cycle which goes to the testing, and then it goes to the deployment mode, it goes to the release and circles back. So I'm sure all of you have your code base, which is hooked to a build system, which is hooked to a deployment system, which parallelly goes into testing. If you see, these are all one-to-one relationship. If we are to design a platform which works at scale, which caters to tens of thousands of developers, not just a small team, we need to design it in such a way that it is decoupled, it is integrated, it is scalable. The one that looks at the one looks like this, right? So you have plan, code, build, test, deploy, operate, monitor, but there is no one-to-one integration, one-to-one relation to it. It's all integrated, yet independently scalable, independently changeable. So that is where the event-driven architecture comes into picture, wherein we move from traditional pipelined way of delivering DevOps operations into designing a platform which can cater to a larger organization. Basically, one where we operate at scale. So what does a typical such a platform should look like? It won't be anything different than what a modern application, cloud application looks like today. It needs to respond to event in real time as they happen, brings real time intelligence, deliver responses, experience to the customers. So when we want to do that, what is it that one needs to keep in mind from the design's perspective? Right. So this is where we came across the reactive manifesto. So basically, reactive manifesto talks about how we can enable real-time user interaction, pluggable microservices, extensible streaming and data analytics for a modern day application. So when we convert this in terms of CI/CD bit, is how you provide the real-time experience in terms of be able to deliver the build on time, be able to provide the continuous testing capabilities, to be able to provide the deployments into staging, testing, and production, and also run n number of analytics at the back end, which will help you determine, let's say there are defects in the system, You can do the root cause analysis. There have been failures which could be due to any of the components involved. It could be a machine failure, it could be a VM, network issue, it could be a database issue. You can plug in any number of analytics you want without affecting the scale or without affecting the deliverables which are core to its, right, the CI/CD functionality. So that kinds of enables one to not only improve and the operations but to optimize as well. So at the core of productivity engineering, when we come to the real DevOps organization, this is what matters. We are there to enable the productivity for developers, and we just discovered multiple new ways to do that without affecting the daily runs or the system, right? So how do we do that? This is where I would like to talk a bit about system design, wherein in specific we are discussing the event driven architecture, right? So I'll that we have been using multiple different designs over the year. There were distributed object, there was server SOA architecture, there's enterprise service bus, and there's event driven architecture, and eventually which of them have been built on the previous one. So we'll quickly go to the next slide where I'll explain what is event driven architecture. If anybody has questions, I can't see them right now, please put it either in the chat window or reach out to me during that later on in the show, right? So event driven architecture is most popularly distributed, asynchronous distributed approach. It's one of the simplest event driven architecture. Actually, if I need to quote a example from the real world, right, it's as simple as a thermostat. It's a mechanical device that turns on and off based on the reaction to an event, which is a temperature change. So, an event driven architecture acts in the same way. It detects an event, it reacts to them in an intelligent way. So, to be able to detect these events and react them in an intelligent way, it needs to have certain capabilities. Like you can see, on the screen, we are talking about multiple microservices in the same ecosystem, yet being independent of each other. There is no one-to-one relationship, there is no bottleneck, there is no single point failure, all because we have introduced a middle layer called enterprise service bus, which is the backbone of the whole ecosystem. And it is capable of receiving the events, storing them, and passing it on to the required subscriber. So we will see what do each one of these things do in the next slide. I'm going through this a little fast because this is more of architecture and design point. I would want to spend a little more time on the use cases. So these are there for the reference. You can use anytime, right? So what is an event? Event is a significant change in the state of a system. So in our thermostat example, we detected an event, which means either the temperature had gone up or gone down, right? What does a mechanical device is configured to do when it detects such a change? It will invoke a chain of events which will perform a logical operation, right? So that logical operation is, if I have set it to 26, it's gone to 29, increase the cooling effect for us so that it gets to a desired temperature. In the similar way, when it comes to when it comes to enterprise grade applications, there are event producers, so which provide provide a certain data, these which is responsible for detecting and generating an event. These are the microservices or the modules, or it could be any integrated application which will produce an event. So these are passed on to event bus, a mechanism that allows different components to communicate with each other. In this case, we are heavily using Kafka as an example. So these events come in the form of Kafka topics. Then there is a consumer, which consume the events. By what we mean by that is, let's say there is an event that came in the ecosystem. These would have subscribed to those events, that they detect the topic and act on the data that is received in the topic and trigger the following responses. It could be as simple as, I checked in my code, so GitHub pushes an event in the event bus saying, the PR, code is merged, so go trigger a Jenkins job. So one might ask, I can simply provide a webhook. Why would I want to get into such a complex system, right? So we will get to it, right, in the following In the following slides, I'll explain you why we cannot do that, right? Or what is the advantage of doing it this way. Right. So as we, the one of the ways to actually realize this event-driven system or design an application using event-driven architecture is through event storming. It's basically, a form. It's an activity. It's a group activity. I know I will see what it is in the next slide. I'll take a break. If you have any questions, please do put in the chat. If you have, any thoughts to share, please do that. It will be really helpful to have it more interactive. So here, this is what event storming looks like. So what is event storming, right? So event storming method was introduced and publicized by Alberto Brandolini. This approach is recognized in the domain-driven design community as a technique to rapidly capture a solution design and improve the team's understanding of the design. The workshop focuses on the communication between product owner, domain experts, and developer, hence reducing any of the gaps that will come in requirements by the time the requirements gathered and by the time the implementation is formed. There are quite a lot of gaps that gets introduced. Event storming is a workshop format for quickly exploring complex business domains so that we reduce such gaps and provide a application which is more relevant and which actually does what it is designed for, right? So how do you do this event storming? As you can see, different color boxes on the screen, each one of them represent a event storming activity. So
I think your internet connection is down. Hello. Hello. I think there is some technical glitch, but we'll wait for 5 minutes. If there is a question, feel free to post in comment section related to cloud native, Kubernetes. Uh, so happy to answer, or maybe Go language or a Terrascan. Make sure to subscribe this YouTube channel for the more this kind of sessions. Also, make sure to join a Discord. There are a lot of people in a community, so you can connect with each other. And we are sharing all the resources there in Discord channel. Also, check it out the previous conference. We did a DevSecOps conference, and if you missed those conference, also you can uh, join. Join or watch the previous content. And if you want to contribute any way by speaking or any open source project you want to share, feel free to reach out. We will schedule the event for you. So let's move on to I think, let's move on to the next session. And next session from we have Mahendra from the Infra Cloud. So let me access to the Mahendra. So what do you know?
So today we are gonna talk about building my service mesh from first principles. So let's get started. Before we start, I would like to talk a little bit about myself. So my name is Mahendra Bagul. I work as a senior software engineer at InfraCloud. You can find me on this link /Mahendra Bagul on GitHub. Okay, and my interests are around Kubernetes, Golang, and cloud native technologies. So I have recently contributed to few open source repositories, so please feel free to reach out to me in case I can be any help anywhere. So yeah, so this is gonna be our agenda for today's presentation. So I have divided this presentation in two parts, theory and demo. So in the theory, we will be covering the traditional way of app deployment. We will also see how we were earlier using reverse proxy to deploy our applications. Then we will see the envoy in detail, because this presentation is around envoy only, and we will see how envoy can be used to form a mesh, right? Okay, then we will also talk about the data plane APIs. So just before the data plane APIs, I will also talk about what is service mesh and how envoy plays role there. Okay, so in the demo, I have two demos basically. I will show you how to configure envoy static way, and we'll also talk about the dynamic configuration for which I will be using Go control plane. That's a kind of control plane for any service mesh. So we will talk more about this in the next slides. And in the last, I will also walk you through the code which I have for a dynamic configuration. Okay. Yeah. So traditional app deployment, right? So so this is a like a simpler picture which I have here. So you have users, right? And your users were used to reach to your backend server on the IP, right? On the IP of your server. So this app, it has been deployed over 192.168.1.101:8080. So your users are directly using your server's IP, and so this was like a pretty security wise a pretty full way to deploy the application. So because you just don't have the users, right? You also have attackers. So your attackers will be exploiting the vulnerabilities in your application code or in the operating system on which you are running your code, right? So it was very harmful way to deploy the application. So that's why there was a need to introduce something in between the users and the actual app server, right? So that's where we had a reverse proxy, right, deployed in between your users and app, right? So here you can see now users are accessing your reverse proxy, your application on the IP of your reverse proxy. So 192.168.1.102, that's the IP of your reverse proxy. Also port you can see here, right? So there were again, I mean, different ways to deploy your reverse proxy. You might have deployed reverse proxy on the same physical or virtual machine where your app is running, or you can have separate application, separate physical or virtual machine itself for just running your reverse proxy, right? So here in this case, we have a different IP for your actual application and your reverse proxy. So that means we can assume here that that these are running on two different machines, right? So but again, I mean, this was because I mean, this was okay when we had the monolithic applications, but in the recent past we have seen that there has been a lot of increase in the number of services we are deploying, right? So you're not using monolithic applications now. You are following microservice based architecture, so your number of application deployments, they will be increased over here, right? And you need to, like, I mean, it is very hard to manage with a single proxy or the older way of deployment, right? So now you need to like follow the newer ways of deployment as well. So people try using some kind of orchestration tools like Kubernetes or Docker Swarm. So we will be talking or relating our examples with Kubernetes in the next slides. So as your number of applications are growing, you also are you are also deploying them as pods on your Kubernetes cluster, right? And again, so to manage these many number of pods, or also to get the secure communication between your pods, you need to have some kind of mechanism in place, right? And that's where service mesh comes into picture. So just before that, we can also talk about here. So earlier we used to use we used to make use of this Nginx and HA proxy as a reverse proxy, right? But Envoy is also similar to that. It's like a high performance, modern, small footprint edge and service proxy. So in this diagram, this may be called as edge proxy because that's very close to your users, right? So service proxy, we will talk about it later. So it's most comparable to, as I said, it is like a load balancer or earlier reverse proxies only. So like Nginx or HA proxy. And the cool thing about it is that it is an official CNCF project. So we are now seeing the in detail view of the Envoy proxy. So again, we have the clients who are reaching to your backend servers over the internet. And yeah, the first envoy which they see is the front envoy. So it is also called as an edge envoy, right? Or edge proxy. And also behind that envoy or behind that proxy, you have multiple services, right? So you can see, I mean, you can have this microservice based deployment or a monolith. So here you can see legacy PHP monolith that's also running behind your front envoy. But the interesting thing to notice over here is that it is also running something. So there is envoy running with every other service. So these instances of the envoy, they can be called as a service proxy because there are 3 services and 3 different envoys are running along with every services. So they are like companions to your actual services, right? So they can be called as a service proxy, right? And then whenever, for example, this Go service is talking to your legacy PHP monolith, this will not be talking to each other directly. So the communication will happen through the envoys which are there along with them, right? So, and these 3 envoys, they are like n number of envoys, they will form a mesh, and as they are running with services, so that is called as a service mesh basically. So having service mesh offers multiple benefits. So one of the benefit can be to get the statistics of the traffic. You can trace multiple things. You can also do rate limiting, and discovery like mechanisms can also be achieved using a service mesh, right? Let's go to the next slide. So you may be like now having questions how to configure envoy in your deployment, right? So to talk or to understand it better, we need to know the internals of envoy proxy. So so there are 2 parts. So as I said, envoy or any proxy sits between your clients and your backend servers, right? So clients and backend servers, and in between them there is an envoy proxy, right? So whatever is there towards clients, it is called as downstream. Okay, whatever is there towards clients, it is called as downstream, and whatever is there towards your backend servers, it's called as upstream. Okay, so your backend servers, they will be called as upstream as well. In the code blocks, in the configuration code blocks, they will be called as upstreams. Okay, and these are the building blocks or configuration blocks of the envoy. So you have a listener. Okay, so this listener is also an you can configure multiple listeners for your single instance of envoy. Then every listener will have a network filter chain. Okay, so it's a chain, so you can have multiple filters over here, and every filter, it will have multiple routes. Okay, so routes is nothing but the path, URL path, right? So because your envoy will be reached, your envoy can be reached on a certain IPN port, and if we append any path to that IPN port, then it will form a route, right? And for example, if I'm trying to reach localhost colon 10,000/accounts, right? So accounts is my route here, and to handle that request, I need to have a backend server configured, right? So the backend server can be configured using cluster. Okay, so cluster is like a terminology in an envoy. So I will show you in the static configuration.yaml, which I have in the code. So you can basically configure multiple backend servers as well behind your single cluster. For example, in this diagram, right? So just behind your front envoy, there is a single Go service, right? But I can have multiple instances running of the same service, right? And I can do the load balance between this among these services from front envoy as well, because front envoy will have the clusters array, right? And the clusters array will have the load balancer, and that will be balancing the load across the multiple instances of the Go services, because Go service might be like having much load, right? So we may need to like spin more instances of these Go services, just for Go services. And that's the beauty of using elastic environments nowadays, right? Because you don't need to scale up everything in your software suite. You just need to scale some of the services and your application will be running smoothly, right? And your users will be happy. Let's go to the next slide. So these are basically the configuration blocks. So I have already talked about the listener. So listener, you can configure multiple listeners as well for a single envoy. But again, for a single listener, you can configure multiple filter chains. A single filter chain will have multiple routes. A single route can have multiple clusters, and a single cluster can have multiple endpoints as well, right? So let's talk about them in the next slides as well. So you can configure the envoy proxy two ways. So static configuration and dynamic configuration. So whenever you are doing static configuration, that time you need to restart your envoy instance, because the configurations cannot be reflected if you are not restarting it. So and then there is a dynamic configuration way of doing it as well. So we will talk more about this in the next slides. So let's go to our first demo, which is about static configuration. Okay, so let me walk you through the static configuration.yaml which I have. So I have got this simple project, simple sample project. So here you can see I have static configuration.yaml. So for the first demo, I just need this file. So I will talk about this in a while, then also about node in a while. So let us focus on the static resources. So let me divide my screen so that we can just compare the slide content with the code blocks which I have here. So if you can see this, I have listener over here, right? So the same way I have it in my slides. So listeners, right? So it's an array. So I can have multiple listeners, right? So as of now, I just have one single listener. So in my whole static configuration YAML, I just have two things: listeners and clusters. So these are the bare minimum things required. You can configure multiple things as well, but for the sake of simplicity, I just had one entry in every array, and only the required elements. So listeners, right? So I have a single listener, and in the listener chain, as I have mentioned over here, I have a filter chain as well. So filter chain is again an array. Okay, so in that I have filters. So for my envoy HTTP connection manager filter, right, I should have now routes, right, somewhere defined. So routes can be configured using virtual host. So if you know Nginx, then in the Nginx as well, you configure your backend server details, upstream server details using virtual host only, right? And in the virtual host, you can see for /route, right, in the routes array, in the routes array, as a first entry, I have a slash. So for every slash request, I will be rewriting my request to www.linkedin.com, right? And here I have mentioned something called cluster. We will see what it is in a minute. And then I am rewriting that route with /robot.txt. So whenever, for example, I'm hitting the invoice IP and port, that time invoice IP and port, right? Because I'm not specifying anything over here. So invoice IP and port /. So that will give me, or that request will be basically handled by www.linkedin.com/robot.txt. So whenever I'm calling invoice IP and port, I should get the robot.txt of linkedin.com as a page, right? And then I have filters over here as well. So let us see what this service LinkedIn means, right? So it's defined in a cluster. So I have another entry in cluster, right? So listener and cluster, they are part of static resources. So in the cluster, I have a cluster called service LinkedIn, which was defined over here. So from from route to cluster, the linking is here. And I now need to also mention what is the server and what is the port for this route as well, right? And that I mentioned as an endpoint in the clusters, right? So cluster has a sub element called endpoints under load assignment, and in the endpoints, again, I mean, that is an array. So in the endpoints, I will be adding the address for linkedin.com and the port value there as well. Okay. So let us now, let me maximize this screen first, and let us try running it. Yeah, so I'm running, I have basically copied this envoy. So I have like added the commands in readme.md. So if you want to run it or try it on your local, then you can go to this readme.md and try on your own as well. So I'm using this /-c, that is configuration, right? So static configuration .yaml will be considered now. And now I will try to reach to port colon 10,000. So that I have configured over here under listeners, right? So listeners and then port 10,000 here I have configured, right? So let me hit this first. Yeah, so my envoy is running. Okay, so this is basically so I can say for linkedin.com /robot.txt I have envoy, right? So let me local. Yeah, so I hit the request localhost colon 10,000 and I can see the LinkedIn's robot.txt. Right? Can you see LinkedIn's? It is LinkedIn's robot.txt. Yeah, so this should be my first. This should be the end of my first demo. So let us talk about the disadvantages of this approach. So if I had any changes, right, in the configuration, then I will need to restart my invoice instance. So what I mean by that is, for example, if I want to now redirect to if I want to get the robot.txt of google.com, then I need to modify over I need to modify my routes as well as the cluster, right here, right? And then to take effect of these changes, I need to restart. I need to kill my earlier running instance of envoy, and then I need to restart. And then if I go now over here, then I can find Google's robot.txt, right? So this is the main disadvantage of using static configuration, right? And it is when you are having multiple services running behind your envoy, then it is definitely not a feasible way to do it, right? So yeah, so moving on to next slide. So with this understanding, let us now try understanding what service mesh is. So I'm again considering here Kubernetes, right? So you can see there are pod 1 to pod n, okay, and there are multiple services deployed, like service 1 to service n, okay, and they are running inside pod, and along with these services I am also running a sidecar container, right? So this is a service proxy, right? So if service 1 wants to talk to service 2, then the communication will happen through the service proxies, right? And also to modify the configuration of these sidecar containers, I need to have some mechanism, because I cannot directly go to the pod's sidecar container and modify the configuration of it, right? So I need to configure these services, this service proxies configuration from somewhere remote, right? So, and that can be done from the control services, right? So I will have some component running over here, and that component will be basically updating the configurations in these service proxies. So configuration is not just the thing which service mesh provides, and I think I also miss what service mesh is by Wikipedia. So Wikipedia says that it is a mesh. So mesh is a dedicated infrastructure layer. So you can say this is a dedicated layer right here, which facilitates the service to service communications, right, between services and microservices using proxy. So we are using here envoy, right? So envoy being proxy, and we are again facilitating the communication between the services, right? But again, these pieces, these components, they also need some these pieces also need some changes over the time, right? And those changes are basically controlled via the control plane components. Okay, so every service mesh out there in the market, they will have two types of components: data plane components and service and control plane components. So Data plane component will also will always have a kind of proxy. So in this case, we have an envoy over here, right? So to control to have the uniformity, what Envoy has done is Envoy has provided its data plane APIs. Okay, so data plane APIs, they are basically implemented by any control plane components. So if we talk about Istio has implemented the data plane APIs to have Envoy running on their data plane layer. Okay, so data plane APIs, there are these 5 types of data plane APIs are there: listeners, endpoints, routes, clusters, and secrets, right? So for every component which we saw earlier, component or configuration block, we have a discovery service. So this blue line, right, so it depicts that data plane component, and in this purple color line, it depicts the control plane. So control plane has implemented these services, and then these these components are controlling the configuration of this envoy proxy, right? And you can find about the data plane APIs more on this link. So it's from envoy proxy itself. And if you have Istio based setup along with envoy proxy in your Kubernetes cluster, the setup will look like this. So you will have service, for example, here service A is there and service B is there. They are talking to each other via proxy, right? That communication can be MTLS or non-secured as well. So so this is pretty old diagram. So now what Istio has done is they have aggregated every component. They have aggregated every component into a single binary. Earlier there used to be multiple binaries for these components, but now there is a single binary. And Pilot was basically the component who used to push so I mean, it still pushes the changes, configured data to the proxies. So you can say Pilot is the implementer of your data plane APIs. So Mixer was the component, or Mixer is the component to do the policy checks and telemetry. And Citadel, it will basically handle your TLS certs to the proxy. So when you want to have the MTLS setup between your between your services, then that time you will be using the Citadel to distribute the certificates. And again, as mentioned over here, Pilot, Mixer, and Citadel, they are the part of control plane API, right? So let us now see the dynamic configuration. So I have simple program which I have achieved using which I have added or developed using the Go control plane. So if we compare Go control plane with Istio, then Istio has also implemented data plane APIs, right? So Go control plane, it also implements data plane APIs. So here you can see I have a front proxy running, right, which is envoy, and then I have a main.go. It is basically using Go control plane, and it is running an infinite loop. Okay, after every 30 seconds the loop will be executed, and so in that loop what I'm doing is I'm reading domains.csv. So domains.csv, it basically has 3 different entries. Okay, so these 3 different entries represent 3 different servers. So I have these REST servers running using JSON server npm package. Okay, so whenever I add the server or remove the server, I modify the domains.csv, and then that change will be picked up by this main.go, and the configuration will be passed on to the envoy, right? So this domains.csv can be replaced with any logic which your requirement suits. So and then you can just make use of the Go control plane in your project. Okay, so let's see the demo. So I need to now go to my project again, and let me walk you through the few folders here. So certs has basically the certificates. So I have certs.sh, which is having OpenSSL commands. Okay, the main thing to notice over here is that this. So I have a cn configured DevOps indiacon.kubedeli.com, and I have generated the certificates accordingly using this OpenSSL commands. So just the server certificates for the envoy which I'm running here, right? So the user will be accessing this envoy using certificates. Then I have sample servers, accounts, posts, and profiles. So if I compare this diagram with my code, so I have these posts, profiles, and accounts, different servers over here, right? And yeah, I'm using JSON server, right? So JSON server is a simple utility from Node.js, which so these JSONs, I will just be using these JSONs to, along with JSON server command, to start the fake REST API. Then I have src folder where I have domains reader. So domains reader is just it's just having a simple function to read the domains.csv and return the domains from that file. So let me also show you the content of domains.csv. So here you can see I have got two entries. So profiles and accounts, these are the server basically added to your Envoy instance as of now. Okay, so let me first remove this. So I will just add the profiles and then we can have the demo. And then I have a domains dynamic configuration.yaml as well. So I had missed telling you about this in the static configuration demo earlier. So admin, this block will make the admin dashboard available of your Envoy on this port, 9000 port management. So management UI will be available on this port for your Envoy. And then you have dynamic resources, right? So earlier in the static configuration, we had static resources, right? But now in dynamic configuration, we have dynamic resources. In the dynamic resources, what we need to specify is that ADS config. So I had talked about 5 different discovery services, right? So listeners discovery service, and endpoint discovery service, and 3 more are there, right? So to have the configuration or to pass the configuration of all these discovery services, we can use the aggregated discovery service. So you can either config for every other discovery service, or you can just use ADS. And the API type will be gRPC. So communication from your Envoy to your Go control plane, right? So from this main.go to this will happen over gRPC. Right, and then if I go down in the static resources part, because this should be static, the only static resource part will be the connection from this Envoy to main.go. So here I'm specifying that so my management server, you can see here XDS cluster, right, and it is available on this IP local, the loopback IP, and then the port 18,000. So 18,000 will match in the main.go. So main.go is like a driver program, I can say, management server port, right? So this is let me also show you go.mode. So go.mode is it has an entry for Go control plane, right? So in the main.go, the main thing which we need to notice is this. So in the main function, you can see I'm starting control plane, okay, and then running my management server, right, on this port. So the port is 18,000, which is mentioned above, right? And this is the infinite for loop, right? Here what I'm doing is I'm building the domains reader file, domains.csv file. Then I create cluster, I create listener, right? And then I create secret, I create snapshot, and the loop will be sleep. It will go in a sleep state for 30 seconds. So every 30 seconds this loop will be iterated, basically, right? So create snapshot, it basically sends request to your Envoy instance, right? So for example, every 30 seconds what will happen, it will create cluster, listener, secret, and then it will create a snapshot. So the request will be, so what if there are any new changes, then those changes will be passed to your Envoy. Okay, so let me also show you what goes here in create cluster. You can see I'm iterating over the domains, right? The domains which I have read from the domains.csv. Then I create a cluster for every entry, right? And then similar stuff happens for create listener. So in listener, code will not be dynamic, because listener, we just have one single listener over here, right? So it's this listener is 10,000 for your Envoy. And then in the create snapshot, it is basically a request to your, so it handles like in the Go control plane library comes into picture, and it will be patching the updates to your Envoy instance. Okay, now let us do one thing. Let us first start your Envoy. Okay, Envoy. Yeah, so here I'm starting, or what I can do is I can run main.go over here, because I need to start multiple terminals now. So here you can see management server listening 18,000 on port 18,000. I have 3 blocks over here. Let me open one another as well. Right, so here I now need to start the JSON server. So you can see here on port 10,003 I'm starting, and on IP 1.3 I'm starting accounts.json. Okay, so I'm starting over here. So if I go to 10,003/accounts, you can see 2 records over here, but I'm reaching to that server directly. Now I need to add reverse proxy in between this service. So what I need to do is I just need to add entry for my accounts in the domains.csv. So to do that, what I will do is I will go to domains.csv, and I will see yeah, there is already entry present, right? So on 1.3 10,003 port /account is already added, right? So this change was already picked up by the dynamic envoy, right? So to do that, what I also need to start envoy. So here I am starting envoy with the dynamic configuration. So you might have seen here, yeah, can you see the service 192.168.1.63 it was added, right? We can observe that as well, because it will, yeah, it will be continuously updating. So what we can do is now we can go to 10,000 port and then try reaching /accounts, right? Yeah, so this is being reset because I have configured certificates as well for my envoy, right? So now I need to go to the third window, and here I need to use the curl command. So here you can see curl. I'm using host DevOps indiacon kubedaily.com, because that's the SN SAN I have configured, or sorry, CN I have configured for my certificates, and it resolves to this. I have also added an entry in /etc host. So here you can see, right, it just redirects it to my local, and I'm using this https:// this URL :10,000 and /account. So if I do that, I should see the records over here. So it is now basically pulling the records from this server running behind your envoy, right? So now what we will do is so without killing envoy instance, what we will do is we will try accessing another server. Okay, so the another server is basically the profiles one. Okay, so let me do one thing before that. So if I now just modify this thread, because I just need to change my route over here, right? So if I do profiles, I won't get anything because my server is not running, right, behind my envoy. So to start my server, what I need to do is I need to use the JSON server command again, and it should run on port 10,002 because 10,003 is already running. And then yeah, now on port 10,002 my profile server is running, right? Now let us do one thing. Let us try accessing it from here. I'm still getting nothing because I haven't added this entry in my domains.csv. So domains.csv, after adding entry to domains.csv, the entry will be read by the main.go right here, and then the snapshot will be created with that entry, right? Main.go, then the snapshot will be created, and then the envoy will be patched, right? So as of now I haven't added any entry to domains.csv, so we need to add that entry over here. So here you can see I have just added 10,002 port and /profiles. So let us wait for the iteration. So it just happens, so it will take 30 seconds. and we will also, like, meanwhile, we will also delete this account. So account slash accounts will not be available, but slash profiles will be available. So we can see the both of the demo, add and remove at the same time. Yeah, so here you can see slash profile was picked up, right? So creating cluster, target host, so 1.3 and profiles was picked up. I have removed accounts, right, and added profiles now. So without any modifications or without any restarting of my backend, my envoy, I now should be able to access my profiles. So can you see I am able to retrieve the profiles now, but at the same time I shouldn't be able to access my accounts, right? Because accounts I have removed it. Yeah, so here you can see that the change was propagated to envoy without restarting your envoy instance. So this is very handy when you have multiple services running in your infrastructure and you don't want to modify the configuration on your own, right? So I think this should be the end of my second demo as well. And yes, we are hiring at InfraCloud. So you can go to this page, www.infracloud.io/careers, or you can just send your resumes on careers@infracloud.io. And this wraps my presentation as well. So thanks everyone.
So this nice presentation by Mahindra. We have a next session by Ritesh Yadav. He'll be presenting and talking about around Terraform. Over to you, Ritesh.
Yeah. So hello everyone, welcome to DevOps India Conference 2021. And let me present my slide, then we can move ahead. Let me share my screen. Okay, I guess my slide is visible to all of you. So someone confirm that
Yes,
my slide is
it's
visible.
Yeah.
Okay. So let me introduce myself. So I am Ritesh Yadav. I am currently working as a data scientist at ineuron.ai. I love to build scalable and efficient machine learning and deep learning models. And at the end of a day, I used to productionize them on the cloud platforms such as AWS, GCP, and these all. I am also the maintainer of Cloud Native Computing Foundation project named as Porter. So at Porter, we are building, it is a project regarding the cloud native application bundles. So you all are welcome to contribute to the project. So I also love to contribute to the open source organizations. Previously, I have worked with Knative, Thanos, and more. Like I'd love to contribute to open source, and I love to learn some DevOps and GitOps tools, and love to apply them to my day-to-day pipelines and see what kind of things they are doing. So for today's talk, I'm going to present about like how you can automate your infrastructure provisioning using Terraform. So what is our today's agenda is we are having birth of Terraform. What is Terraform? We are going to see what is infrastructure as a code, Terraform alternatives, and then we are going to see why we need to choose Terraform, why Terraform is used by such a large industries, such a large big organizations. Then we are going to see some kind of a configurations, what are state files in Terraform and what are backup files and these all. At the end, we are going to have a look onto how you can automate your whole infrastructure provisioning process using Terraform with integration of Jenkins. We are going to see a pipeline, how you can build that pipeline. Then at the end, a beginner-based demo over Terraform, a provisioning of some kind of a resources over AWS services. So let's begin with the birth of Terraform. So Terraform is a infrastructure as a code tool. If you search in Google about Terraform, so you will get a simple definition like Terraform is an infrastructure as a code tool, which is used for managing, provisioning all your cloud resources, all your resources onto the cloud services. whether it is a GCP or Azure or AWS, Alibaba, Oracle Cloud, any cloud, you can provision resources using Terraform. Second, it is created by HashiCorp. HashiCorp came up with this idea, and the man behind this tool is known as Michel Hashimoto, who is the developer of this tool, who has came up with this idea in 2014. And from 2014 till 2021, they have currently supporting having an integration of 100 plus cloud providers. You just name it, they have an integration. They have an integration or a plugin for that cloud provider, whether it is Amazon Web Services or it is a Google Cloud Platform or Azure. Now, how Terraform is revolutionizing the industry? Like what Terraform is doing, how industries are taking Terraform into day-to-day process. So all the thing inside the Terraform is defined by a single term, which is known as infrastructure as a code. So what is infrastructure as a code? So infrastructure as a code, you can say, is a way to perform all the tasks of provisioning of resources. Let's say you want some kind of a serverless function for your application. Let's say you want some kind of a EC2s or S3 or data lakes you can easily provision them onto the cloud using infrastructure as a code tools. So infrastructure as a code, you can say, in this process, we are not utilizing any kind of a we are not doing any kind of a manual process, like we are taking a Linux instance and performing all the operation like we do on-premises setup. Like in on-premises, we take some kind of a Linux instances, create some kind of a resources inside it, provision our whole architecture into a in-house setup. And so what is the problem in that setup? If we see in 2009 and around 2009 and 10, when AWS is in the market, AWS has launched their few of the services like EC2, S3, and few more. So, but the problem is that it is very costly for the organization to afford. They are trying to move towards the cloud services, but cloud services has their cost of, you can say, let's say they want some kind of a Linux instances like EC2. So EC2 charges are too huge, but the problem is they continue to use on-premises infrastructure. So on-premises has not a big on-premises infrastructure do not have some kind of a big problem. But you can say, let's say you have a cluster of Linux machines, cluster of Linux instances. Now it will create a problem for you. Let's say you want to scale it up. You want to perform some kind of a scaling. You want to update some kind of a resources. You want to modify some kind of a resources. Let's say at the end of a day, you want to delete some kind of some Linux instance, not all, in on-premises infrastructure. So it will cause a problem for you. You will end up wasting a lot of time in doing these all process manually. So what AWS is came up with their solution known as Cloud Formation. In a similar way, Azure came up with their solution, Azure Biceps. So AWS Cloud Formation is one of the best solution which is present in the market for infrastructure as a code tool. So when you are using AWS Cloud Formation, you just define a particular template, whether it is in a JSON. You define a template, you list down all the resources from, let's say you want EC2, you want a Lambda function, you want CloudWatch monitoring, you want CloudWatch for monitoring the logs. You just define into a AWS Cloud Formation and take that file, put it into the AWS, you can say some kind of an engine where we are going to put that Cloud Formation file, and boom, it will create all your resources. It will launch all your resources. In a similar fashion, we can see about Azure. Azure Biceps is one of the famous solution by Azure. So it also gives you some kind of an infrastructure as a code tool. So we can use that. It also perform the same operation what AWS Cloud Formation do. But the problem in these both two are, they are not cross-platform. Let's say your team is working on AWS. Now they want to shift their whole infrastructure to Azure. To shift their whole infrastructure to Azure, it is a very tedious task. there is nothing as you can say plugin or any integration available to shift your code, your whole infrastructure to the Azure. To perform these all kind of operation, let's say another day you want to shift your infrastructure to Alibaba, which is not too much known cloud. So you can, it is very difficult for you how you can do that. So to perform these all kind of a operation, we have came up with, or you can say HashiCorp is came up with a solution known as Terraform. In 2014, HashiCorp has performed its first release of a tool known as Terraform. So Terraform has a inbuilt support for 100 plus cloud providers, more than 100 plus cloud providers. This is just a number. They are working day and night to give you some kind of a integration in every cloud providers. So in Terraform, you just need to write some kind of a script. Just need to write some kind of a script and just give it that script and apply some kind of a commands like plan, init, destroy, like plan, init, and build, and all the things will be done. So to perform these all kind of the operation, Terraform has came into the existence. Like it is supporting the cross-platform. Let's say you want to switch your configuration to Azure, you can do that. There is a keyword known as provider inside it. Just change the provider. It will do each and every step, and just apply 2 to 3 commands like Terraform init, Terraform plan, Terraform apply. It will be done in a seconds. So this is the, you can say, why we need to choose the Terraform. Terraform is one of the famous solution which is present in the market to give you the cross-platform integrations, cross-platform infrastructure as a code tool integration. So there are a lot of alternatives or Terraform are also available onto the market. So the first alternative is, you can say, the first one is the Crossplane. So Crossplane is one of the alternative. Crossplane is the one of the big organization which is present into the, you can say, which is the part of Cloud Native Computing Foundation. It is an open source infrastructure as a code tool. Then we are having CloudFormation, AWS CloudFormation. That's what we have taken a look. AWS CloudFormation is a famous tool which is used by many of the, you can say, tech giants. Let me, I guess, present. Okay, sorry for that. Let me present it. Okay. Okay, so Crossplane is one of the famous solution which is built, which is the part of the Cloud Native Computing Foundation. Then we are having Amazon CloudFormation, which we have seen. It is relative to, you can say, it is built for AWS. It is only built for AWS. You can't switch your configuration to Azure or any cloud service. Then we are having Plumi. So it is also the one of the famous infrastructure as a code tool. And this is Azure Biceps. This is one, the Azure Biceps, which is built by the Azure as an infrastructure as a code tool. And then our famous tool, which is known as Ansible. So Ansible is also capable of performing these all kind of stuff, like provisioning of resources, provisioning of infrastructure onto the cloud. But there are some kind of a lag in Ansible. As you can say, this is not a orchestration tool. This is a configuration management tool. But Terraform is a orchestration tool. Terraform is used to manage the life cycle of your whole, you can say, whole infrastructure provisioning. You can use Terraform to manage your whole life cycle. Let's say you want to update your resources. Take Terraform, you can do that. Just apply 2 to 3 commands. You want to destroy your whole infrastructure, you can do that. But in Ansible, we write playbooks, and it is little bit difficult to perform these all kind of the operations. Okay, so if you have any questions, you can just drop onto the chat. At the end, we can have a quick Q&A session, so we can take a look onto your questions also. Okay, so how Terraform works? What is the, you can say, what is the working of Terraform? How we can configure your Terraform in our system? Now, in Terraform, we have a particular domain-specific language. We have a domain-specific language, which we are going to talk in the next slide. So in Terraform, we will create a config files, which are known as .tf config files. So .tf is the extension for Terraform. So if you are having Terraform files, you will generally see .tf at the end. So it is the Terraform configuration file. Then we are having Terraform CLI. So Terraform CLI is the common thing, like the CLI which you usually get. Let's say you have installed AWS CLI, you have installed SAM CLI. In a similar fashion, we have a Terraform CLI by Terraform. By HashiCorp, they have provided the Terraform CLI. So you can interact with your resources, you can manage them using Terraform CLI. So Terraform CLI used to create and disk changes and destroy the resources accordingly. So you can say in CloudFormation, we use JSON. In a similar way, we are having SCL in Terraform. So what is SCL? SCL is a HashiCorp configuration language. So it is very similar to JSON, but there is some kind of a difference which they have created inside it. So you can see this is the syntax of the HashiCorp configuration language. So inside that we are having data. So this is the data sources. Then we are having resources. So resources are the resources which you are going to provision onto your system or onto your cloud. Let's say you want to provision CloudWatch. So Terraform has a documentation how you can provision CloudWatch onto the AWS. Let's say you want to provision some kind of a serverless functions. So Terraform also has a documentation for it. Next, we are having, you can say, this is the whole configuration of a simple EC2 instance, which we are going to see a demo at the end. This is the whole configuration of a simple EC2 instance, how you can launch a T3.micro instance onto the cloud with single click. So this is the whole HashiCorp configuration language. This is how it look like. Okay, then we are having some basic commands, some basic CLI commands, which we are going to use in our demo. So some basic CLI commands are Terraform plan. So what Terraform plan will do? It is similar to, you can say, it will show you, it is similar to git diff. If you have ever used the git diff, so it will show you the same thing. It will show you when you execute the Terraform plan, it will show you all the resources which you have selected, all the resources which you have not selected. All the resources, let's say we have selected the EC2, it will show you the that you have selected the EC2. This is the, you have selected some kind of a, let's say you have also selected the Elastic IP. It will also show you, you have selected the CloudWatch. It will also show you onto the, after when you execute this command known as Terraform plan. Then we are having Terraform apply. So Terraform apply is used to apply your whole configuration. And this is the interesting part of Terraform. So Terraform apply is a single command, which you when you enter this command, it will provision all the resources onto the cloud. It will provision all the resources onto the cloud in a single go. In a similar manner, we have applied it. Now let's say we want to destroy it. You can destroy it in a single click. Just perform some Terraform destroy. Your all resources will be destroyed, which you have provisioned onto the cloud. Let's say you have provisioned some resources like EC2, which you are going to provision now. So it will be destroyed in a single click. Like Terraform destroy, all the resources are destroyed. And it is a very good command. Like if you are using some kind of a, let's say you are performing some manual process. You are performing some manual process, like you have set up 10 EC2 instance and some of the databases like Aurora and DynamoDB, these all. Now it will be difficult for you. Let's say you want to only delete 4 to 5 EC2 with a particular ID, of it. So you can do that using Terraform easily. But if you are performing these all operations using manually, then it will be very difficult, and it is a very tedious task. Like you go to each and every resources and check what is the ID. This is the ID, and then click on it, terminate instance, and it will take a lot of time. So to perform these all operations, Terraform destroy is one of the best command. And there are a lot of commands which are present into the Terraform, like Terraform init is used to initialize your provider. We will see it in a demo. Okay, so now inside Terraform, whenever you apply commands, let's say you have applied Terraform init, so and then you have applied Terraform plan. Terraform plan is an optional command. If you don't do it, it will be like, it will also work. Then let's say you have performed Terraform destroy. So what Terraform destroy will do, it will destroy your whole infrastructure, which you have provisioned onto the cloud. After that, it will create 2 files. It will generally create 2 files. The first file is terraform.tfstate. So what is the use of terraform.tf state? So it is, you can say, it is used to store some kind of a state, the current state of your infrastructure. Let's say you have provisioned 2, you have provisioned the 2 EC2, then again you have changed the number of count inside the Terraform configuration file, and you have changed it to the 5. So what this will do, it will store your each and every state. Let's say you want to perform, you have done Terraform apply, it will store, now it will change that number. In the previous, you have applied Terraform, you have applied 2 EC2 instance, now it will initialize 5 EC2 instance. So it will, you can say, it is kind of a memory cell. It is a kind of a memory cell which will store each and everything what you are doing with the Terraform. So this is known as Terraform TF state, and we generally say it as a state file, which is used to store some kind of a state of the whole HashiCorp configuration files. Then we are having terraform.tf-state.backup. This file generated after when you destroy your infrastructure. Let's say you have created your infrastructure, you have destroyed your infrastructure. So this file will be created whenever you destroy your infrastructure, so that it can have some kind of a backup. As the name suggests, it has some kind of a backup, terraform.tf-state.backup. So it will store all the backup of the previous configuration which you are having. Okay. Cool. Then we are having, let's see what all things we are having. Okay, so how the end process will look like, what we are going to do now. So this is the whole end process will look like. So this is the image which is taken from Google. So to cite this, so here we are having few files like terraform.state, terraform.tf-vares, terraform-provider.tf, and terraform-instance.tf. So those who are familiar with Terraform, they got to know what we are going to do. And those who are not, let me give you some quick introduction of what these all files are going to do. In Terraform, we can perform these all operations in a single file also. We can perform in a single file also. But what we have done, we have separated these files according to their purpose. Let's say we want to terraform-provider.tf will store the name of the provider. Let's say we want to provision our infrastructure onto the AWS, it will store the provider we will mention is AWS. Let's say we want to initialize our, or you can say provision our infrastructure onto Oracle Cloud or GCP, it will store all the, you can say, it will store the name like provider equals to the name of your provider. What is the name of provider? It depends on your choice. Let's say you are taking GCP, you will write GCP. They have some kind of a API. So API will talk to AWS and send some kind of a request to AWS. So here AWS just provision these all resources. So it will provision all your resources and it will be done in a seconds in any cloud you can have. So terraform/-provider.tf will initialize all the thing, which is you can say for a particular cloud service. Then we are having terraform-instances. So it will tell you, here we are going to write some kind of a EC2 configuration, like what all are the security groups, what are the inbound and outbound rules, each and everything we are going to specify in the terraform-instances.tf. So in this, everything will be mentioned, like whether we want a public IP, whether we want attach some kind of elastic IP to it, whether we want some kind of a CloudWatch resources, whether we want to attach some kind of a notification service like SNS, each and everything will be mentioned inside this terraform-instance.tf. And more generally, this is used for writing the instance part. You need EC2, write that onto this. Let's say you want some kind of a S3, create another file, terraform-s3.tf, and write its configuration onto that. So this is all about, you can say, these two files. Then we are having terraform.tf-vares. So in this, we are going to initialize some kind of a variables. Let's say we want to use instance type is equals to t3.micro. So to provide a clean architecture, clean look, so what we are going to do, we are going to initialize all our variables inside this terraform.tf-vares. And at the end, this is our state file, which is auto-generated. So at the end, we are going to collab these all files and send it to the Terraform, and Terraform will ask to AWS, hey, it talks using API. So it say, hey, AWS, just provision these all resources onto and create one kind of a infrastructure. So you can easily do that. So let's see some kind of a hands-on over how we are going to perform, how we are going to instantiate a EC2 instance onto the cloud. Okay, so anyone, let me know whether my terminal screen is visible or not, so that we can start with the.
Yeah, it's visible.
Okay, thank you, Sangam. Yeah. So here we are having a lot of files, so don't get scared. Those who are the beginners. So let me hide this. You all take my secret key and access key. So here we are. Let's move towards EC2. Let me walk you through these all. Let me zoom it. Okay. So let me walk you through this code structure. So here we are having EC2 input.tf, output.tf, provider.tf. This is the file. These all files like tfstate, tfstate.backup, .tfware. Okay, so that tfstate and tfstate.backup, it is created, you can say, automatically whenever you are instantiating, or you can say whenever you are initializing your Terraform, it is created automatically. Okay, then we are having this EC2. So EC2, this is used for provisioning of EC2 resources onto the cloud. So what I have done, so I have separated all the things into different files. Let's say I want to talk to provider. So for talking to provider, I have taken this file. So provider AWS, here is the access key and secret key and region. So here you can talk to any provider. Let's say you want GCP, you can talk to GCP also. You can take Alibaba, you can take Oracle, any provider. Okay, this is the region. In which region we are going to talk, in which region we are going to provision our resources. So this is the region. Then we are having our ec2.tf. So this is the main file. Inside that, I've taken a small configuration, not too big. So this is in the resources. I'm mentioning the resources. So what I need AWS instance and giving a good name to it, like ec2_example. So then AMI ID. So you all know what is AMI ID. So AMI ID is the Amazon machine ID. So Amazon machine ID is a unique ID which is available in each and every zone. And one thing to notice here, one thing to take care of. Let's say I'm provisioning my resources in US East 2. So if any one of you is checking these all files and provisioning their resources, so make sure to change your region, because this AMI ID is differ from region to region. Let's say you are in the AP South 2, the Mumbai region. So you will have another AMI ID. So try to be sure to change this AMI ID. Okay, then we are having key name. So this is the key name. This is the you can say the optional thing. This is the key value pair, which we at the end we get a key name. That we, in a general process, when we are doing when we are initializing the EC2, we download that key pair and store it onto our system, create some kind of a using putty to connect to the SSH. We create a PPK file and use that. So this is what the key name. This is the key name which is available onto my AWS console. So, and this is the name and tag. So this you can use any. So, okay, then we are having, let's see, we have seen the EC2. If you have any question, you can drop onto the chat. At the end, we can take a look onto it. In the input, you can specify the inputs which you want to give. Let's say I want to give this key name as an input. You can specify it. By default, I have left it blank. Then we are having an output. So what all output I want? So I want a public IP. After applying all the resources, give me this output. These all output. I want public IP, I want ID of my AWS instance, I want AZs, availability zones, and at the end I want public DNS. So give me these all output at the end of when I'm doing some kind of a Terraform apply. So list down these all resources in the command line. Okay, we have seen the provider. Now what is tfstate? So you can see I have previously used this template. So that's why it is showing me some kind of a JSON file. You do not need to write it. This is auto-generated. This is automatically generated by the Terraform. Our main task is to see the Terraform.tf files. So as I mentioned, we are going to mention some kind of a type of the instance, or you can mention any kind of variable that you want onto your resources. Let's say you want a CloudWatch, you are initializing a CloudWatch, so you can write a variable like CPU utilization should not be more than 4%. You can write it in the terraform.tf var and import that, or you can say import this instance type onto this provider, onto this ec2.tf like I have done. Var.instance type, this is known as formatting in HashiCorp configuration language. Formatting similar to what we are doing in C++, what we are doing in Python. In a similar way, there is some kind of a formatting which we also do in the HashiCorp configuration language by writing any kind of templates. Okay, so this is about the TFR. So TFR I have mentioned, I need an instance named as t2.micro. Okay, then we are having a variable. So variable are used to, you can say, to initialize that variable. Okay, so I have used this variable here, but I need to initialize that variable anywhere. So for initializing that variable, I have used this variable.tf files. So okay, so now let's run this whole configuration. Now let's run this whole configuration and take a look onto it. Okay, so let me increase this font of my terminal. Okay, so let's perform some kind of operation here. So first do terraform init. So it will initialize all the resources. You can say it will initialize the backend. So what is our backend? Our backend is AWS. So it has taken the AWS API, or you can say plugin, which is already provided by the HashiCorp. So HashiCorp is a very good organization. Like they are having a good packages like Packer and Console and these all like Console and HashiCorp Vault. So in a similar way, they have created AWS plugin, and you will find the same thing in when you are using other cloud providers also. Then we are going to do another command, terraform plan. So this will plan whole hour. You can say this will create a general plan, like how our plan look like. Like you go to the grocery store, you write some kind of a list like these all things I want. So to plan these all things, we are having, you can say, we are having terraform plan. So it will plan all the resources, each and every resources onto our system. So it will create one kind of a list. You can say it has created a kind of a list. Like you need IPv6 address count, you need IPv6 address, security groups. We don't know, we do not have set the security groups. Then we need some kind of a tags. Okay, it has taken the tags because we have mentioned in the ec2.tf. Again, it has taken some kind of all the things which we want, with general things which we want, like availability zone, ID, public DNS. Okay, so now let's see, perform terraform apply. So let me clear this whole terminal. So let me clear this. Then we can perform terraform apply. So terraform apply will apply these all resources onto the cloud. It will apply all these resources onto the cloud. So let me do that terraform apply. So now let's see. Now you can see what all is going on. Okay, so press yes. Okay, now it is creating the EC2 instance onto my AWS console. So we are going to see that how is it created or not. So it is creating. So let's wait for a while. Okay, so here you can also see, and it will also output all the things like IP, DNS, and these all stuff which we have written into the output.tf file. It will list all these things at the end of this process. So let's wait for a second. Let it be created. Okay, cool. It is created. Apply complete, resource added 1, 0 change, and 0 destroyed. Availability zone, US is 2C, and this is the ID, this is the machine ID, this is the public DNS, which you are going to see, and this is the public IP. Okay, so this is how it has created all the resources. Now let's move to our EC2 management console. So let me refresh this. Okay. Okay, you can see that. You can see it has provisioned my EC2 instance using Terraform apply. You can see this. You can see each and everything. We have added a public IP. We have a public DNS name, which it has output onto the terminal. Now here it is named as hello world. It has initialized. So how cool. You can initialize more than n numbers of instance onto this. You can initialize any number of instances onto this, and you can initialize any resource. Let's say you want to provision, you want to create some kind of a CDN, content delivery network, using CloudFront. You can even do that easily. You can easily provision these all things. Like you can create a CDN cloud content delivery network using CloudFront, and then what you can do, you can connect with the route 53 and get your some kind of a domain name and connect with it, and you can deploy your own website easily. Now at the end of a day, let's say you want to destroy this instance, so you can easily destroy this instance using a single command. Let me show you. So let's clear this out. So you can do that using Terraform destroy. Terraform itself is a big automation. You can say it has it is being used by most of the companies nowadays. Now it has a competitors like industries are also using Ansible, but you can do the same thing with Terraform, but in a much better way. So it is refreshing its state. Now you need to just enter a value of yes, it will be destroyed. Your whole infrastructure is being destroyed, which you have provisioned. This is not an infrastructure. This is just a EC2 instance. But let's say you have created an infrastructure and you want to destroy it, you can easily do that. So AWS instance.ec2 example, destroying, and it will destroy this. Okay, let's wait for a second. Okay, so till then, anyone have any question, they can raise onto the chat. So at the end, we are going to see your question. You can even drop any cloud native questions if you are having regarding to some contribution. So, okay, so it has destroyed our whole infrastructure. Okay. So let's see here. You can see it has destroyed our whole infrastructure. So terminated. Its state is terminated. So that the thing which we have provisioned is that it has terminated. Okay, so this is about, you can say, how we can automate Terraform. Now there is another way to automate the Terraform itself. Now currently we are using the Terraform to automate the whole provisioning of infrastructure. Now you can itself automate your the Terraform task. So for that, we are going to introduce our friendly component known as Jenkins. So what Jenkins will do, Jenkins will come here. He will say, write some kind of let me write some kind of a job for it. Let me write some kind of a script or a job for it. So you are going to write some kind of a jobs inside Jenkins, and when you apply this kind of a job, when this job is triggered by, let's say, some kind of a developer is sitting at the behind of Jenkins, he has triggered this pipeline, and once this job is built and triggered, it will automatically deploy all the resources to AWS. So it is also one of the kind of automating the Terraform. Now you can also automate the Terraform. Now in a similar way, we can also attach some kind of Ansible playbooks, and we can also work with the Ansible. You can have a multi-parallel pipelines, like two pipelines are running in front of them. So you can also add Ansible and anything like that thing, what you want, like just say to Terraform, it will do everything for you, from provisioning of resources to deleting and managing and building them completely. Okay, so this is how we have automated this whole process, like just introducing a Jenkins. You can even use any of the CI/CD tool. Let's say you can add GitHub Actions, or you can add Travis, any of this tool here to automate the Terraform itself. So thank you for listening. So it's been a great to talk here and giving my views over how we can automate the Terraform. So thank you everyone for listening. Now it's time for your question. If you have any question, Let me see onto the dashboard. So
Yeah. So I think we have currently one question. I think Shiva answered in the chat. Can we
yeah,
migrate from one cloud vendor AWS to another cloud vendor like Azure using Terraform? And there is another question: what is advantage of Terraform over Ansible?
okay, so the advantage of Terraform over Ansible, in Ansible, you don't have some kind of a lifecycle management process. Let's say you need to update your resources. Now, you need to update your resources. You need to manage your resources in between when your resources are provisioned onto your cloud. So to do that, Terraform seems to be better option, a viable option to do this. Second thing, in Terraform is totally a different thing from Ansible. And you can use Ansible for performing, it is a tool for configuration management. And Terraform is a tool for orchestration. If you have ever seen about the orchestration, in orchestration tools like Kubernetes, Kubernetes is one of the container orchestration tool. So in a similar fashion, Terraform is also a orchestration tool. So you can use Terraform easily. Like it is a much viable option. You can do the same task. You can do the same task with Ansible, but there is some kind of a upper head when you use the Terraform. You can easily work around. Like you can just apply 2 to 3 commands and everything will be done. And the okay, so for migration, for cloud migration, yes, you can do that easily from using Terraform, very much easily. Just change the name there from provider AWS to GCP and change the resources. Like you want some kind of a in AWS we have Elastic Compute Cloud. In GCP we have some kind of a Google Compute Engines. So you just change the name of the resources. Everything will be same in the template. And just do Terraform init, Terraform plan, Terraform apply. Boom, it will be done. So any more question, Sangam?
So I think that there is like, do we need to provide account detail also? Yeah, we need to
Yes, yes.
provide details so it can create a resource on your account. So it's very informative, Ritesh, very informative for a beginner also, or those who wanna adopt or wanna create how to like create a resource, destroy, and it's kind of a one-to-one workshop you took in the short time,
Yeah.
and a really great presentation. And looking forward to your next meetup. So Ritesh run one of a kind of a community, Guna CNCF community. If you wanna present anything, and he also maintainer of a portal. And if you wanna start your contribution to the CNCF project, so you can reach out to Ritesh for any kind of help you need. So he is very active in the community. So do support Ritesh.
Yeah. So we are having a session on getting started with service meshes tonight at 7 p.m. So
Yeah.
I will just drop a link in the chat after
Yeah,
this talk.
you can. Yeah. So
Yeah.
people can take a benefit.
Yeah. So we are having one contributor from layer 5, Meshri. He is Shivai Lamba. So do connect with him and you do join our today's talk.
Yeah.
So it's been great to
If you wanna learn like another service mesh kind of thing, so
yeah.
Mystery is one of a tool, open source tool, and there is so many people, and even web developer and a different kind of developer can contribute to it, not only Golang or specific. Do join the CNCF Guna this new meetup. So we have a next speaker, Jaideep. So he
Bye
run
everyone.
the yeah. So we have a next speaker, Jaideep, on screen. Yeah. So he's on mute. So let's wait for 2 minutes. Yeah.
All
Hey,
right.
hello. Hey,
Hey,
sorry for
thanks, Sangam.
yeah,
Oh,
you're watching the full episode, and thanks for spending your time with us, and looking forward to your session. let me
Sure.
add your screen. Yeah.
All right. Okay. Thanks, Sangam. Really appreciate. I hope like people are up after a post lunch on a Saturday. My screen is visible, right?
Yeah, it's visible, and we will share a link in the community so people can watch more
Cool.
like sessions.
All right. So, okay, I'll be talking about my experience of moving from a traditional continuous deployment pipeline to GitOps with Flux V2. Now, GitOps, we have heard it multiple times. Neha and Shubham covered it. Sangam also covered it. So it is a new, I don't know, should we call it a buzzword? But yeah, it is a new word that people and wondering that what exactly it is. It was the same story for me as well, like what the heck it is. So I'll tell you about my production experience of actually operating on GitOps and how we moved away from a traditional continuous delivery pipeline and the tool using Flux V2. About me, I am co-founder at One2End Consulting. We are into back-end reliability, infrastructure, engineering, and what One2End Consulting is primarily into back-end and site reliability. What we really look and thrive is to actually from shipping code to running things on production with best practices. So you can talk about availability, reliability of the systems that are, of course, these are the words that are thrown, but it takes a lot of time and toll to reach there. So yeah, that's what I do at One2End. Yeah, let's begin. Well, this is a typical deployment pipeline looks like. Everybody wants to, go through the process of having all the neat and the very purest process to actually deploy your code to your environment and infrastructure. Well, now this I found it funny that at the end, if it doesn't matter if it fails or passes, you just go ahead and deploy, right? So yeah. So what we will be doing today is I'll set up a high level of expectation, what it is, an overview of GitOps. We'll compare with a traditional CD pipeline. Use what Flux CD V2 and the toolkit it actually offers. Why we choose GitOps and Flux. We'll tell my constraint. Maybe it may work or it may not work for your use case. Of course, a demo. DevOps India conference cannot go without a demo. What are the challenges with GitOps? Right. So, what is GitOps? We have heard it multiple times in a day, but I'll repeat it again post lunch. So, GitOps is a term that is actually coined by this company called Weaveworks. They are the primary folks who coined this term GitOps, and also the project Flux came from them. Well, in GitOps, you actually start treating your source of truth as your Git repository. So everything that is there is part of code. Now, infrastructure as code is something that has become a very common practice, that you operations people and operations team actually write their code and push it into a Git repository, and that becomes the de facto source of truth. So everything is actually around that. Declarative provision of manifest. So all our manifest YAMLs for be it Helm or Kubernetes manifest, they are actually or for say example your Terraform code as well is actually declared is in a declarative format. So there are the software agent who are actually responsible for the reconciliation for what is actually running on your production or your environment, and what is actually part of your Git repository. These agents are actually responsible to ensure that the state is maintained at any given point of time. There are alerts that you can actually have on the state divergence, that in case if there is any kind of a state divergence that has happened, like, look, I want an 1 + 1 and you have a 1 + 2. So we need to go back to 1 + 1 again. So, it will say that, no, look, you are right now not on 1 + 1, you are now on 1 + 2. Changes are all observable in Git history. we can see all the commits and logs can be there, and you can find like who pushed what and what happened. Well, the operations are actually done using pull request or merge request. So somebody in your team can actually have a look, like, look, this code looks fine to me. This is tried and tested. All right, let's merge it to the main branch, right? So I'll start comparing this with a traditional CD pipeline. Now, if you have a look at this, this is the first challenge that I'll throw. That right, you have this is a very simple, very high-level diagram. So you have developers who has access to the code repository. They are pushing their code, and then you have your continuous integration pipeline, and which can actually access your code repository, right? And it does all the magic of running the test, linting, validation, and then generates an artifact out of it. Well, that artifact is something can be a Docker image, and that can be pushed to a container registry, right? Now, once that you have that, you also need to actually deploy this. Now, when you need to deploy this, what you really need is some API credentials. So I need an API credential to actually push to my Kubernetes cluster. Now, the problem here is the moment you start doing this, you need the Kubernetes environment is running somewhere outside, and your CI/CD tool is actually running somewhere. So you are crossing the boundaries, and now actually started to access the Kubernetes cluster from your CI/CD system, right? Now, once you are doing this, what actually happens is that you have to share the credentials. Well, this may be a problem when you are actually working in a very fintech organization, or you are working in where there are strict compliance across cross-boundary credential sharing, right? So that's the challenge. What is the solution to it? Now, if you look at the solution, you said, yeah, look, everything looks okay. What I'll do is, instead of pushing it, I actually pull from it. So previously, the challenge was the push pipeline. The pull pipeline will say, okay, I'll take it from whatever I have actually inside my cluster, and I'll try to sync it with my GitHub repository, okay, for example, and it will actually pull those changes, right? So this is the desired state that you want is actually stored in the Git, and you pull it from there, right? Now, what's the second challenge? So monitoring actually systems of the deployments. Now, what happens is that from your CD system, yes, you can definitely, in a push-based pipeline, you can definitely go ahead and say, well, look, what I'll do, I'll probably just, keep on pushing it, but I really don't know what's the end state. Is it a success? Is it a failure? Probably I may or may not get an alert. I don't know what actually happened. I don't have that visibility. Now I'll have to go and look into the other system as well, right? Well, there's no denying the fact that you can't do this. Definitely from a push pipeline, you can do this. You can write up a custom code, but that will be a very tedious job. It's not a very first-class way of handling these things, right? So GitOps actually comes with its own monitoring, and majority of the tools, right? It is as a concept, it is part of it. It differs from a tool to tool, right? And it also supports retries. Retries is something that it caters to that. Okay, in case if it fails one or twice, I'll try it again. Why? The reason could be that there could be a network connection barrier, or services are not reachable. Challenge 3. Now, this is the most relevant challenge that I have faced wherever I have actually worked: cross-environment access. So think about it. Let's say pick Jenkins as your build tool as CI, and your deployment tool CI/CD system. Now, for your CD system to actually access it, it is possible that you'll have to do up a lot of VPC pairing between different environments, and that is a very overhead for the infrastructure and network team. They'll have to keep on saying, oh, okay, I need to connect this environment, that environment to my Jenkins so that I'm able to actually connect and actually do these deployments, right? So probably your infrastructure and network team is always like, with their screwdrivers, is always like patching things here and there, unless you don't have a very dedicated network and infrastructure team. But if you are working in a small team, it becomes very tedious and problematic. Well, since GitOps is a pull-based pipeline, you don't require no more cross-environment access, right? You don't need that because everything is actually part of your Git repository. That guy will pull it for you, deploy it, and say, yeah, I'm done. I don't need anything else. Challenge 4 is environment specific configuration. Now what happens is that, okay, if you have 3 or 4 environments, you have always sometimes a runtime configuration. Now these runtime configurations can be some secrets, some endpoint, some database endpoint. Now they can vary per environment. Now here's the thing, what you can do is that you can actually start making all of these runtime configuration as part of your Git repository, right? Well, other way, you can say that, no, why do I need that? I can actually put it in probably a console KV store, or I can actually store it somewhere in a vault as a secret manager. Sure, you can do that, but now that's again another tool where somebody has to go and populate that, right? So you have to start thinking that if I can actually keep everything in my Git, my state is saved, right? The state maintenance, which probably we heard in the Terraform talk. So that actually is part of the Git repository itself. So you start treating Git repo as configuration as a code, right? And everything is actually part of your Git repository. Well, other benefits, definitely it's a repeatable process, because now everything is part of your Git repository. Anybody in the team can start, actually whoever joins it knows it. Yeah, this is the code that how actually things are running on production. There is nothing that is a surprise to me, or there is a learning curve. That okay, this is the state what we have, this is the state that is actually running. I'll actually just pick it up and I'll be able to learn it easily. The chances of reducing human error. Why? Because now all your runtime configuration and everything is part of your Git repository. It ensures that everything is actually, the chances to actually alterations will be minimal. Not saying that it will be completely gone, but it will be minimal. And of course, Git is a tool which is widely used by tech teams and engineering teams, so they can actually operate on this existing knowledge. So they know what needs to be done, right? Why actually we decided to move towards a GitOps? So we were actually a small team of DevOps practitioners. Now what happens is that when you have a very small team of DevOps practitioners, or they are always one or the other thing. They are either plumbing something, either they are on call. And what used to happen was developers were always actually blogged on the DevOps team and wanted to deploy new images. They want to say like, okay, can you just deploy this? And they were shipping multiple times in a day. So think about it, that a DevOps team was started to become a blocker on it. Well, one way was to actually teach the devs to actually deploy by themselves, but not a lot of developers are in for it. They're saying like, look, I'm a developer, I have a lot of deliverables to do at my plate. I don't want to get into this. You take care of this part, right? Sure. So how do you do this? He said, okay, all right, how about this? If I actually if I set up something like a GitOps process, will you be more than happy to just operate on the Git knowledge, where we can also contribute? So it's a good way of a collaboration for both the teams as well. So yeah, fine, let's do that. So you have a PR based model structure that, okay, I want to deploy this Docker image tag. I want to just change the tag, push it to create a new branch, push it for a PR, raise a PR, ask team members like, can you review it for me? And then boom, everything is done. It gets deployed automatically. Last point was very interesting is security team had, as I said, that concerns of accessing Kubernetes clusters from outside. And they wanted like, because what we were working was actually in a fintech domain, they said like, look, okay, if you are using GitOps, I think probably we are more happy you using this, because then we can actually make not a Kubernetes cluster accessible from outside anymore. If you have to deploy it, you don't need multiple jump box and whatnot. You can say like, okay, this is configured. Probably I can actually pull it from my controllers will pull it from the Git repository. Right. Let's move towards Flux CD. If you have any question, do post it on that, and I'll try to address it at the end of the session. So Flux CD v2. So if think of it like GitOps is actually an interface. So Flux CD is a tool that actually implements it. Flux CD is one of the tools, by the way. Sangam already discussed at what all tools there are based on pull and push based pipeline, but I'll be discussing right now Flux CD because that is my experience as well of using it. So Flux CD actually offers something called as a GitOps toolkit. What they really believe in. V2 actually came out recently. I think it's been 5, 6, or 8 months at the beginning of this year. And earlier they were using Flux V1, which was more of a monolith, and everything was actually part of it. Now they've broken down into microservices where there are certain controllers responsible for doing individual things, and that we will be discussing in the upcoming slides. Now, GitOps toolkit is composable API for CD, so you can actually keep on building upon your CD system as well as in when you like, because they provide you the SDKs and everything. You can actually do that, right? It internally uses Kubernetes controller runtime libraries, and you can actually work with the Kubernetes events and create CRDs of your own, right? Besides what they actually have to offer, they are also responsible for reconciliation of the objects that you really want, because they are part of the Git repository in itself, right? What are the toolkit components? So there are 5 components majorly. There are, of course, in image automation, there are split, but we'll take at a very high level for the 5 components, what exactly they are doing. So first is the source controller. So source controller is like source registration, authentication, and resource fetching. So what they do is, what they do is actually, take up, probably you create up a GitHub token, they will fetch it for you. They'll actually fetch the resources and then sync it to your Kubernetes cluster. So the source controller can be anything like a Git repository or Helm repository or an S3 back packets, right? And they are primarily for the reconciliation of the source code. Customized controller. So Flux heavily uses customize to actually organize their directory structure. We'll actually look at it into one of the slides as well as a demo, that they have a customized controller where you identify resources like, look, these resources I really want to be synced and actually put to my Kubernetes cluster and deploy, right? So they generate actually these manifests with the customize, and they keep a watch on them. They also take care of the garbage collection. So in case if there are some resources which are not required, you can ask them to actually prune it, so they will actually clean it up for you. So if you remove some of the resources from the Git repository, they can actually, it will start reflecting to your Kubernetes clusters as well, right? You can definitely define specific pipelines that you want to run a backend first, and then you want to run a front end. And then definitely it also reports your cluster state changes to the notification controller. That's another controller part of the toolkit as well. So Helm controller. So this is something that I really kind of liked it, because earlier what we were, before moving to GitOps, we were actually using Helm charts, and we didn't want to rewrite. We wanted to reuse our existing Helm charts because it gives us the ability to do up a loose coupling. Now what's the benefit of it? The benefit is that we can actually use GitOps for a dev and QA environment. For a production environment, we will still deploy it manually, because for whatever reason, because we don't want to actually touch our production environment and get a surprise. So we said that let's us operate it. Because Flux was supporting Helms, that was like really good thing for that I personally like. It actually watches Helm chart object for any kind of a revision changes. It does an automated remediations that has to be done for the Helm charts. You can define the sequence of your Helm charts, that which chart should go first and which chart should go later. All of this was actually is taken care by the Helm control. It also reports Helm release status to the notification controller, right? So basically, notification controller is actually is the controller that deals with all of the incoming and the outgoing events that are required. So what it will do, it will create any kind of an event-based pipeline. It will keep on getting all these events and capture them. So and all the other controllers keep on sending these events to notification controller. Having, as I've said, that Flux support mostly a pull based pipeline, but with notification controller you can create a push based pipeline as well. How? So what you can do is on a you can have a set up a GitHub webhook which can actually point towards a notification controller, which can take it up and actually start up your CI/CD process as well. So if you want up somewhere an event driven thing from outside of your Kubernetes ecosystem, you can do that with the help of notification controller. So you can connect it with any ingress, and that guy can actually take up that event, listen to it, and then start up a trigger a complete pipeline as well. And based on the events, this notification controller is also able to send alerts to different channels. So we will be actually covering this in our demo. Right? Image automation controller. Well, this guy is responsible for scanning the image repositories. So if there are any kind of image updates that has happened, this will take care of what is actually coming in. So and it's also able to update the YAML files with new Docker tags. Of course, you can provide up a regular expression that this is the regex that I would want to take care of it, and it can take care of that. So it listens to your Docker registry as well, that what new Docker images have been pushed. You can definitely commit the changes to your and it can it will actually push the changes for you to the Git repository as well. So if I have to look into this is the actual diagram. This is from Fluxy docs. These are the this is the Kubernetes API. This is the source controller from GitHub, GitLab, Helm charts. And then source controller and Helm controller listens to it and says that, yeah, these are the new resources, and it will actually create it in different environments. Customized controller will look for any kind of a different resources that you have created and listen to the talk to the direct Kubernetes API. Right. Now, question is, why did you actually landed up using choosing Flux? Well, so this was a very specific use case and reason for you choosing Flux. The reason was, you can use existing Helm charts. So we can actually use Flux. We were able to use, as I discussed, able to use our existing Helm charts, and it gives us a loose coupling, and we just extended the GitOps-based solution on top of it. Right. Argo is another solution to it, but it was a very overwhelming component. Like we never knew that we would ever require to go to a multi-tenant kind of a system and whatnot, and have that kind of a granular control what Argo provides. It's like Argo is like the big brother of Flux. One really good part was supports SOPs. So what is SOPs? SOPs is secure ops, and what happens is that we were actually pushing all our secrets into the Git repository. Now you can say that pushing secrets into the Git repository is not cool, right? That's not a good practice. Well, what we were doing, I think Sangam also discussed this whole SOPs part for the security at GitOps level. So we were actually encrypting it using a asymmetric key pair, public and private key, and providing to our controllers like, okay, this is our private key. Can you actually decrypt it and apply these secrets onto the Kubernetes cluster? One part is the lightweight and less maintenance, very CLI based thing, very lightweight. You don't really have a lot of buttons to click, so you can never get confused. You need to just read the documentation. Flux supports monitoring with Prometheus, so that was one part that you can have a monitoring because it has a endpoint. You consume that scraping endpoint and actually put a Grafana on top of it, and then on top of it you can integrate it with a PagerDuty for an L1, L2 support in case if something goes bad. Because now you have an observability of what actually is happening onto your Flux series system as well. I would like to now actually look at the code structure directory, how it was. So this, if you look at it, that we had a deployment repository where all the infrastructure as code was lying. So what we had was like we had a state as GitOps dev. So dev had service 1 and service 2. right? It has all the config map, customization, release, and secrets. These are our Helm charts. So Helm charts were, the standard Helm charts that we were consuming it, and these were the Helm values. Now, if you look here, these Helm values are specific to an environment, for develop environment, for production environment, and for QA environment. So everything was actually part of the one single Git repository, but we had, because Flux supports, listening to a particular subpath, we were able to separate it out on or at Git level itself and Git hierarchy itself. So yeah, this is how the complete pipeline actually looks like. So there are those developers who are pushing code to the application repository, right? And then you have your Jenkins pipeline. This is a very basic naive test build, and pushing the artifact, generating artifact and pushing to a Docker registry. Now, what you have here is that you have your DevOps practitioners who are changing the Docker tags and config maps, and then pushing the changes to a deployment repository. Now, deployment repository is where the actual, the GitOps is implemented. So now you have this Kubernetes cluster, you have different controllers who are doing a lot of magic, and what they do is they actually pull the changes from this Git repository and then send the alerts, and then you give a notification. So yeah, this is how a pipeline actually looks like. So time for a demo. Am I still audible? I'm still still around. Sangam, can you just send me an app?
Yeah. Yes.
Hello.
Yeah.
Yeah. Okay. All right.
So do you want to take questions or direct demo?
Can I take the demo and then probably take up questions at the end?
Yeah. Yeah. Sure.
All right. Okay. Fine. So I am running on a kind cluster on my local system for now, and what I will do is probably I have my Git token, so I'll bootstrap my cluster probably here. Yeah. So I'll bootstrap. I've said that these are my components that I need to install. This is the path on which I would like to install. This is the branch, and yeah. If you look at it, the Flux system has actually started to come up. These are the controllers that have started to kick in. All right, now this is done. If you look at it, we have this. What we will do is look at our Git repository. There is nothing right now, and the controllers actually just push the Flux system configuration here. So what we will do is, I'll just remove my older one. Okay, there we go. Now we have this Flux system states and everything. Now we actually, let's do one thing. What we'll try to do is actually just configure our Flux system. Now I have created up already some setup. So first of all, let's actually go to GitOps Flux system GOTK sync. So this has the configuration about, let's say, even the Flux system configuration is part of your Git repository to actually reconcile. So I'll do some changes that I don't really want to do prune it, for example. So I said, yeah, okay, fine, right? That's one change. I'll apply another change as well. So I have my notification.yaml. As I said that we will apply some notification to actually start sending some alerts. Let's hope that actually works. We have the Slack channel, for example. So I'll say that, yeah, notification.yaml and say like Flux system, so that we can start receiving alerts as such. Now, if you look at it, the notification controller alert has been initialized here. Let's hope the endpoint is there and valid. Yeah. Okay. So this is how it looks like. This is the notification. I said that this is my channel, this is my address, and I want to watch on all of these CRDs. Right now, let me do one thing. let's actually push Git. So I said, okay, Git add GitOps flux system GPK for YAML. Git commit, I say that, okay, reduce the sync interval to 1 minute. Right? I say git push origin main. Yeah. Now, meanwhile, we have this. Let's hope it starts synchronizing in a while. Meanwhile, what we're doing, we will actually start creating up a directory structure, what we showed in this slide. So I'll do is actually create as I'll say helm chart sentence values here. All right. So I would like to show this the tree here. So what we have, so we have this GitOps for the dev environment. I just got a message. Now, what it did was it actually fetched the changes. It said that, okay, all of these changes are configured, and it identified in itself. Yeah. Now, next is what? Next is this is our tree structure. Now, what we can do is let's actually start adding services to it, for which we want to be deployed on our Kubernetes cluster. Right? So if we go here, there is GitOps, there is dev. What I will do is I'll have already created up a directory structure, GitOps dev service, right? And then we have customize these values. Just bear with me. I'll explain what exactly it is. So let's have customization.yaml. So customization.yaml, I'm saying that please have a look at this service one as a resource and identify, keep a watch on this. I would want you to actually deploy this, right? Now, if we go to this service one, what do we have? We have this customization.yaml. So customization.yaml is saying that, okay, this is a customization thing. This is a config map generator. This is like a one config map, which has all our, Helm values are actually part of it. I'll show you in a while what exactly it will have. And if I look at it, it says that, yeah, these are my Helm values, which we will be using just for the dev environment. And if you look at the release.yaml, so release.yaml has that, okay, this is my Helm release, this is my Helm chart, this is the source is my Git repository, name is flux system, and in sync interval is 1 minute. And the values are from this config map service1.yaml that we actually just created in the customization.yaml. Right now, what we will do is we have it. Now what we can try to do is actually just deploy this to us cluster. Git status, I'll say git add, GitOps, add everything here, git add and charts. Git commit add service one. I push my changes, that's done. Right. Let's actually wait. Update completed. Let's go here. Should have something in a moment. Yeah, let's wait. Meanwhile, what we will do is we will start preparing for an SOPs based of a demo. Okay, so Helm installation has started. If you look at it, this is running, right? And yeah, this is what we deployed, service 1.0.1 here. So this is a success. Now, what about some secrets? We discussed about SOPs part. So let's actually try to look at that as well. So this is a secret. Just keep a watch on here. What I will do is I'll configure up an SOPs at mine. So I'll go here, GitOps dev here. I'll create one file probably called as sops.yaml. I'll just paste it from here. I will. Now, if I look at this sops.yaml, what basically is actually a PGP key, which is actually part of my local system. Now, SOP support, you can use asymmetric keys. It can support Azure's KMS and Vault, so it can integrate well with that. So have a look at that project, Mozilla SOPs. Now, what I'll do is I'll actually copy my secret that I have already created. So I'll say that, okay, this secret.yaml to service one. Let's have a look. Secret. Now, this cannot be pushed, right? This cannot be pushed. How do you do that? So what we will do is we'll actually encrypt this. Now, to encrypt this, what we will do, we'll say that, okay, SOCKS encrypt in place service one secret.yaml. Now, if I look at my secret.yaml again, this is actually encrypted. Completely is actually encrypted. Now I have encrypted it locally. What I really need to do is actually tell my Kubernetes, Flux system, like okay, look, we have a PGP key ready, so why not? You should be aware about it. So how do I make it aware about it? I have some commands which are ready here, and I'll say that, okay, just create a first. This is part of the configuration, by the way. Here, the secret has been created, and I said, okay, Flux customization to blah blah blah. This is done. So if I look at it, edit customization Flux system, SOPs now, Flux system knows, okay, this is the provider is SOPs, and this is the secret reference that I need to look for decryption of the keys, right? Now this is done. What we can do is it is git add service one secret.yaml. Oh, before that, I'll have to tell my resource release.yaml, like, look, not release.yaml, sorry, customization.yaml, that you should also keep a watch on secret.yaml, which is part of your directory. I said, yeah, okay. So what we do now, we add service one customization.yaml and git add service one secret.yaml. Okay. Git status. We have two files. Let's say git commit add secret for service one. Git push origin main. Done. If you look at our Git repository, I'm right now, by the way, this model needs to be on a PR based thing. I'm right now pushing it directly. It should not be, it's not encouraged. If you look at it, there are help charts, GitOps dev, service one. I have the secret, and this secret is actually encrypted. If you look in the Git repository. Okay, now let's just wait. If you look at it, this secret has been created by itself. So everything is part of your Git repo, right? Now this is all of this is done. What we really need to do is say, okay, I want to actually upgrade from 0.1 to 0.2. That's what developers were doing. They said, okay, I want to go to 0.2. Here is the thing. So I'll say, okay, git add this, git commit -m upgrade service to 0.2. Git push origin main, and we should start seeing this should update in a moment, right? Yeah. Meanwhile, this is happening. So if you look at the Slack, there are some changes that has been done. Please apply your changes to the latest version. Let's see. If you look at it, the old version has been terminated, and now the new version has been applied here. Yeah. So 0.2, and I'll say that, okay, I want to roll it back. I say, okay. Revert. I'll say revert. So upgrade service 2 to 0.2. I can say Going back to 0.1. Did this git push origin me? Yeah. Now if you look at it, it will identify it. Because it's your rollbacks are also as an append only log. You just keep on incrementing. You can just do up a river as and when you want. So it started, and yep, we are now back to 0.1. Right. So this was the demo part. I'll actually come back again to my slides. So what are the challenges that I actually faced with GitOps? Well, Git is not actually designed for programmatic updates. Well, what happens is that if there is a Jenkins, which you want that, even these changes that are done by the developers or DevOps team push for, the dev config that we change, the Helm values, that has to be also there. You can do it, but you need to take up a lot of hit and tries, because there's a possibility that if multiple developers are pushing to the same Git repository, you may get conflicts and whatnot. So you have to, it's not very seamless. You'll have to work towards actually making your automatic part of it to capture all those hit and tries, that in case there are conflicts, merge failures or auto conflicts, whatnot, you need to handle that. That is a bit tricky and hairy. Maintaining multiple repository has maintenance overheads. So think about it, that if you are multiple developers who are working towards multiple repository, then creating Chinese wall becomes a problem. SOPs makes PR reviews inconvenient. Definitely, like you can't really see what exactly it is, right? So you probably will have to get the key and review it. I wish that if Git has this whole plugin to enable like some kind of an SOP. I wish. So that was really inconvenient. But again, that was a trade-off that we said, like, fine, we can actually live with it as long as our secrets are secure. These are the resources. We wrote a blog on this. So definitely you can actually have a look. Of course, GitOps.tech for documentation. Flux CD has really great documentation. And also, if you want to look more about GitOps, this is a really, really good book. I found it actually starts from a traditional push-based pipeline to actually moving towards a pull-based pipeline. Yeah, that is about me. And we are actually hiring and looking for reliability and DevOps practitioners and backend engineers. So if you are interested, feel free to drop a message. I'm more than happy to talk. Thank you. I can probably, Sangam, now take up some questions.
Yeah, so this time we have like question from one of a colleague who work at Accurics, and he's here in the backend. So he has like 3-4 questions.
Sure.
Have a check.
So
Hey,
how
Sam,
does Flux
thanks
compare
for
to?
Hey,
Hey,
sorry,
hi,
go ahead.
Siva.
Hey.
Yeah. So I think I can read it. So there are 3 questions. How does Flux compare to Argo? Well, as I said, that Argo is like the big brother. There are a lot of other capabilities that it provides, a multi-tenancy. Of course, Flux has also started to do that, but again, it's a third-party project. Not sure how integrating it in. Flagger also Argo supports control of AB and Canary and whatnot. They were primarily doing it, but Flux has recently started with the whole Flagger part in the project, right? So they are trying to catch it up there. In terms of if you are like a smaller team and not if it is a lightweight system, then definitely Flux makes more sense. Argo gives you a low granular control, like okay, do you want to deploy this? You want to go ahead and not? These are things that Argo provides. If that's my opinion.
Because I tried with Argo, but like based on the time I had, it was getting difficult to get that working to the way I wanted. Especially, I was not having access to state. Like that was my next question. Like, how do you manage state? Like, is there any way to expose the state in Flux? Some to a system like Prometheus or some kind of an API.
So is it to expose the application state? When you say the application state, basically understanding that is it successfully running or not?
successfully deployed or running? What is the current state?
Yeah. So Flux, as I see, actually very valid question. In case if it is failing for some or the other reason, it will not be able to tell you that. It will only say that, okay, if your Helm chart had some certain issues or Flux itself was not able to deploy that, then it will say, okay, it has failed, and then it will notify it on whatever notification channel that you have taken.
Yeah.
As such.
Because we are harmonizing around Prometheus and Grafana, like at work.
Yeah.
So I want to, we are also deploying custom metrics for applications. So I want to see if Flux can do that, right?
No, Flux probably its role ends up at the deployment part, and what actually, I mean, of course, it can tell you that your deployment was successful or not, or in such. But in case if there are any kind of an application level error, probably it will not be. I mean, I don't know as of now. To my knowledge,
I'm talking about the Flux level. Like, what is let's say it has 10 applications. What is the state of the different applications, and can I roll back to the previous version through an API, right? Not go into Flux.
I mean, you will probably have to write up some kind of a role controller, maybe not directly. I think it can actually detect it. Yeah.
Okay. And the other question I had was with Argo, the basic requirement is your Helm charts and the value should be in the same repo. Value should be at the root of the Helm repos, right?
Right.
So that kind of was a no-go. But does Flux have any similar
No, you can actually define up any path you will. Let me just share my screen. Maybe I can just help to answer this. Yeah. So can you see my screen, right?
Yeah, I can see.
Yeah. So if you look at it, these are my Helm values here in devconfig.yaml. This is for service one. If I go here and service one, open GitOps dev Flux system, not Flux system, service one, sorry. And then you have this, not release, sorry. Yeah. If you look at this file, I have identified this is where my file is. So I can define it at any path as I like and as I want, whatever the tree structure I want to maintain as such.
Okay, but can it also pull the Helm charts from another repo?
Let's say from another repo, it supports that. Yes, it can.
Okay. Okay.
And you have to just identify that. Yeah.
Yeah.
Oh, cool.
That was a good talk. So.
Thank you. Thanks, Eva.
Yeah, I enjoyed a lot. I don't know much about Flux, but I learned something today. I learned a few of the new
Glad you
GitOps tool like XLA. I know how to encrypt and all these things. I never play around Helm chats. But this is a great question from Shiva also. And there is another thing which I am very fascinated with. A lot of conversation is going around. One of creator of the Rancher and K3S, he wrote a library we send the read a data from Kubernetes controller, right? So you can do that with directly read and write in Git. So he wrote a kind of controller. So there is a lot of tool and so there is a lot of Git GitOps like Autopilot is there, Argo Autopilot, which help manage your
Verf is also there. I think some.
Yeah, that one also there. So there is so many GitOps tool.
With the whole GitOps toolkit, you can do that. Yeah.
Yeah, and by the way, if those who not using GitOps, not wanna use GitOps, they can use Spinnaker. There are other alternatives also, so they can do same kind of thing. But it's a great demo and totally demo oriented, and we talk lot about GitOps now in this conference. So let's move on to the some of the serverless
Too much
talk.
GitOps.
So we have
Yeah.
So we have Arif. He will be sharing around serverless. Over to you, Arif. Hey,
Hi, Sangam.
can
Hi,
you share?
everybody.
Yeah,
Sure.
Can you share a screen?
Sure. All right. Is that visible?
Yeah,
Okay.
it's visible.
All right. Thank you so much, Sangam. It's been an absolute wonderful day of learning so far. Really, really amazing speakers. And quite a bit exciting day all in all. So my name is Arif. I'm the CTO and co-founder of Metroguild Incorporated. I have also co-founded a think tank that works on social good. Beyond that, I'm also an AWS community builder, so an ardent Amazon fan. Uh, I'm also a full stack developer, spanning multiple years in the front end, in the back end, and have a special place for DevOps, especially with ISC that's come up. So that's what we're going to talk about today. I also advise early stage companies on technology, going from 0 to 1, 1 to 100. Now, today what we're going to talk about is simplicity, right? I've spent about 15, 16 years working in small and large organizations, extremely large teams to very small teams with a handful of developers. And it's very easy to make things complex, right? But it's very hard to make things simple. And in a recent challenge that we had when we were working with an NGO, we were tasked with building a platform within a short amount of time. And we'll go into details of those requirements as well. And there were certain choices that we made with the architecture. We made certain choices around the tech stack. We made certain choices around deployment. And more than a code or a tech success story, this is more of a DevOps success story, right? Because I attribute the fact that we served millions of people only because DevOps succeeded, right? And that's what I'm going to share today with you guys. Right. So what is it that we were building, right? So the NGO that I was working with, we had a handful of volunteers, and these volunteers were mostly people that were working during the COVID phase. They were working towards helping people, but they wanted a portal wherein they could share information, right? And in the middle of the pandemic, you guys must have noted there was a huge wave of lack of information on hospitals and all of that, right? And we were tasked with the fact that, okay, let's build something that can share information to people, to everybody, and to the masses, right? Not only to the people who knew how Twitter worked or Facebook worked and had technical savviness to go to all these portals, but something that the common person could use, right? From the get-go, we knew this was going to be a very large-scale deployment. So that means we knew that we were going to get immense load, right? A lot of load, and we wanted to be ready for that. We also had a lot of stakeholders. And by the way, the portal and the platform that I'm talking about, it's an evolutionary platform. So even though we started with focus on only sharing information, eventually we had a lot of people also giving us that information to be disseminated, right? So the number of stakeholders increased as the platform grew. And these stakeholders were right from villagers or the common person to medical professionals to people with information to other NGOs as well. We also had constraints around time to market, right? It's more of a business term, but what it meant was that we had very little time to roll this out, right? And writing the UI or the backend was not a hard problem, in the sense that these were already solved problems. We knew that the data existed somewhere. We had to pull it, and we just wanted to show it on our portal. And of course, being responsive and being able to work on mobile apps, on tablets, or on larger screens, right? So these were the constraints that we were sort of given, and we were only two people initially working on it, me and my co-founder who works on the design and the UX side of it. And we knew that we didn't have a lot of time to sort of build a lot of things, right? The other technology requirements or the data requirements that we nailed down when we were building this was that, first of all, very interestingly, for this particular use case, there was near real-time data that was being made available, which means this was not like a ticker tape information, stock market or Bitcoin or anything of that sort. We knew that data had to be updated because people had to look at it very quickly, but not in real time. So that means the data could be delayed by 5 or 10 minutes or 15 minutes, right? We also needed to support different media types. So we had to show information on the portal, which was video, there was informational videos, there were posters, images that people could print and put them on in their office spaces or at their, in their communities and all of that, right? There were audio podcasts that were being made available, and the portal also had to make sure that it got uploaded to it, right? So obviously we had instead of small information, we also had large files that we had to upload to our infrastructure. The third requirement that we had technically was the most interesting one, right? It was multilingual and regional support, which means that we had to provide a way that the website could quickly get translated by many people, could not use any of those, standard translational tools that you get in Django or Node.js or, those translation files. We had to basically change the content and change the translation based on the region we were going into, right? And eventually we covered up to the 70% of the country, right? So we went about 8 languages, and I'll show you around that as well. The updates came up intermittently. So the updates that we were getting were in short bursts, right? Sometimes we'll get a lot of data, sometimes we won't get data for a day, right? So let's say in some regions, we were getting information literally by the minute, but in other regions, we would get data in once a day. So we had quite a different and a myriad ways of getting information. We also needed to capture analytics, how this portal was being used, that is which area or which particular hospital or which particular information was getting a lot of attention, so that we could feed this back into the stakeholder. And we could tell them that, look, this is where people are focusing on. Let's try and put some more effort over there, right? More volunteers could be brought in over there. Then we had multi-device and bandwidth support restrictions, right? So one of the requirements was that we needed to support 2G, 3G, right? And that also kind of made the architecture a little bit different, and we wanted to make sure that all of this gets supported. And finally, we were told that the data needs to be accessible by third party. So whatever information we have, whatever we collect from these various sources, others also wanted to use it. And we were supposed to be ready with the fact that anytime a third party could come and say, hey, give me all that information via an API, right? And the last and the final bit, which of course changed the entire approach to how we were doing things, was it had to be cost effective. Because initially we were funding it ourselves, and then later, more parties got involved. But initially we knew that we couldn't run a highly reliable, distributed, extremely resilient system in a very cost-effective way, right? And that's what sort of kept us up at night. So what do we actually look when we started looking at alternatives? That okay, how could we solve this problem in a very quickly, right? Keeping all these requirements in mind. And the first thing that came up is a three-tier architecture, right? You just have a front end, your back end, your database, and your standard architecture, which basically solves all your problems. And it's time tested. Everything is fine. The reason why we didn't go for a three-tier architecture is because we just thought that there was too much lifting up of the infrastructure in this case, right? And we knew that since it's only a couple of people doing this, we didn't have the bandwidth to sort of bring all this infra up and maintain it and ensure that you have replicas and read replicas and you're replicating the data so that it's highly available, right? So we kind of knocked it out in the first go itself. The second was we thought, let's go with a low-code or a no-code platform, right? So there are several of them. In fact, a lot of the other platforms that came out during the COVID time used low-code and no-code platforms. The challenge was that low-code and no-code have a low barrier to entry they have very few tiers. Like the free tier is there and all of that. But eventually, once you start getting a lot of traffic, the cost grows exponentially. And it was very difficult for us to even enter a low-code platform without having used it first, right? So there was a promise of success over there, but we didn't quite see ourselves convinced that it could work. We also looked at these if this then that kind of models that could help us build this website or this portal using data sources like very well known as Integromat. There's also Zapier and all of those that could pull data from various sources, and that could work. But again, due to lack of understanding of these systems and a little bit of lack of faith in those systems, we decided not to go for them as well. And then finally was WordPress. You can't miss WordPress though. If you're building a platform, you have to talk about it. So WordPress was something that also came up, that it had all these plugins and everything, and it could just work out of the box. But again, it's something that we weren't really well versed with, and we felt that it has its own issues that we didn't want to deal with. So what is it that we ended up building, right? So before we come up to the actual architecture, this is what the UI looked like when we deployed it, right? So the COVID information portal actually ended up growing more than we ever anticipated, right? And it was a bittersweet situation because the people were suffering, and we hoped that this platform wasn't used as much as it did. But we also know that people who really needed it, they could get information on their fingertips, right? So we ended up building this platform that could collect data about beds, plasma, antigen, ambulances. All this data was coming from government sources, volunteers, our own endpoints that we had built, and we eventually supported 8+ languages, and we covered almost 70% of the country, like you can see, right? We literally covered entire states, and in some cases, major cities to show this information. Now, what was the final architecture that we ended up building, right? So all of this was done being cloud native. There was not a single deployment that was done using a server or an EC2 instance or anything of that sort, which was just mind-blowingly amazing the way it scaled, right? Because like I said, initially, even though we started by saying, let's serve a particular community or just let's serve a particular city at that time, because of the explosive growth that we got, not just in terms of the visitors, because eventually we reached about 2 million+ visitors in a matter of 6 to 8 weeks. We also had an explosion in terms of the data sources, right? So all of this, because we did not use any instances, any sort of underlying infrastructure that needed maintenance, it just worked extremely well for us, right? And that is where the simplicity came out, right? Because we used Lambda, and we'll go over the infra architecture top to bottom, and we'll break out some pieces also. The whole idea was that we captured the information from the origin databases. These were the databases, various sources from which we could get data from, right? These were actually hosted MySQL servers outside, Google Sheets. There were people who just dumped CSVs for us, or there were other government portals that we had to scrape data from in some cases. All of these origin databases rapidly grew over a period of time, right? And the layer that actually pulled all this information was our pull Lambda fleet, right? So this fleet of Lambda servers were completely based on ISE, right? We built the entire infrastructure as code. And as you have seen throughout the day, and especially the last session that you saw, having infrastructure as a code really gives you that repeatability of deployment, right, that we needed. We always knew that if we deploy this code, and we used a CDK for this, again, being an Amazon person, and Amazon themselves helped us quite a bit. Having the ability to use CDK or to codify the entire infrastructure meant a couple of things, right? One, being a developer myself, it was very easy to manage and maintain. I didn't have to go to the console or get into the CLIs of any sort. In fact, hardly used any CLIs, which I guess most of us should think about. And everything was a single, deploy click, and later we in fact moved to code pipeline. But the idea was that it gave us that repeatability, right? It gave us the ability to go to multiple regions at that time. The second thing it did was the fact that because it was codified, adding a new region, adding a data source was not writing more code. It was simply adding more, elements into an array and saying, okay, you got Pune, Bombay, now I just add Hyderabad, right? And your entire code was absolutely written to, have for loops over it and basically deploy new Lambda fleets as required, right? So those were the Lambda fleets that really managed and pulled all the data from these data sources. We eventually did not use a database, right? Especially for the read path. So this is where it got a bit interesting, is that one of the patterns that I actually am quite impressed with is the CQRS pattern, right? So CQRS basically has a different read path versus a write path. And because we were read intensive, we knew that the data is going to come slowly, or rather the data can come very quickly, but the updates can take some time. We did not end up writing all the data that came from Lambda into a database, not even DynamoDB, right? Because DynamoDB does have the resiliency, but we knew cost was going to get a little tricky, right? So we ended up writing JSON files on an S3 bucket, right? And then we deployed the S3 bucket and the code to a CloudFront server, and it was a React application, which was the front end. So your information portal that you see, and again, we'll break it up a little bit later, is the one that read from this S3, right? We also had an API gateway that was the write path. So this was completely different from the read path that you can see that comes straight from the origin database, going to S3, CloudFront, and then to the browser. The write path went actually through the API gateway and directly hit the DynamoDB, right? And did not have any impact over here. We also had reporting needs that we new stakeholders needed. So that was again a bunch of Lambda servers, a bunch of Lambda functions that actually polled the S3 server on a scheduled interval, aggregated that. We didn't have to use EMR at this because the data wasn't that big, and the Lambda's 15-minute runtime limit worked for us. And in fact, we broke it up in smaller chunks as well. So we didn't have to go with anything complex. We didn't have to do any complicated architectures over here. And the data would get just dumped into the reporting S3 bucket, which was again served to the other stakeholders via another portal, right? So we'll get into a little more detail on how this worked, right? So as I was saying, this was the origin database. It could be anything. We could add any origin point as long as we could programmatically access it. So we started with a Google Sheet. We ended up with CSV. We ended up with Airtable. We ended up with a database. We ended up with an S3 point as well in some cases, because there was a technical person who was giving us information. So we ended up pulling data from that as well. And the Lambda servers, the Lambda functions were basically done in Python, and all they did was pulled up the information, transformed it, normalized it, generated the JSON, and dumped it into the S3 database. The information portal was a straight short path, which was through CloudFront and coming through the S3 and back, right? What it also meant was the front end was basically reading the entire JSON and loading it in the client, in the browser, and then doing all of the processing in the front end, right? Be it filtering, searching, whatever you needed. We avoided any complicated stuff. And we had some intelligence that kept coming in from the analytics that told us, hey, people are searching for this kind of a hospital more often. So we changed the defaults when the UI loaded. So when the UI loaded, we would have certain filters that were already there based on your IP address or something like that, right? So that was all done very easily and quickly. This was the breakdown of the analytics flow, right? So the third-party clients that we spoke about that also needed access, the way they worked was they also hit the API gateway, and I'll explain to you why didn't these API gateways directly have access to S3 through CloudFront, right? Why didn't we just hand over a link to a JSON file that they could bypass the gateway? And we'll talk about that, right? But they went through the gateway and they hit the S3 and got their data back. And this was the same data that even the front end used. The analytics portal, which was basically when people clicked on the portal when they wanted to search something or entered a search term, that data would go over API gateway and went into our DynamoDB, right? We started with Google Analytics. We also investigated Hotjar. but the challenge there was that it just added a lot of weight to the front end, right? And this is not really a concern only for developers. As a DevOps professional, you also have to be very cognizant of this fact, right? That what is slowing down your front end and what can you do to improve it. So sometimes your vendors are at fault, like in this case, Google Analytics is the problem child over here. But sometimes what will happen is that even a new JSON or a JavaScript that you add, if you screw up the caching, then that will also cause a lot of downloads to happen, right, and slow it down. So we ended up doing our own analytics, which was basically just simple click tracking, and it would hit the API gateway and update the DynamoDB, right? And then even the aggregator would read the S3 as well as the DynamoDB to generate, the portal, the data for the portal. This is what the scrapers looked like when we ended, last month. So we had a whole bunch of scrapers that collected data for various regions. They spoke to several endpoints to get that information. Again, completely codified, a complete infrastructure as a code architecture, which meant that we had that faith that in fact, I remember that when we deployed the stack, in between, we had to get rid of the entire stack itself, and we were using CloudFormation. Because we were using CDK, it was very, very simple to recreate that entire stack, right? One thing that we did not do was, in the beginning, we did not use any pipeline or GitOps pipeline sort of a way to deploy code, because we wanted to control how data flows back in, right? So we had to do it at particular times. Even though we were committing code throughout the day, the deployments would only happen in the night, right? So initially we made sure that it was all manual, and we had to sort of go through our terminal and say CDK deploy, and all of these lambdas would get updated, right? Now, let's get to the other interesting part. Why did we use an API gateway for third-party clients, right? So one of the things that we needed to do was provide authentication, because what ended up happening is that a lot of clients that kept coming up at that point, and these could be, other people, it could be other NGOs, or it could be other smaller groups that are trying to utilize our data. They actually made us a proxy, right? So their apps would not have their own backend. They would simply point to our backend and say, hey, whenever you want to search or do anything, just go hit the ICR and infrastructure, right? Which we didn't really want at that time, because we were trying to save costs at that time. So what we did is API Gateway, which was an amazing construct by Amazon, and I'm sure there's similar for Google and Azure as well, provided an out-of-the-box approach to limiting, right? So first thing that API Gateway does, and again, all of this was done by CDK, so we didn't really go clicking around or doing anything. First thing it did is it gave us API keys. So we could generate API keys for our third party when they wanted to use an API. And also it allowed us to do usage plans, right? So API Gateway has this concept of usage plans where you can limit the amount of time an API key can be used and how many API calls can be made. Again, absolutely nothing that we had to do, right? We didn't even have to pay a lot for this. And the simplicity of this whole thing was so amazing that, otherwise I remember building this up in my earlier life where, had to do a leaky bucket algorithm. You probably had to fudge with Nginx. You had to do several other things to get this to work, or come up with another service where you had to, sort of proxy your data through, and all of this just goes away, right? And the interesting thing is that API Gateway has direct capabilities to connect with S3 as well, without writing a single line of code. So if you notice on the top right one, which is this block, the get method of this API connects directly to S3, which is just really, really amazing if you think about it, right? So I could put data into S3, front it with an API Gateway, do all this usage plans, and I don't have to write a single line of code, right? So that is why we went with the API Gateway, and it really worked for us. So coming to the final conclusions is that what did we end up, coming out with, right? We spent only about a month and a half on the actual MDP that was needed, right? So the minimum desirable product that was needed, it took us only a month and a half. In fact, the first 15 days was mostly research than anything else. It was just a month of actual code. And I would say 50% of the time went in the UI UX versus 50% went on DevOps, right? On fine-tuning this architecture, making sure that it was absolutely error-free, right? And according to me, I think every developer, be it a DevOps or a front end or a back end, needs to be aware of IST, right? Because it really helps you to understand how your code is getting deployed. We ended up reaching about 2 million plus visitors in I think it was about 6 to 8 weeks that we reached that mark, and it was just amazing. We didn't have any issues on latency. We had no issues on any downtimes or anything of that sort. In fact, we had zero downtime because there was no database, right? There was no database to deliver all this content. Everything was coming from S3, which is 11 nines or 9 nines, which is highly available. And we had no issues at all, right? Everything was deployed in AP South 1 region, which was 30 millisecond latency from anywhere in India, which is absolutely amazing. All of the services that we ran, be it Lambda, be it the API gateway or anything of that sort, were all under the free tier limit of Amazon, right? Which was just really amazing for us because we didn't have spending any money on the actual services itself. We had a huge bill on data transfer, right? And that is something that we couldn't have avoided, be it anything, right? Whether we would have had gone with the 380 architecture or anything. Data transfer is a fixed cost when it comes to these kind of services, right? We did end up caching and improving the caching and making sure that there wasn't a lot of data transfer. But because we had made that choice that when the person loads the data, when they load the portal, the entire JSON comes down. The JSON size, even though it was broadly compressed and we had on the fly compression going on, which is your standard browser compression, we still ended up paying a bit, and that was quite okay for us, right? We had zero downtime, like I said. DynamoDB was never in a critical path, right? So whenever we deployed any of this code, this infrastructure, there was not a single time when a DB unavailability was ever was a problem, right? If as long as the JSON was in the S3, the portal worked, right? There were times in the beginning when the JSON itself could be corrupt, but we quickly weeded that out, and therefore we never had any issues. Eventually, we went with code pipeline for everything, and that was again quite brilliant. Although CDK was underlying this code pipeline flow, so code pipeline was running actually a CDK pipeline, which we could run from our local machine. But at that point, we felt as more people started to join, we felt that we had to go through the automated deploy path, right? And we also had a lot of checks and balances that we were doing before code was getting committed and going into production, right? So that also eased a lot of things when it came to CIC. CDK is just amazing, just mind-blowing. We work with Pulumi as well, but at that time, Pulumi wasn't complete, I think, because we investigated a little bit. So we just went with CDK, and CDK just sort of eased us a lot of our issues in terms of actually managing the infrastructure. And to be honest, at one point, we didn't even need DevOps because everything was so repeatable. What were our learnings at that time, right? So once we finished this and we did our retrospective with the team and we tried to understand, okay, what went right and wrong. First thing is that complex is not always good, right? Throwing up an architecture diagram that has 50 different services, and you've got a mesh architecture that that basically seems like it's going to do the right thing is not always the answer. In fact, so I remember that we spoke to one of our advisors on this, and he said, "Are you sure it's going to work? Because you don't have this and that, and where are all the complicated services?" And we said, "No, it's going to work," and it actually worked, right? So there is this mental barrier that unless you have many services, it's not going to work. But I think the infrastructure as a platform, infrastructure platforms or platform as a service systems have come very far, right? They've made things very easy for us. Like we don't even, I'm sure a lot of you guys are extremely young and don't even know what I'm talking about, but we don't even talk about servers anymore, right? We are at a stage where people don't even know what a physical server is. And that's where all of these other services are moving also to, right? You might have a lot of systems that, provide security or resiliency or high availability. But if you look at this, if you break it down to first principles, chances are that you don't need that complexity, right? one of the things that we failed for us was caching, right? Because we were using JSON and for our data, we had a misconfiguration at one point of time where we ended up caching the response for 30 days. And that just killed 10% of our users, because every time the mobile browser would open up, it would just show the cache, right? And there was no way to kill it, because I think we were experimenting with web workers, and that kind of we didn't sort of see it through properly, and we immediately rolled it back. So we removed all our web workers and the whole PWA thing, and ended up fixing it. But yeah, we did have that initial hiccup, right? Does that mean that this is the right architecture for everything? No, absolutely not, right? We would probably rewrite this entire structure if there were a lot more right paths, right? If this was more like a traditional architecture where we had to have a lot of APIs that did a lot of CRUD, then this wouldn't work. It was this particular use case that 90% of the times we were only responsible for showing information, that this architecture really shined in front of everything else. It's like I said, it's an absolute DevOps success story, right? The code was very simple. It was just a front end that showed data and a table structure, and we used Bootstrap and all of that, your typical stack that is needed. The backend code was also extremely simple. It read data from sources and just transformed it into JSON, right? So I really never see this as a developer doing the right thing, right? I think it was the DevOps and the infrastructure that held up this whole thing together, and the scale that it managed is what really we feel was more important, right? Now, from the observability of the infrastructure itself, I think one thing that we learned is that initially we were thinking about, hey, we need this monitoring system, we need Datadog or Splunk or logs monitoring and all of that. And I have done that for a lot of my production systems, and I think it's warranted in those areas. But again, you need to rethink if you need all of that, right? Because we had a bunch of CloudWatch alarms, and because we were fully serverless, there was nothing to really monitor, right? Where if a function went down, or if functions don't go down, actually, I mean, if there's an error, it's probably your code that's doing something wrong. So a lot of this monitoring and everything else was really not needed, right? So we were very glad that we didn't end up building any of those monitoring systems or trying to make it a traditional app. So that also helped a lot. So it's very important that you try and not be reactive, right? That you're monitoring something and then you will take an action. In fact, if I were to replace the JSON with a DynamoDB, and if I wanted to auto scale my DynamoDB, I would actually do it with target tracking, right? Which is CloudWatch target tracking. So these kind of solutions where you are absolutely event-based, or you're absolutely proactive, that your CloudWatch is, or your alarms are telling you something that, hey, something is going wrong. You don't need a human to really get involved if you know exactly what's going wrong, right? Of course, there are edge cases and the unknowns out there that you have to look at, but generally you don't need all of this, right? So that was extremely good for us. That's pretty much about it. It was a great experience, and I think for side projects or projects that people are starting to work off, I would really urge them to look at do some lateral thinking, right? You really need to not just box yourself into some boilerplate or React starter kit, which has a MERN and those kind of stacks coming out of the box, and you've got Mongo running or something else running. I think the world has moved a lot ahead. Like I said, you really need to leverage all these serverless technologies that even, in fact, Amazon Aurora is now serverless, right? It's a MySQL database that's now serverless and scales based on load. So you really have to stop thinking about all these things, right? In fact, the only thing that you need to focus on is in your code, right? If you focus your energies on the business logic, the problem that you're trying to solve, and leverage all these other serverless tech, then things can go a long way for you, right? I'm more than happy to sort of answer questions. I'm available on my email. I also blog a little bit. So in fact, I've posted about this architecture on my blog as well, but more than happy to answer any questions as well. Thank you so much.
So there is a question from Jaydeep. How updated the origin database were?
Oh yeah, so it really differed, right? In some cases, we had to pull the data from the origin. So let's say, for example, I'll give an example, right? There was a volunteer group running out of Delhi with about 8,000 volunteers, and they were running only on Airtable. And they said that, look, we update data pretty much every day, all day, because we have so many volunteers. You need to pull that information on your own. So we ended up pulling that information from Airtable on a regular basis, right? And there were schedules. So these crons have schedules that you can set. You can say that this Lambda function will run every 5 minutes, every 1 minute, or every 15 minutes. So we did that, and in some cases the origins were very, very slow. Like, say, for example, I believe in one of the Gujarat areas, the data wouldn't get updated. It would get updated only once every 5:30 p.m. So there the cron was set for 5:45. So we had the latest data, but that data would only update once, right?
So hope that answered the whole question. If you have any questions, reach out to Arif on the LinkedIn or contact on email, and he will answer quickly.
Absolutely. Please feel free to reach out to me.
Yeah.
All right. Thank you so much. Yeah.
So we have a last session on CyberOps, and let me
Hi everyone, and welcome to my talk on cybersecurity operations. My name is Glenn D. Singh. I'm a cybersecurity instructor and an information security author. Over the next few minutes, I'm going to talk to you guys about the need for cybersecurity operations, or better known as CyberOps, within any organization. So you're probably wondering, why do we need cybersecurity operations and strategy? Cybersecurity is such a huge topic right now, and it's one of the most demanding fields within the information technology industry. To put simply, almost within every single industry right now, whether it's in manufacturing, even in healthcare, we need cybersecurity operations together with professionals, the people, strategies, the technologies. Each and every day, threat actors such as hackers are creating more complex and much more sophisticated cyber attacks. Therefore, cybersecurity professionals need to stop these attacks before they occur. So in other words, cybersecurity professionals need to step up their game to always be one step ahead of these bad guys, which is the hackers, the black hats, and even the insider threats. So by simply implementing cybersecurity operational approaches within your organization, security professionals are able to proactively stop cyber attacks and safeguard their organization's assets. And these assets, as we all know, could be tangible assets, intangible assets, and even our people. These people are our employees, together with our customers and any other stakeholders as well. So what is the need, or what exactly is cybersecurity operations? And this is commonly known as CyberOps. Cybersecurity operations contains 6 essential elements. These are understanding cybersecurity concepts, or generally security concepts. These also include security monitoring, understanding both host and network-based intrusion, and analyzing these intrusions to understand where the attack actually originates from. These also include understanding incident response and incident handling strategies, together with security management. So with cybersecurity operations, it's actually a combination of understanding the fundamentals of security concepts, such as security appliances, and how implementing these security solutions affect the security posture of your organization. Furthermore, understanding the need for implementing a defense-in-depth approach. A defense-in-depth approach simply covers implementing security to prevent any sort of entries within your organization. Furthermore, understanding how we can implement various security controls and how these security controls can affect various security restrictions between authorized users and unauthorized users. Furthermore, By understanding security monitoring, you can simply focus on grasping the key concepts of profiling traffic across various technologies. So you're probably wondering, hey, what are these technologies? Well, to put simply, we have security applications such as firewalls, and we need to be able to determine and analyze the logs and traffic patterns to understand what a threat actor is actually doing and where this traffic is originating from. This traffic might be malicious traffic, and what if a threat actor is routing their traffic across what we call Tor, which is an onion routing network, or through the dark web? Therefore, it's very important to understand how to identify potentially malicious traffic and actually trace the source of the attack. If you are able to identify potentially dangerous traffic, you can simply improve the security controls, your technologies, and even your security solutions to better protect your organization. If your technologies do not work properly, well, I'm not saying that they don't work properly, but what I'm saying is if these technologies are not configured properly, then they might miss certain types of cyber attacks. And because threat actors are trying to always be one step ahead of every organization, including cybersecurity professionals, they are always developing more sophisticated type of cyber attacks. Furthermore, taking a deeper dive into understanding cybersecurity as a security analyst, it is very vital. To put simply, once you're breaking into the cybersecurity industry, it's really important that you gain a strong and solid foundation on understanding the various types of cyber attacks, threats that exist within the industry. Even though each day or almost every other day, a new cyber attack is being discovered, new security vulnerabilities are being discovered, it's really important that a new and upcoming generation of cybersecurity professionals, whether you are going to be a penetration tester, incident responder, or even a security analyst, it's very vital to understand the characteristics of various types of cyber attacks. In other words, you are looking to actually profile these cyber attacks and catch these attacks as they occur to protect your network. So to put simply, by understanding how to identify both host-based and even network-based attacks, you're able to better protect your organization. Sometimes a threat actor may plan something what we call a bot, and these bots are designed to allow the threat actor to control your system and to perform malicious attacks against other systems within your network or even on the internet. So imagine that a bot is planted on, let's say, one of your critical servers or multiple servers, and without any sort of active monitoring solution within your network, or let's say you don't have anyone who's actively monitoring your network traffic, then your organization will probably miss the intrusion between the infected web server or the infected internal server and, let's say, the attacker's command and control server, which is on the cloud. So even though we are implementing security technologies such as firewalls, intrusion prevention systems, we also need the right people with the right skill set to actually do the human aspect of cybersecurity, which is a human aspect of doing the analysis to actually catch a threat actor and even mitigate these cyber attacks from actually occurring. While many persons want to start a career on the offensive side of cybersecurity, and I will admit, being on the offensive side is pretty cool because you get to break into companies' networks ethically, of course. And yeah, like think about how cool is that? An organization is hiring you as a penetration tester or even as a red team professional. You are getting paid to break into an organization by simply testing the security vulnerabilities of that organization. So in other words, you are simulating a real-world cyber attack. However, do you know that there's a huge demand for blue team professionals? So you're probably wondering, hey, what is blue teaming? Blue teaming, it's a side of cybersecurity which focuses on incident response and even catching the threat actors and preventing the cyber attacks from actually occurring. So within the industry, there's a huge amount of demand for blue teamers, or let's say blue team professionals. And these are the individuals who actually handle security incidents within an organization. If an organization is not able to detect, let's say, threat actor or a threat or any sort of cybersecurity event or incident within the organization, the threat actor spends a lot of time within the organization's network. Imagine there are many organizations that will take sometimes days to determine that their network is compromised. There are even some organizations which take even months to actually determine that, hey, their network is actually compromised. The longer an organization takes to actually identify their network or their systems are compromised, it means to say the longer the threat actor is able to spend time within that organization network, pivot their attacks, even perform lateral movements and vertical movements, compromise their, let's say, their domain controllers, even discover remote networks, exfiltrate data, and we all know that threat actors like to exfiltrate data and sell this data on the dark web. So without even monitoring or even having, let's say, an incident response team or even an incident response strategy, organizations are not able to properly defend against cyber attacks, and they are not able to actually remediate their systems and eradicate the threats. So when organizations take months to identify their network is compromised, again, the threat actor is spending so much time on your network. So it's really important that organizations have a cybersecurity incident response plan and even have an incident response handling strategy. This also means that an organization may need to implement various policies, procedures, and even create a dedicated team for handling incidents. Overall, having security management is very important. Security management isn't simply just a policy, but it's everything from the policies to the procedures to the people to even user awareness training and even managing the assets within your organization. Having proper security management ensures that, hey, your organization is able to protect its assets, the people know how to actually implement security solution, we have the right skill sets, and most importantly, we are trying to build a fortress to secure our internal networks from both internal and external cyber attacks. While many persons and many organizations may think that a threat or the cyber attack will originate from, let's say, the external network such as the internet, overall, most of the cyber attack actually occurs from within the organization. By simply implementing a cybersecurity operations strategy, you can even build a small security operations center within your organization once you have the right resources, skill sets, together with the right people. Just as a large organization will have a network operations center, which is a NOC, you can even build a dedicated security team, which is called a SOC, a security operations center. And by understanding cybersecurity operations, you will know that there are three main types of SOC. Each type of SOC has its advantages and disadvantages. So to put simply, I have written a book, and this book is known as a Cisco Certified Cyber Associate, the 200-201 certification guide. This certification guide focuses on understanding blue teaming strategies. It helps you understanding incident response, how to identify security threats, how to implement proper security controls, incident handling, and even understanding security operations center procedures and their techniques. This book actually is aligned to the Cisco Certified Cyber Associate official examination. And this examination focuses on, again, going into becoming a cybersecurity analyst, a security analyst, or even overall a blue teamer. It will also help you gain a strong understanding on cybersecurity operations, various types of threats and attacks, how you can use various technologies, even open source tools, to actually perform threat analysis and incident response. Furthermore, if you go through this book, you will be able to cover the fundamentals of understanding intrusion analysis and even performing network security as well. Overall, whether you're going into cybersecurity or not, this book contains a lot of valuable information for anyone within the IT industry. So let's take a look at the Cisco Certified CyberOps Associate examination page directly on Cisco website. So currently, we can see here that the Cisco Certified CyberOps Associate focuses on providing the necessary skill set for anyone who wants to go into becoming cybersecurity analysts and even working within a security operations center. It's currently just one exam, which is a 200-201 certification exam. So if you click on this right here, you will definitely be able to see the learning objectives. Please note that my book is actually aligned to each of the learning objectives for this examination. And whether you're going into becoming certified or not, honestly, the topics covered here is very, very essential and very vital for anyone who is within the IT industry. If you're interested in picking up a copy of my book, you can simply head over to Google and let's Google my name, Glendy Singh, like so. Hit enter. And here we can see there's an Amazon link. Let's click this one. On the Amazon link, you will see all my books that is available for purchase. You could pick up the Cisco Certified CyberOps book right here. If you're interested in becoming Cisco CCNA certified, you could also pick up my latest CCNA copy as well. And of course, I'm the author of one of the top selling Kali Linux book within the industry. So you could pick up my Kali Linux book if it is you want to learn about ethical hacking, penetration testing, and even how to discover and exploit various security vulnerabilities that exist within organizations and within systems. Furthermore, if you're interested in getting an ebook directly from PAC, which is my publishers, you can simply click the PAC link here, and this will carry you directly to my profile. So once you're on the PAC link or the PAC website, you can simply scroll down and add any of these books to your cart. So if you want to get my Cisco Certified CyberOps Associate book, simply click on View Details, like so. And now you can see where you could get just the ebook, you could subscribe, you could even see the entire table of contents of the book to get an idea of what this book is covering and whether this book is perfect for you. So I simply want to say thank you very much for listening to my talk. I hope it was really informative for you guys. Please be safe out there. I know that we are in the middle of a pandemic, so please be safe out there. Please ensure that you social distance. And I really hope this knowledge was informative for you. I really do hope that you pick up at least one copy of any of my books. I really do appreciate it. So take care, everyone. I wish you all the best. And again, my name is Glendy Singh, and you can also feel free to connect with me on any social media platform. So take care, everyone. And thank you again.
Hey, hello. Thank you for attending DevOps India conference. I would like to thank all the speakers for their amazing efforts. Without them, this conference is nothing. And there are like amazing talks today. Even I learned so many things. And we will continue this kind of free conference, maybe alternative month, or just join a Discord. And feel free to connect with each other and learn from each other. And I'm there in Discord if you have any kind of questions. So that's it. And thank you, all of you. Please subscribe to this YouTube channel for more update and support me to get 1K subscribers. Thank you. Bye.